everybody. My name is Darren. I'm with CalTrout. I'm one of 5 coordinators for today's workshop on integrated modeling for game changers in California salmon recovery. Thank you for being here. We're going to spend just a few minutes introducing our session today, introducing our workshop coordinators. I have a land acknowledgement that I'm going to read. I'm going to talk about the current situation a little bit with the federal NOAA employees, and then I'm going to introduce our moderator for the first session this morning. So that's what we have for today. If you didn't get an agenda, I have copies here, so grab one. A few copies left. I'll leave them over there in the corner where you can have yourselves. So again, my name is Darren. I've been working with Nate Mantua, David Boughton, and Eric Palkovacs from NOAA Fisheries Science Center in UC Santa Cruz, and my colleague Jacob Katz on coordinating this session. We have, I think, a really good workshop today. We have just an incredible lineup of people representing many different watersheds throughout the state, working in salmon recovery, and so I think I'm really looking forward to hearing all the diverse activities going on. This workshop started when CalTrout staff took a staff retreat down to Pescadero last summer in August, and as part of our staff retreat, we visited the Southwest Fisheries Science Center, and we had presentations from Nate, Dr. Steve Lindley, and Eric.
Katie Kobayashi.
Katie Kobayashi, yeah, that's right. 3 presentations in the morning to all of our CalTrout staff, and one of which was Dr. Lindley's discussion of funding that was coming to the Southwest Fisheries Science Center to support modeling, to support watershed groups like ours throughout the state. This was very exciting and interesting for several of our CalTrout colleagues, and so we continued this conversation with our NOAA Fisheries colleagues through the fall, and ultimately arrived at this idea of having this workshop today. So that unfolded in the fall as a response to this presentation, and the idea that NOAA fisheries scientists who have been doing tremendous work over the last few decades has the ability and capacity to do modeling to support watershed restoration efforts in many different places throughout the state, depending on their capacities, of course, but that's sort of where this came from. During that tour, our staff retreat down in Pescadero, we heard from a gentleman from State Parks, Michael Grown, and he was just really a super fascinating guy. He's an archaeologist and historian, and he met our staff out on our retreat tour and gave us a presentation on the Native American tribes, indigenous peoples of this region. I reached out to him last week and asked if he would help me with the land acknowledgement, and he did. And so I'm going to read you, to start off our session this morning, the land acknowledgement that Michael has sent to me. It's really good. I think it's a really great way to start our day today. So bear with me here as I read through this. We are gathered today in the unceded territory of the Awaswas-speaking people known as the Yupi, who stewarded these lands and waters since time immemorial. Despite the legacy of successive waves of Spanish, Mexican, and American colonialism, indigenous people persist in the region to this day and are working to restore traditional resource management practices, informed by millennia of traditional ecological knowledge. Of course, salmonids were and are important resources for the indigenous people of the Pacific Coast, and this place is no different. Archaeological evidence in the region demonstrates the harvest of coho and steelhead reaching back at least 7,000 years. Today, tribal peoples are partnering with resource management agencies and researchers to combine traditional ecological knowledge with modern ecological sciences to address the many issues facing salmon. For example, the Amamusin tribal band partnered with Sempervirens Fund to remove a dam along Mill Creek just a few miles north of the town of Santa Cruz back in 2022, and have been monitoring the creek in partnership with Sempervirens and researchers at UCLA using eDNA to assess the presence-absence of salmonids. The tribe also conducts an annual salmon ceremony near the river mouth of this creek to welcome salmon back to their native waters. It is important to consider not only the deep time connections indigenous peoples have with the land, water, plants, and animals in the places where we work, but their contemporary presence and desire to be involved in restoration. This can build partnerships in pursuit of mutually beneficial goals while providing more holistic and integrative research and outcomes for people in salmon. I also shared that land acknowledgement with our workshop coordinators, and David provided me a request to read another piece from tribal peoples, and that was a promise made back in January 23 to do so. And it reads like this. Our land was stolen from us, but we know it is not your fault. We do not ask for it back, but we do ask that you remember that you are the beneficiaries of that theft. We do ask that as you emerge from your home each day and place your feet on this ground, that you remember you are the beneficiaries of that theft, and you remember us, and you remember the Awaswas, who are now extinct. In this time, we must all work to heal Mother Earth. These are really nice things. So in our presentation from the NOAA Fisheries scientists, they talked about modeling and the importance of this kind of science that's been done and they're planning to do in the next phase of implementation. And it kind of struck me that we've had about 25 years of planning, design, implementation toward this endeavor of salmon recovery since the major listings that occurred in the late 1990s, right? And we've all been seeking that success, that sign that what we're doing is working. And it seemed like it was not happening. I feel like in my own personal trajectory through this, in the last decade, we're hoping, but we haven't seen very much signs until recently. And I think recently we've started to see some places that are showing those signs of that investment that's been made over the last 25 years and showing promise that what we're doing or what we have been doing has been working. And I just wanted to reflect that in those 25 years, since those listings, it would be a whole different world if we didn't have the NOAA scientists at the Southwest Science Center and at our NOAA offices throughout the regions supporting these restoration efforts, right? It just wouldn't have happened. All of the foundational documents for population viability, all the recovery plans that have been prepared, all of the support that these staff people have given us, writing biological opinions for the restoration projects that we're doing, impossible without these folks. And I just wanted to acknowledge at the start of this workshop the importance of these scientists to the work that we're doing. And the hard times that they're experiencing from the federal actions that are going on right now. I think there's no world in which we've gotten to where we are today without their brilliance, their dedication, their years of hard work. And I just wanted to take this moment to thank them. I wrote a list of the people that I'm aware of in NOAA, in NOAA Fisheries that have retired already or are planning to retire, and I'm just going to read those names. Jim Simonday, Leslie Wolf, Justin Lee, Jeffrey John, Julie Weeder. This is virtually the entire leadership staff in the Arcata NIMS office, all gone now. Nick Easterbrook was a probationary employee working on our Elk River program, also gone. Steve Edmondson, Brian Kluwer, Lisa Van Atta, incredible loss of people who were doing such tremendous work for the work that we're trying to do. George Pest, Steve Lindley, who's here today, Eric Danner, Eric Anderson, Devin Pierce, I don't know these folks, David provided me these people, Jeremiah Oting, Anthony Spina. I also want to mention two more, one from Fish and Wildlife Service, one from the Forest Service. Connor Shea works in the Arcata Fish and Wildlife Service office. He's a geomorphologist and an engineer who's providing support, modeling, all sorts of capacity for some projects up on the North Coast. He's retiring. Josh Abel works for the Forest Service, has been helping our Potter Valley dam removal process. He's retiring as well. So I just wanted to take a moment to say thank you to all of you who are here and these who aren't for all the work you've done over the years. Really appreciate it. And so with that, I'm going to introduce Nate Mantua. Nate is going to coordinate our first session today. He'll introduce Steve Lindley and then coordinate the speakers for our morning session recipes for recovery. So thank you very much.
All right, yeah, so I'm Nate Mantua, co-convener, and I work here in Santa Cruz at the Southwest Fisheries Science Center. I lead our salmon ecology program in our Santa Cruz lab. And our first speaker will be my boss for the last 12 years, who has been with the Science Center for 28 years, working on California salmon exclusively. And he came to this after studying biological oceanography, so a pretty big shift in focus. But in that time, his contributions have really been incredible. Starting with, as Darren said, all the listings and the technical recovery teamwork that went into developing the listings and recovery plans back in the 1990s, through the development of a really powerful science program that is a powerhouse, really, in supporting the work that you good people are trying to do in California. So with that, I'll introduce Dr. Stephen Lindley, the director for our lab, for another 2 days. He's retiring after the end of this month.
I'd like to thank everybody for being here, and the organizers. I think it's going to be a really fascinating day of talks and discussion. So Nate, Darren, David, and Eric, sorry for those of you who saw me give a related talk at the CalTrout visit that we really enjoyed. This will be pretty similar, and Darren and Nate have really covered a lot of the points I'm going to make, so I'll probably be able to make this pretty quick. It is I think a really good time for us to come together and talk about these things. I think we're going to be looking for some other people to kind of step up to carry some of the load that the federal government has been doing. I've been through at least 5 administrations. The winds of the federal government shift back and forth, and to make progress on these problems, you need a steady progress through all of that. After tomorrow, if you want to get some feedback here, if you want to talk to me about any of this, use my UC Santa Cruz email address. And I will respond to you there. The NOAA one will not work. So also, I'm just going to be talking about the role of science in accelerating salmon recovery. Science is a small but probably very necessary part of this, but it takes a whole lot more than science to make progress in these problems. So, getting feedback. There we go. Okay. So as Nate said, I've been at this for more than a quarter of a century. The salmon crisis, as you all know, has been unfolding really since the arrival of colonial Americans on the West Coast, developing gold mines and forests and forestry and all of that. And people dealt with that for decades, really, just with hatchery supplementation strategies, which didn't really work out. And by the late 80s and 90s, the depth of the crisis was becoming readily apparent. Salmon populations were reaching critically low levels of abundance. And people started to sue the government to list these things under the Endangered Species Act. And this is when a lot of people came into NOAA Fisheries, people that are probably leaving tomorrow, with the status reviews for these things. I was involved in the Chinook one, a little bit in the steelhead one. These apply the newly developed principle of evolutionarily significant units to the problem of managing, thousands and thousands of salmon populations, each unique in a way, but that's just unmanageable at that level of detail. So this led to a listing of a lot of the evolutionarily significant units, which then kicked off a lot of other work about developing recovery criteria, recovery plans, the principles of viable salmon populations, the idea that focusing on abundance, well, that's what is alarming, but abundance declines. To reverse that, you need to think also about productivity, spatial structure, and diversity, some really foundational ideas that have withstood the test of time. Yeah, so an important part of all of this that you're probably familiar with are the recovery plans for the different regions of California as well as the Pacific Northwest that lay out often very long menus of actions thought to be beneficial for salmon. If taken, they're often prioritized as to like high impact to lesser impact actions. But nowhere have we really figured out like how many of those do we really need to do to achieve our recovery goals, which sometimes aren't all that ambitious in some sense, just to have a minimum level of viability to prevent extinction. And many people want more than that. They want healthy and harvestable salmon populations. But we don't know really what it's going to take. Those recovery plans and the list of actions have guided a lot of restoration spending. So this is just some data on the Pacific Coast Salmon Restoration Funding, which has been over $1 billion spent since this has been implemented. There are little dots on the projects. Probably many of you have been involved in one or more of those. The map is well covered in some sense, and $1 billion is a lot of money. And I think in the Columbia River and the Sacramento River Basin, similar orders of magnitude of money have been spent there on things that are, meant to help salmon in some way. The accounting can get questionable, I think. But nonetheless, a lot of money has been spent, yet no ESUs have yet been delisted. And there is this sense, Darren alluded to, that, I've been told maybe recently people were wondering, is this even working? Are we having any progress here at all? Certainly, I think people were hoping we'd be delisting some things by now. So one of the fun things I've done recently is work with some of the folks in this room and Mike Ford at the Northwest Fisheries Science Center to look at the status coastwide of all the Pacific salmonids after a quarter century. And we have found actually that if you look at the listed versus unlisted ESUs, the listed ones, and that's the upper thing here, Chinook, Coho, and Steelhead, the trends in abundance for listed ones are higher than in the unlisted, and they're generally positive. So that's some actually pretty good news that's not commonly understood. This is a paper that should be coming out. It's in review now, so hopefully soon. But that's the good news. The bad news is that in California, when you look at that versus the Pacific Northwest, California is not seeing this effect at all. It's maybe not surprising. We've been through a millennial level of a drought. Most of the last decade has been extremely dry, and we all know salmon don't thrive under dry conditions, especially when they're exacerbated by the warming climate and human demands for water. So we're generally seeing, California is not responding as much as we'd hoped. So with that kind of backdrop, in 2022, Congress passed the Inflation Reduction Act, and the science centers were basically looking at their portfolio of science actions, trying to think about, what can we be doing better to have the most impact to improve the performance of salmon populations. And we produced some strategic plans. You can find these on the web. I don't know if we're going to make these PDFs hopefully available to people if you want to find the links later. But you can download these plans. They were developed somewhat independently, although the scientists at the centers are talking to each other all the time. So it turns out there's a lot of similarity between these plans. And we have since sort of boiled that down into 4 major research themes. Mainly what I'm going to talk about today is this integrated model development. This is what we think is where we can have the most impact as scientists, is developing quantitative tools to predict how salmon populations will respond to complex, multifaceted restoration actions. It's something we've been working towards really for more than 20 years, and only now we really have the data and some of the modeling approaches. The technical aspects of this can be really difficult to do right, to where we actually have some working examples of this, and we want to have many more of those, so I'll get to that. Of course, as I said, these kinds of models need a lot of data, and we are investing in collecting some crucial missing links there. One, National Marine Fisheries Service, we're very interested in things that happen in the ocean where salmon spend much of their life. And our co-managing partners are often much more interested in things happening in freshwaters and estuaries, and we've done a lot of work there with them that has been super informative. But we're going to be able to do some things in the ocean ourselves with our university partners that are going to be helpful, because a lot of things happen in the ocean that can help or hinder what you're trying to do in freshwater and estuaries. We're trying to get more data on the efficacy of different kinds of restoration reintroduction of other recovery techniques so that we can translate plans for that into quantitative outcomes, like how much does the productivity or capacity of a habitat improve when you do a certain thing to it. And then our colleagues at the Northwest Center have a great capacity, or they did, I'm not sure where they're at with that, for looking at contaminants. They discovered the compound in automobile tires that's a problem for Coho salmon. They have a lot of plans for more work like that. So with these plans, we did direct $25 million to different places to help do this work over the next 5 years. And my strategy for this was to basically work with Eric to get this out the NOAA door and to the university where we can collaborate with them. And this so far has turned out to be a good thing, because other places in the government, we can't spend money anymore, we can't issue contracts, and everything is sort of gummed up. So this money that for the California part of the work is at the university. The people are working on these projects now, and this is going forward regardless of what happens to me. So that's the good news. And the core of it really is this idea of developing integrated models, and that this is sort of a nice diagram that I like the weaving of it all. We are trying to weave together many dimensions that go from the people to the overarching Earth systems and the different biological processes, how they affect salmon throughout their life cycle. This is very complicated, of course, because salmon have a complex life cycle. Human actions can affect them in different places and at different times, and those effects, if they're not lethal, can carry over later. And they add together or even multiply together in complicated ways that make it really hard to predict how any one thing is going to turn out for them. So we're trying to develop quantitative tools to do that. And just to give you a concrete example of where we made a lot of progress with this is the winter run Chinook salmon. And it's not accidental that we made a lot of progress with that. They were the first one listed. There's enormous amounts of data now available about winter run Chinook salmon, so they're very well studied. And we could develop a very sophisticated system of models to make these kinds of predictions for this population. So this is sort of really sort of at the speed of
Would it be helpful if I turn the thing down over there?
Maybe, yeah. Maybe it's going to be okay. I could probably just yell loud enough. Anyway, so these life cycle models really are a collection of other kinds of models, which include hydrologic models like CalSim, a water planning model that the state of California uses to operate its water management system, hydrodynamics models, habitat models, water quality models, and other things about behavioral and migratory patterns for smolts that integrate together into this winter run Chinook model. And this is its inset here is what the actual model has. And we've learned a lot from just thinking about this and messing around with this model. So it has the salmon life cycle, and what's unique about this model, or unusual, a couple things. One is that it has 4 or 5 different life history strategies, depending on where the salmon end up rearing, and they can experience obviously different conditions in different habitats, so like the Yolo bypass, or the delta, or the upper river. And then they go into the ocean where they're subject to harvest and they return. And the model is most sensitive to things that act on the arrows that all of the fish experience. So this number 1 transition between eggs and fry, the model is very sensitive to that. And this is, it turns out, is actually a huge focus of management for winter run Chinook salmon, because they live in the river below Lake Shasta, and the water temperature there is controlled by that reservoir, and unless it's not during drought, and then a lot or all of them can die from that. And similarly, all of the fish then end up out in the Gulf of the Farallones here, their early ocean survival, and they're very sensitive to that. So with climatic fluctuations, winter run Chinook salmon can go up or go down. Conversely, a lot of the things that are wrong with their habitats might only affect one or another of these arrows, and there are hundreds of things like that. And we can only expect a small response by addressing those individual things, as important as they may be. But that's one of the reasons why you can invest a lot of money and not see an obvious response in there. It's actually, I think, mathematically impossible, given the variability, to even expect to see that, unless you're working on something really big, like alleviating high temperature mortality of the eggs. So this, I think we're going to hear, is Alison Collins, is she going to be speaking later today? I think she was on the agenda earlier, but I haven't seen her yet. Anyway, We worked with Trout Unlimited, Renee Henry, and many other people to apply this model in a community setting where people came up with a variety of recovery actions that they wanted to test individually and in combination. And then they developed metrics of success. Along here, abundance and productivity, core replacement rate, measure of hatchery influence. And we could then run through, like, what are the effects on these metrics of these different actions individually, and then if you did them all together, what they call the kitchen sink. And there's actually enormous prospect for recovering Burgt salmon. If you could implement all of these actions, which are probably technically feasible, if not politically or economically palatable, you could get almost a tenfold increase in abundance of winter Chinook salmon from that. And any individual action has a much more modest effect on the population. I think this is what we're going to find from this kind of modeling. It's these portfolios of actions that can act synergistically that will really improve things. And we are going to be developing the tools. David Boughton's really going to be leading this effort to apply or develop these tools for many more ESCs of salmon, probably a focus on the Klamath, other Central Valley, fall Chinook salmon populations, and coastal Coho. But that's still open for discussion. So just to summarize, this is sort of where we're going, that we're developing these life cycle models. We're looking for partners, and that's why we're here talking with all of you to help us identify what kind of recovery actions are you interested in pushing forward, to develop different scenarios of potential actions that we might take in concert and understand how these come out in terms of their performance, and then communicate that back with you, kind of an iteration, so that we can guide our restoration actions and investments to be the most impactful that they can be. So thank you, and I hope to learn a lot more today about what has been working, because there are some success stories.
All right, good morning, everyone. Thanks for inviting me. I'm Jason Hwang with Pacific Salmon Foundation. I am your friendly neighbor from Canada, it's wonderful to be here. You might not appreciate this with your heads down working on all of the challenges that you have in California, but in the world of civilization, what happens in California has a broad resonance. It's not just what happens locally. I've had the opportunity to come and meet some of the people who are working here, Nate, Jacob, and others. And when we go back to British Columbia and we tell stories around what we're seeing in terms of the work that the people on the ground here are doing and the challenges they're dealing with, and if you think about it, when you live in British Columbia, looking at what's happening in California might be a window in terms of what's happening in the future for us in British Columbia. It might be a bit of a crystal ball. So we're really keen to see what's happening here. And when I've been learning a lot about the work that's been happening in the Sacramento, in the Yolo bypass, and in doing that we've had some exchange, and we've realized that some of the stories around what's happening in British Columbia might also be helpful and resonate in California. So I'm just here to tell you a couple of those stories, and I'm going to give you the quick version of them. What I should say to start is, our organization is based in Vancouver, British Columbia. I live in the southern interior in Kamloops. That's the traditional territory of the Tecumloops Teshwetmik. And I'm not going to be talking about stories from that territory today. I'm going to be talking about a couple of stories from the Okanagan, the territory of the Silk people, and from the Cowichan on Vancouver Island. And I'll get to that as I go through. Do you advance slides for me?
I can.
Okay. So just quickly, we've got a complex environment, much like you have here in California. We've got 5 species of Pacific salmon as well as steelhead. You can hit the next slide. And there's a lot of genetic complexity. We've got about 640 different conservation units, genetically distinct populations, over 200 watersheds, ranging from coastal to interior, relatively short streams, relatively long streams. So there's a lot of complexity, and probably much like you're working on in California, there is no, what's the answer that we can just do everywhere. Everywhere's got its own set of circumstances and challenges. Next slide. The state of our salmon is complex, but we've just done a summary, and about 70% of our populations are doing more poorly than the long-term average across the board. So we've got some populations that are doing really, really well. I just read a news article this morning saying that Fraser River pink might come in at the biggest number since 1958 or something like that. And so it's always difficult when someone says, how are salmon doing in British Columbia? Well, how many days do you have if you want us to walk through all 640 different circumstances? But the big picture is things are not doing well and the trends are declining, much like you see all along the west coast of North America for salmon. So next slide. So what have we done about this? We have been working with an Indigenous organization called the First Nations Fisheries Council. So two non-government entities, but we're very close in working with government entities and all kinds of stakeholders and technical entities to say, let's start talking about this and see what we can do to solve some of these problems, turn the corner, and start to find some ingredients for success. It's been a really important exercise, and it's something I'd like to emphasize is it has not just been technical people. It hasn't been biologists and modelers and researchers. It's been people who go fishing. It's been people who are stewards of the land base in some regard. It's been regulators. It's been community organizers and conservation organizations. So it's been this very broad-based exercise. And this is one way we could describe what we found for key ingredients for success. But if you hit the next slide, we are trying to learn how to tell stories, how to relate to knowledge in different ways. And this is a way of doing a workshop report done by a graphic artist who does a workshop storyboard like this. And they actually, it's amazing if you see this happen. This artist does it real time while you're in the room. And then at the end of the day, we ask the artist to come up and say, what did you hear? And then we invite people to add to their story. And you can look at this instead of like a nice little box on a PowerPoint slide and say, what are we learning? How do we look at what's happening with salmon in the area we work in and find some of these ingredients for success? You look at the roots of the tree, the idea that everything is connected. You see right in the middle of the storyboard the indigenous way of thinking around thinking about 7 generations of timeline, not just what are we going to do right now, but what's the long game. We talk about knowledge sharing, and there's thinking about things that we think about technically, like scale. How do we work at a provincial scale, a regional scale, a watershed scale? And I think as someone that I would say is probably near the end of a career journey, I've been trained in the technical world, but I'm learning more about the relating to the social world, to the other ways of knowing, other ways of seeing, and taking the time to relate learnings from a workshop session in different ways instead of your typical academically oriented PowerPoint presentation can be very powerful. Because when we take something like this out to community and you sit down in a room full, say, in a remote indigenous community, if I put up that previous slide, people will be checking their coffee and sharing a muffin. When I put this slide up, everybody starts looking at it. They're trying to say, what is the story here? So I would say how we as technically trained people tell stories is part of what we're starting to see as ingredients for success. We can go to the next slide. So now I'm going to tell a story about the Okanagan River, and I'm sharing this with the permission of the Silk people. My friend Carrie Alex, who gave me permission to share these slides, is someone I've worked with for a long time. She's based in Penticton, southern interior British Columbia. And the Okanagan River is a river that starts in British Columbia, crosses the border, and joins the Columbia River system. And it's one of our great salmon recovery stories in modern times. The next slide. Something that's important to understand is silk are salmon people. If you came to British Columbia today, you would think that this is not the kind of place you think is where you're going to find a lot of salmon. This is not ancient cedar rainforests. This is peaches and beaches. It's hot, it's dry, but the people there, the people who are from there, the silk people, have always been salmon people. And this is really important to understand. We think in British Columbia this is the foundation of one of our ingredients for success. Because what happens here is silt people don't change every 3 or 4 years. They don't get re-elected. It's not the Democratic silt people and the Republican silt people, or the liberal or the conservative. It's just the silt people. Always going to be there. They were there since time immemorial, and they will still be there since time immemorial, and they care about this place. And this is really important, because it gives you that stability, continuity, and that moral authority for leadership, as well as other authorities for leadership, that is really part of the story. Next slide. And I'm going to start with the result first. So in the mid-1990s, there were around 3,000 sockeye returning, the typical story of decline. The nation themselves, without actually government leadership, and I will say I worked for the government at the time, there was government resistance 25 years ago to their start of, we're going to recover the salmon. And the Okanagan Nation leadership said, we are going to do it, and they've been at it for 25 years. And the point of this slide is to say, they started, they've done a whole bunch of things, I'll tell you quickly what they were, and they had a return last year that was well over 500,000 sockeye come through the Columbia, and over 300,000 of them made it across the border to Canada. All from their work, and they've been at it for 25 years, and they're going to be at it forever. But this is probably one of the last places in British Columbia you would have said you're going to have a salmon recovery success story. And so I'll go through a couple of slides quickly here and tell you briefly what they did. So next slide. The starting guidance from the Indigenous leadership was based on a traditional story. You can look this up online, the story of how the coyote brought the salmon back. But the guidance from the leadership to their staff was put the fish back and put the river back. It wasn't, let's do a life history model, right? No, I'm not criticizing these things, but it's important to think about how are other ways of knowing? What are other ways of seeing? How can we bring those together? Put the fish back, put the river back. And the leadership said, over to you, staff, and go ahead and figure that out. So next slide. So what did they do? Well, in terms of put the fish back, they have started a conservation and rebuilding hatchery. This is not a production hatchery. They actually have a plan to ramp down production, but they're still rebuilding and expanding the range. And they've done work to improve passage over relatively small dams so that the fish actually have access to their range. So in short, they've gone through a 25-year exercise to put the fish back. Next slide is put the river back. This is a highly modified channelized section of the Okanagan River, but they've been finding the space they have to work. And they've also worked a lot on this fish water management tool that is really changing the game in terms of how the flows are managed to benefit fish as well as other uses. And it's removed some of the limiting factors that were maybe known somewhat, but were not being addressed. And they've been addressed in a way that has still met all kinds of other objectives. So they have gone through this 25-year exercise, starting at the resistance of government, but now with all kinds of people on board to put the fish back and put the river back. Next slide. Another similar story, and I'm just going to touch on this quickly, just to say there's not only one success story. There's not that many, but there's not only one. This is from the Cowichan River on Vancouver Island. This is more one of those places, rainforest, coastal river, where you say, oh, this looks like a salmon place. But even the Cowichan River was experiencing problems with their fall Chinook. And you could see the decline in the mid-2000s. It was crashing, and there was serious concern. But the Cowichan tribes and the Cowichan communities came together and said, we're going to do something about this. And they have rebuilt that population now. So I think for the last 7 or 8 years running, it's exceeded its conservation target, and it's been well into the kind of surplus productivity range. And this is doing something different than the rivers that are adjacent to it. So it's not just, oh, you're lucky and things are working. The rivers right alongside are not performing the same way. And again, they've been at it for more than 20 years on a comprehensive series of recovery actions. And they have goals like, we want to be able to eat the shellfish. That's the guidance from the Indigenous leadership. And then it's over to staff to figure out what are all the things we have to do to get to them. Next slide. And one of the key ingredients here, and the quote from Chief Seymour talks about it, is partnerships, and he talks about relationships and trust. and these guys have excellent websites, you can look all this up. But the idea of coming together, working on these problems, and taking a values-based approach is, I think, one of these ingredients for success. Next slide. So in kind of wrapping this up, this is a statue that's in the Okanagan. This is the coyote bringing the salmon back. Sorry, I have to turn my computer on here because I have a couple of quotes, I've got some summaries from my friend Carrie that I'd like to share with you exactly the way she gave them to me, because I think they're instructive. So the first was the value of Indigenous-led reconciliation. Going to a point I made earlier, these are people that have always been here, who will always be there, who aren't changing, and they provide that moral leadership, they provide that continuity and the stability. But in doing that, it's collaborative. It's not the nation saying, everybody please leave and let us fix it. It's everybody please come work with us. We'd like to do it together. There was a feeling to act fast from leadership, not to overanalyze, but to get started. And they use what she calls the chicken soup concept, dealing with multiple issues at the same time. So looking at flows, looking at habitat restoration, looking at the hatchery, looking at fish passage. It's work on all of it, and that's what their leadership wanted. And at no point was it ever about what is the value of these sockeye? Like, what's the economic value? Who's going to make money? Who's going to benefit? It was about restoring the fish because the fish had a right to be there, and because it was the responsibility of that community and that leadership to make sure it happened for future generations. So I think in terms of some summaries of what this means in BC, I see a lot of parallels from the work that I'm learning about in California, but it's about bringing people together, it's about staying the course for the long game, it's about blending the hard science that we do along with the community values and finding those solutions. And so I've shown you two success stories out of these 460 watersheds or conservation units, and 70% of our populations are in decline. So what we're trying to do now is work with these and a few other success stories and find these key ingredients for success in a collaborative way, and then set them up as kind of a model forward where we can start to get other communities, other watersheds, other regions working along the learnings and the models for this, because we don't expect to see a payoff in 5 or 10 years. We think it's probably going to be 20 or 25 years, like it's been with these models that we have for success. But if we don't start doing that in 25 years, we might not have a longer list of stories to tell. So I hope that's been helpful, and I think I probably went longer than I should have, but I'd be happy to.
So today I don't have a mathematical model to show you, but I do think we have a conceptual model of the recovery that's been working for us on the Oregon coast. So before I get started, you guys are stuck with me today, but I just want to be clear that this has been work that has been ongoing for a long time, for decades. There's been a lot of folks involved, many folks in this room, and it really takes a community to recover a species. So I'm just going to give you a brief background on Oregon Coast Coho, talk about some of the federal protections, the state regulations, the local habitat response, and try to wrap up with what's been working. So Oregon Coast Coho, OC Coho, is made up of 21 independent populations. It's ranged from Cape Blanco on the mid-south coast of Oregon up to the Columbia River. Prior to European arrival, it's estimated that 2.8 to 3.3 million spawners returned annually. And all of these populations have been affected by the combined effects of poor ocean conditions, high harvest rates, hatchery influence, and habitat loss. This is a figure I'll show a couple of times today. On the y-axis there, we have estimated wild spawner abundance. This is at the ESU scale, so aggregating all of those populations together. The x-axis is time. The dashed line is showing harvest rates, and the secondary y-axis there is the reference for those harvest rates. So on the left-hand side of the figure, in the early 50s, you can already see that the population, the ESU, was already affected. It's about an order of magnitude lower than it was prior to European arrival. We see a lot of interannual variation. Harvest rates were extremely high. They peaked in the 70s at just under 90% harvest rates, which seems crazy. Those high harvest rates also coincided with a pretty dramatic change in the ocean regime. Sea surface temperatures increased, productivity went down. Overall, the ocean carrying capacity just decreased. In 1997, the total ESU abundance had decreased to under 24,000 individuals. So again, very low abundance numbers here. At that point, federal protections kicked in. The ESU was functionally listed under the Endangered Species Act in 1998. The federal recovery plan didn't come out until 2016, but when it did, it identified reduced stream complexity, water quality as the primary freshwater limiting factors. Specifically, summer water temperatures and winter rearing habitat were most limiting. So what are the elements of a near-term scenario to improve the populations? The first was to work to overcome hatchery and harvest issues. State regulations kicked in. After ESA listing, the harvest rates decreased dramatically. The commercial fishery was closed. A freshwater recreational fishery was opened just kind of sporadically in years of higher abundance, but managed at a low harvest rate. Hatchery production was eliminated from virtually all hatcheries. Again, we have Coho smolt releases there in the millions on the y-axis. In the late 80s, we were seeing between 5 and 8 million hatchery smolts released. And that decreased prior to ESA listing, but the listing was really solidified that that was a need. The next element to improve populations was creating more high-quality habitat. And we developed a system called a Strategic Action Plan for Coho Recovery. These action plans were initiated in 2015, the year before the Federal Recovery Plan came out. Wild Salmon Center, in collaboration with the Oregon Department of Fish and Wildlife, NMFS, NOAA Restoration Center, and other partners, basically asked the question, what will it take to help to accelerate the pace of coho recovery in terms of habitat restoration? So these strategic action plans, or SAPs, they take this ESU scale recovery plan, kind of boil it down and synthesize that information to focus on single populations. And really, the ultimate goal of these action plans is to get away from the kind of scattershot, opportunistic restoration strategy to something that is addressing specific stresses at the reach scale. So these action plans, again, focus on a single population. They bring together all the local players who are working very collaboratively. We're working with federal and state agencies, local tribes, industrial landowners, basically anybody who has an interest in coho salmon recovery and habitat restoration gets a seat at the table. We spend 2 years developing a plan that's localized, it's flexible, it's science-driven, and two main components are to identify watershed-specific stresses and long-term habitat restoration strategies. These are strategies that will span about 20 years, and to identify short-term projects in high-priority focal watersheds. So when these SAPs are complete, all of our partners are working together cooperatively to secure funding and to fast-track the projects. So I'm just going to highlight a couple of the components of these action plans, the identification of stresses and strategies. So again, we work together at the reach scale, working in and looking at all of the habitat components that support coho. So we are looking at multiple scales, at a HUC 10 scale, identifying stresses, HUC 12 scale, identifying stresses, looking at main stems, tributaries, wetlands, estuaries. The next part is to map out restoration strategies at the reach scale that address those. So this figure on the right is showing the Coquille Basin. All of the squiggly lines there are different restoration strategies that the team identified, but we don't have enough funding or time to basically work everywhere. So the next step is to prioritize the highest priority subwatersheds. So each team develops a list of parameters in which to identify and evaluate the subwatersheds. And then we go through a process of ranking and prioritization. The figure now shows the highest priority subwatersheds in the Coquille Basin. And then we overlay our watershed strategy and stress map with the highest priority. So this becomes our roadmap over the next 20 years. These are all the places that we know that we should be investing in habitat restoration. So to date, we've completed 5 SAPs. We have 2 more in progress. We have funding secured for an additional 2. So far, Wild Salmon Center has been awarded around $21 million in funding to support these projects. To date, we have 66 projects that are either complete or in progress. We've got some metrics up there. Because we work so closely with the state of Oregon and specifically the Oregon Watershed Enhancement Board, there's a special funding that the state has set up called a Focused Investment Partnership, and it's for population and partnerships that have a strategic action plan that has been developed. It's a competitive process, but if you are awarded, it is between $11 and $12 million award over a 6-year period. So an additional $23 million has been awarded to our partners in the Coos and the Sayuslaw. So what are the elements of a near-term scenario to improve these populations? We are seeing a positive ESU response to reduced harvest pressures. This is the same figure here, but now the x-axis goes from 1950 to 2023. We see our high harvest rates, the decrease prior to and during ESA listing, and we see a pretty immediate ESU response to reduced harvests. We also see a positive ESU response to the elimination of hatchery production. In the decade prior to ESA listing, 7 of the 21 populations were considered hatchery dominated, meaning they had a high percentage of hatchery fish on the spawning grounds. We had another 6 populations that were considered wild at risk, just low abundance. And in the decade following ESA listing, we see a conversion of these hatchery-dominated systems to being wild strong populations, and that trend has continued over time. Now, positive population response to habitat restoration. I reluctantly put a big question mark up there. This is a tough question for us to answer. Disentangling the positive effects that we're seeing from hatchery reductions and harvest reductions, and ultimately, we just need more time to really be able to link the habitat restoration that we're doing to a fish response. We're hoping that we can get this as something that we can measure in about a 20-year period. Additionally, we need some finer scale monitoring of these populations, again, to try to link specific restoration actions to fish response. So what are the elements of a scenario for full recovery? We need a functional federal government with well-staffed agencies. I apologize. This is so much of the work that we do is in cooperation with scientists who have dedicated their lives to this work. We really need this. Continued coordination and collaboration between partners. And we're also able to use NMFS 5-year recovery plan review that identifies where the next round of SAPs will be implemented in order to improve underperforming populations. So this is a really good feedback loop. So I'm going to wrap up with this slide that helps me sleep a little bit at night. Out of the 28 salmonids listed under the Endangered Species Act on the West Coast, threatened Oregon Coast Coho is one of the closest to recovery. And with that, I might have a few minutes for questions, or we can just wait for the panel discussion.
Time for one question.
One question.
Peter,
Yeah, sure, I got a question.
I'm sorry, I was
Yeah.
playing to Peter. Ed, you're the next speaker, right?
Yeah.
Do I have yours sometime?
I give it to you.
Oh, yeah. Sorry.
Can I ask a question?
You have a question? After all, yes.
So you identified priority reaches, I think, for action, and I'm wondering if you can explain a little bit about how you prioritize those. In other words, did you select the most promising, or the ones that were, worst off?
That's a great question. Each of the partnerships that we work with, there's a self-directed sort of planning process. There's this balance between protecting the best and getting some ecological uplift. Most of the partnerships decide there are areas that we should not be working in, either because the habitat degradation has been so dramatic that the investment there is just not worth the money. So during this prioritization process, we end up doing a little bit of both in terms of protecting the areas, again, the highest quality areas, as well as looking at areas that need just that little bit of uplift. Yeah, you got it.
So we're going to talk about the 10-mile river watershed in Northern California. Okay, this is the microphone, sorry. Where there's been a ton of smallish recovery actions and restoration actions by a whole variety of actors over a long period of time that has all stitched together to result in really large-scale watershed level restoration. And we've started to see some early indications of recovery, which is super exciting. So next slide. So the 10-mile watershed is on the northern Mendocino coast, just north of Fort Bragg. It's a pretty small coastal watershed that is the ancestral homeland of the Pomo and coastal Yuki people. It's a redwood-dominated watershed. It's got low gradient, broad alluvial valleys, and a whole bunch of characteristics that make it a really right place for restoration for species of coho, runs of coho salmon, chinook salmon, and steelhead trout. It's also really largely undeveloped. There are very few land ownerships. Over 90% of the watershed is basically a single timber holding, so it's managed for natural resource purposes. And then the entirety of the lower watershed is conserved through either conservation easements or fee title protections. It also has a really unique shape. If you look at that watershed, a lot of our coastal watersheds are oriented on a pretty east-west axis, and the 10-mile watershed is a blob. And as a result, it stays really foggy. It gets a whole bunch of coast fog influence. It's a really, really good redwood growth area. And it collects rainfall from a really wide geography, so we have really good in-stream flow that stays cool and running throughout the year. Next slide. But like all of our coast watersheds, it was heavily impacted during the advent of colonial settlers from America and Europe. Wave after wave of timber extraction occurred in the 10-mile watershed, including early logging, taking out basically all of the old growth trees, and then progressing through time, especially after World War II with the advent of tracked machinery, we really saw the scale of impact reach industrial levels throughout the watershed. Proliferation of roads, clear-cutting of entire hillsides. We also had a good amount of agricultural development in the lower watershed, burning of the river, converting these broad alluvial valleys into just single-threaded streams with high perched floodplains. And then in the 60s, we had a series of biblical floods. So we had clear-cut hillsides, completely denuded of vegetation, bare soil, and then huge flooding that brought all of that soil down into these valleys and completely buried them. So most of the valleys throughout the lower 10-mile watershed are buried in somewhere from 4 to 10 feet of sediment. So we have a stream and really perched floodplains. Next slide. This is you, Darren.
All right, so we've been, a little foreshadowing here, we've been seeing some really, really exciting population numbers in the last couple of years. So the historical estimates were from NG, around 1965, were based on red counts and estimating about 6,000 adult returns for coho in this watershed. As you can see at the early end of the figure here, in 2008 and 9, we were down to nothing. So the downlisting to threatened target from the recovery plan for CCC Coho is 1,850 fish. The delisting target is 3,700 fish. And in the winter of 2023 and 2024, the adult return was estimated to be around 5,500 coho, and that there's some debate between the folks who made these estimates. They're pretty sure the number is actually quite a bit higher than this. This was based on sort of their low end of their estimate. We don't have the numbers back for this last winter yet, but according to the folks who are doing the spawning surveys, they had a very similar experience this year to the experience they had in 2023 and 2024, where they were often unable to finish in a single day their survey reach because there were so many reds and so many carcasses to count. So we're optimistic about the returns for this year as well.
Interestingly enough, while we were sitting in the back, I shared this graph with Peter and Jen that came from an early recovery planning document, and it was saying like in about 75 years we should be at about this mark that we're at now. So, you know.
Well, doing this applause is just fine.
Next slide, please. Yeah, so the Central Coast California Coho Plan came out around 2012. And, you know, one of the immediate actions that were designated for the 10-mile within the early recovery planning documents was to look at opportunities to create and restore complex in-stream habitat, to restore floodplain habitats like alcoves, back channel, side channels, and seasonal ponds, and to, you know, put more wood, essentially, into streams. More recently, the 10-mile, and so anyways, these planning documents really guided a lot of the early recovery efforts that our groups have collectively been involved with. More recently, we, working with NOAA and with Cal Fish and Wildlife, we've been working on finalizing the recommendations of the SHARP planning document, which if you're not familiar with that, that's the Salmon Habitat and Restoration Prioritization Planning document. And in that document, some of the attributes that were identified as being the most limiting to survival are still very similar to the recovery recommendations in the 2012 plan, which included improving in-stream complexity, creating more off-channel and winter habitat refugia, and that was across the basin. And then in some of the areas within the 10-mile, they talked about also improving summer juvenile rearing as well. The attributes that were considered to be the least limiting were actually water quantity and quality, barriers, and sediment. So next slide, please. So this is a challenging image to see, and I do apologize, but this is a map of all of the restoration projects that have occurred that have been funded essentially by CDFW. So there are tiny little dots across this watershed, and I think the point that I really wanted to show, which maybe is a little hard to see, is just that these restoration activities have happened watershed-wide. There's probably around 40 individual restoration efforts that have occurred in the 10-mile watershed, and they date back to the mid-70s when they started a Chinook hatchery. There was a group called the Salmon Restoration Association that had a cooperative rearing hatchery. It was focused on Chinook. It did supplement a little bit of steelhead and coho, but I think it was really focused on Chinook. Then in the mid-80s through the mid-90s, there was a lot of stream clearing. And that was largely carried out by a group called the, and I always want to say their name wrong, so I wrote it down, Center for Education and Manpower, which I don't know how to get that wrong. It's like an incredible name, right? But it was a work development group, and I run into some of these folks from time to time. It's interesting hearing their stories. They didn't just do stream clearing, they did actually install large wood structures too, and I think for a long time I would see those in the watershed, and I thought they were old California Conservation Corps projects, but I don't think that they actually were. Then really in around 2005, the large wood loading work really started in the 10 mile, and that was largely led by Trout Unlimited. I think overall, well, this will be on another slide and I'll come back to it, but we started using this method called accelerated recruitment, or rapid recruitment, where we were just really trying to increase large wood density and to get as much wood back into these stream channels, and doing so in a way that kind of mimicked the natural ecological process. And I'll talk about that a little bit more in the next slide. There was, one second before you go forward, thank you. So there has been some other restoration work in the watershed, which includes some sediment reduction work. In 2001, TU, in partnership with Pacific Watershed Associates, did a watershed-wide assessment of sediment sources, where 350 miles of road were assessed. That included many stream crossings. We then, in 2001, did implement a road drainage improvement project in the North Fork 10 mile, which treated about 3 miles of the road network. But really, largely all of the road work that's been done in the watershed has probably been carried out through timber harvest practices and through regular operation maintenance of the timber companies that manage the watershed, because the watershed is probably about 90% in management of timber companies and is 99% privately owned, and even some of those private landowners have their own small timber harvest plans. And then beginning in 2012, you see a lot of the really excellent work that the Nature Conservancy has led with a slew of partners. I'll let you list all of them, and that's really been focused on creating some very complex habitat in the floodplains and estuaries lower down in the watershed. Next slide, please. So yeah, so here's where a lot of Trout Unlimited's work, the California Conservation Corps has also been involved with this work starting back in 2005. We think of the 118 miles of potential coho habitat, roughly 42 miles have been treated with wood. I would say there's a little margin of error there because there may have been a little bit of double counting because some stream reaches have actually been retreated, particularly in the South Fork 10 mile. So that's roughly about 35% of the watershed that's received some kind of wood treatment. Of those, I think of that 42 miles, about 89% of it was carried out by Trout Unlimited with our partners and with the timber companies. And it really was the first place where we started using this accelerated recruitment method in 2005, 2006. We treated 13 miles of the South Fork 10 mile, just direct falling trees into the channel, allowing them to do a lot of vertical adjustment, but using kind of soft anchoring by using the length of the logs to stay in position. We did go back and retreat that area around 2015 with the assistance of the Nature Conservancy, where we started digging out whole trees and pushing those into the channel, which was quite fun, I have to say. And even this past year, we went back and treated more of the South Fork 10 mile, because what we've learned is over time, all of these large woody additions have been very beneficial, but over time, we've just learned that we need to do more. So in that essence of go big or go home, there's still many areas that have been previously treated that could potentially be retreated, and we're looking at that quite a bit now as we move forward. Back to you now, next slide.
Yeah, so while all that work was being done in the upper watershed, TNC really kind of fit into our niche of focusing on the lower watershed. We knew there had been a ton of work on sedimentation, improving spawning habitat, improving summer rearing habitat in the upper tribs, and so we saw a gap in improvement of winter and spring out-migration habitat. So around 2012 or so, we started engaging in the watershed, working with landowners in the lower watershed to protect their land and put conservation easements over those properties that also provided us with the affirmative right to do restoration within the stream and its adjacent floodplain. And we used that as those land protection deals as the basis of a really big, long-running restoration program that has been ongoing since then. So once we protected the land, we set about developing habitat enhancement plans that were reach scale and identifying concept sites along multiple miles of stream and lots of acreage of floodplains. And then in 2018, we started moving into active restoration, bringing those concept sites through design, permitting, and then constructing them as rapidly as possible. So since 2018, we've built 4 large-scale floodplain and in-stream habitat restoration projects, basically trying to reintroduce complexity in these lower alluvial valleys where the streams have been so systematically disconnected from their floodplains. And this summer, we're building 2 more, so that'll bring us to a total of 6 projects, including the biggest one we've ever done. And yeah, we've enhanced over 23 acres of floodplain, almost 2 miles of stream with really large engineered structures, and just basically packed this landscape with root wads, logs, and then off-channel high-flow refugia opportunities for fish. Next slide. You, Karen.
One thing I'll add about the previous slide is there was a study done by Stillwater Sciences around that time that we started working in the watershed that showed that Salmon had about 5% of its historical overwinter habitat remaining. So that was the baseline. When we started this work. Sorry, next slide. Thank you. So another kind of key ingredient for success here is the partnerships that were involved. So this, the work in this watershed over time has had really significant engagement and support and partnership with agency staff, from engagement throughout the project design and construction process. We had technical advisory committees for each of the projects that Peter spoke to, and I believe Anna had input as well on some of the large wood projects too. So we had really significant engagement throughout the design and construction process, from NOAA and CFW, the Regional Water Board, and the CCCs provided a lot of support for implementation and construction for the large wood projects, the smaller large wood projects that Dan was referring to. We also had a lot of funding from both federal and state partners to implement this work. We had key science, and still have key science partnerships. So we're going to, I'll speak a little bit to some of the science work that we've been doing on the next slide. But we have academic partnerships with UC Berkeley and Eric at UC Santa Cruz, and engagement through the restoration process with a scientific review panel who has helped us design an experiment to assess whether or not these big floodplain estuary habitat enhancements actually produce more fish. And then over time, really significant partnerships with the landowners in the watershed. As I think Peter noted, almost all of the watershed is owned by one timber company, and that the ownership has changed over time from Campbell Hawthorne to Vine to now being owned by a Redwood Timber Company, but they've all been really engaged and supportive of restoration on that property. And then we have significant partnerships with the ranch land owners in the lower watershed, and that's through conservation easements on a couple of ranches in the lower watershed, as well as some other protection efforts. And our tribal engagement is increasing as well. We've been working with the Sherwood and Homo to engage on these restoration projects and provide cultural resource support before and during construction activities as well. Next slide. So a little bit more about the monitoring work that's going on out there. First of all, I just want to put in a plug for the California monitoring program for salmon populations. It goes without saying it's absolutely essential that that program continues, and we have concerns for obvious reasons about what funding or lack of funding to PCSRF might mean for the CMP, but the CMP has been an absolutely essential basis for helping to understand how these restoration investments might be affecting populations over time. Essentially, it keeps going. So in addition to the population monitoring work that's happening across the Mendocino coast, TNC and partners have engaged in a kind of more intensive activist monitoring program around the the restoration work in the floodplains and the estuary. And I won't go into details, but there's going to be a poster at the poster session if you're interested in talking about it more. It's been a Boughton experiment focused on changes to juvenile abundance, Coho juvenile abundance before and after treatments. We're in the 9th year of that part of the study right now. And it's been paired with some additional work using rotary screw traps and pit tags and antenna arrays to assess growth rates and residence time and survival in the restoration area as well. So that's in progress. We're towards the end of that investment right now. But as a ingredient for success, we think this is a really important part of it to provide the information that we can use as a feedback loop between the restoration and the monitoring and science work, and we're able to use that information to do adaptive management to projects that we've already implemented, as well as develop ideas about how we might want to change actions going forward.
All right, next slide is our last slide. So just, again, I should put this graph up there because I feel like it's kind of a mic drop for the 10 Mile River at least. I just want to shout this from the rooftops because it's a pretty cool story. But moving forward, I mean, I think we're all aligned on continuing to tackle the highest priority restoration opportunities in the watershed just to try to keep that trend line moving upwards and see if we can get to a truly sustainable year after year recovery in the 10 Mile. And I think we'll just quickly share each of our thoughts on how we get there moving forward. And for me, I think it's really important for us to continue a broad array of actors to continue implementing restoration spatially distributed throughout the watershed so that there's habitat available for especially Coho salmon to express this diversity of life history strategies that historically they would have expressed, and that will provide them with some resilience to the inevitable environmental shocks that we're going to have. I mean, there's got to be a drought around the corner. There's going to be really intense winters around the corner. Ocean conditions might plummet. So they're facing a lot, and if we can just provide them with enough high-quality habitat distributed geographically throughout the watershed, then we'll have a good chance of not just surviving, but also hopefully one day getting back to recovery and maybe in abundance.
Yeah, I mean, I think I kind of let the cat out of the bag as far as the next steps. I think that we still have a lot of work to do as far as like bringing some of the in-stream habitat complexity numbers up, but we have this watershed in particular, maybe more than others in the Mendocino coastal area, is a really special place, and we have had this incredible ability to really treat a very kind of evenly across the watershed many of the major tributaries that support Coho salmon and steelhead trout, and then to a lesser extent the Chinook. And I think that for me, one of the, it's a continued step, and it's just a testament to how this work works well, is that collaboration amongst partners. I mean, I think you can see it in testament to the fact that we're all standing up here together, and we work really closely with the landowners and with the California Conservation Corps and with all of the other agencies, and I don't see any way to have a chart look like this without that extensive network of partners working together on these kinds of projects.
Yeah, I don't have a lot to add except that I do think that a couple of points that I made are really important here, which are that these partnerships are basically allowing us to link the entire watershed and treat across the entire watershed, and to address the specific kind of key recovery actions, the highest priority things, and to go big on those big things.
All right, so we have one more presentation, and then we'll have a 15-minute break. Next up is Jacob Katz to talk about sharing Butte Creek.
Hey everyone, back at SRF. When we were thinking about this workshop, we were hoping it wouldn't be a workshop as much as a discussion. And when everyone's facing forward like a nice lecture hall, that's hard. The fodder for that discussion we were hoping would be these, they were called case studies. Maybe they're examples of the natural exuberance of salmon when a population can recognize what we usually call habitat, but the sequence of biophysical conditions at each life stage that allows that life stage to access the resources it needs to matriculate to the next, right? And so what we were hoping was to stop asking people what success looks like and start to ask the fish. And what did that mean? Where were we actually seeing along the entire West Coast population level response to conservation action? And so these first case studies were those rays of hope. The reason that we all do what we do. Because we believe in these fish. And we believe in the capacity of landscape to resiliently supply those resources again. And those fish to find them, to access them, and to show us the way. Like Jason, I'm going to be reporting on work that was not mine. Butte Creek in the heart of the Sacramento Valley has had an incredible array of champions over the last 30 years, and I'm going to tell you that story. So unlike the coastal streams of southern Oregon or the 10 Mile, and a little bit more like the Okanagan, Butte Creek is in the heart of a large river valley, an agrarian river valley, right? So the Sac Valley, of course, is one of the great agricultural landscapes on Earth. The valley's bounded by Shasta and Lassen up here, the volcanics to the north, the lowest part of the Cascades, the most southern part of the Cascades, the Coast Range on the west, and the northern Sierra on the right. And right smack in the middle of it is that little green dot. Maybe there's not a pointer on this. The Sutter Buttes, often referred to, at least locally, as the smallest mountain range in the world. And the creek I'm going to talk to you about runs right along the western flank of that little mountain range, fed by water coming out of the foothills of the Sierra, and flows down into the heart of the Sac Valley, right? So the Sac Valley, before it was this tapestry of agricultural production, was a mosaic of different wetland habitats. We tend to think of rivers as thin blue lines, right? But the Sacramento River Valley is an excellent example of a corridor of fish-bearing streams connected to a variety of different wetlands. Swim-through wetlands, I call them. Historically, fish, juvenile salmonids moving down this system would have had access to literally millions of acres of different kinds of wetland habitat. Those wetland habitats have left their mark in the very namings of the valley. They really define the Sacramento Valley. These words, Butte County, Sutter County, American, Calusa, these are the names that we give our political jurisdictions. Each one of those is actually named for the seasonal wetland that was there previously. The Sacramento River is flowing, at least from Chico, about halfway down the Sacramento Valley, all the way to the nexus in San Francisco Bay Estuary, on an elevated platform of its own creation. So there are, the high ground is the river natural levees themselves, often now covered by man-made levees, and the ground slopes away shallowly on either side until raising again on the foothills of either the coast or the Sierras. What that does is creates a shallow depression that would have been seasonally filled with water, creating vast wetlands that were unbelievably productive. The development of the valley is very easily summed up, right? Drainage. What once was a valley where, typified by water spreading and slowing, by the long-term residence time of water and landscape has been fundamentally changed by a very simple act, piling up dirt next to every single channel, right? As well as shaping the former wetlands by draining them, right? So a very familiar story, over 95% of those former wetlands are now rapidly drained. And that fundamentally changed the relationship, not just of river to landscape, but of fish to the biophysical conditions within that river channel, right? This thinking that fish belong in the river and the river belongs in its banks really typifies the idea of what a river is, at least in Western thought. And we're here today, I think, challenging that in so many different ways. And one of the ways in which that, I think, breaking of that conceptual model are the stories that are being shared about ridgetop to river mouth, approximation of the patterns of water interacting with the landscape through which that water flows. So the channelization of the Sacramento River led to an incredibly steep decline in all 4 runs. The Sacramento is the most diverse Chinook population on Earth. 4 distinct runs coming in from the salt at different times of year. That reflects the different hydrologies of the Sacramento River. You have a groundwater-fed hydrology that gave rise to the winter run life history. You have spring run that are really honed, created, evolved to surf the snow melt coming off the Sierras. The fall run is a rain-driven fish. I'm just throwing up the Sac Valley Spring Run Chinook here. They'll be the main fish that we talk about in Butte Creek. But the trajectories of the populations are all similar. Very, very, very steep decline. This, of course, reflects, this is from 1969, so it already reflects a, orders of magnitude decline from what was pre-development. So no surprise there. But what do the Sutter Buttes have to tell us? What does this small little mountain range with orchards on one side, row crops on the other have to tell us? Well, there's 2 other sides to this mountain range. Here you have the Sacramento River winding its way, completely channelized, steep levees on either side of this river, completely divorced from the wetland landscape that it once flowed through and that its fish had access to. And you can compare that to the route of Butte Creek coming through this. I know it's hard to see, but this is the Butte Sink, a wetland of tens of thousands of acres that is still managed to spread in slow water and has a fish-bearing stream, Butte Creek, going right through the heart of it. And as it comes around to the south of the Buttes, it goes down through a floodway, a engineered landscape designed to pass the highest floods in the Sacramento River safely around the high-quality farmland and towns. So a bypass, we call that. That's the Sutter bypass, that very rectangular shape below the buttes. This is what the Butte Sink looks like. Beneath all those geese, fish swim. Right? This is the agricultural landscape just below the buttes. The buttes themselves is kind of Valhalla for duck hunting. That is why it has maintained within an agricultural matrix a wetland semblance, right? That is to attract the ducks so that rich duck hunters, and these are the most prestigious and the highest value duck clubs in California, can do that. As a unintended consequence of that land use, we have one of the only landscape scale swim-through wetlands left on the West Coast that I'm aware of. So how these things unfold is always an interesting story. So as it comes out of those wetlands, it moves through another kind of wetland. This is 500,000 acres of rice are grown in the Sacramento Valley. Of all of California's crops, rice is really one of the only ones that is grown in a puddle that has water spread and slowed, right? That's what a wetland is. Well, here we have managed wetland-like conditions. So what happened in Butte Creek that, brought me here? Butte Creek's population, like that of the rest of the valley, had dwindled until the, in the early 90s, it was really just a handful of fish. But there was an anomalous event, right? So the community in Butte Creek and larger within the Sacramento Valley, and even assisted by the Metropolitan Water District of Southern California, all came together on a series of projects within the creek, projects that we'd all be familiar with. Some of it involved screening, ag diversions, some of it involved passage, but the real critical ones were taking out a couple small head diversion dams in the upper system that allowed the spring run to get up into holding habitat in the canyons. And that had a really, really dramatic effect. So here we had small dams taken out, something that we've all either been part of or dreamed to do in a watershed, but we had something very different happen when that action occurred. We went from life support to an incredible resurgence in that population. What's anomalous about that? These kinds of efforts, as totally admirable and laudable as they were, have occurred in other places, and yet the fish didn't respond. What was special about Butte Creek? Why did you get this kind of abundance so quickly responding to that conservation action? And I think the answer was right in front of us. We didn't understand it at the time, but Butte Creek is the only population of salmon in the Sacramento Valley that still migrate through an ecologically functioning wetland environment. It's impossible to overstate that fact. That the juveniles that are out-migrating in this population still move through a landscape they recognize, even if we might not recognize Sutter Bypass as functioning floodplain ecology. So what happens out on those floodplains? I mean, it's relatively simple, right? Sunlight is captured by either plants growing out on the floodplain itself in summer, or if I have to do this, right? So you have a small channel, right? The moment that water spreads out onto the landscape, you've increased that wetted area to actually capture sunlight in winter. So under flooded conditions in winter, you have phytoplankton and algae collecting winter sunlight in that very large photic zone compared to just the small amount of water available to capture sunlight in winter. But the big one is really the stored photosynthetic, the sugar, the battery of vegetation out on the fertile landscape, right? So that primary productivity, when a river floods, when water slows and spreads, that's the means by which the river ecosystem is accessing that stored solar power, right? And so microbial, bacterial, fungal communities make that sugar available to invertebrate and zooplankton communities. They, in turn, feed fish and other tertiary production, and very, very quickly, those small fish become bigger fish. Why is that so critical? Well, we just set out to look at this. So these are experiments that we did in the 2014, 15, 16, 17, just to the south of Sutter Bypass, in the Yolo Bypass, looking at the different aquatic habitats, looking at how productivity changes in a channelized river, in the canals, which really are the way that water flows across the landscape during summer, during most of the time in our very drained, rapidly draining landscape. And then just on the other side of the canals, in these agricultural fields which have the infrastructure, because they're rice fields, to hold on to shallow water, to create or recreate, to approximate the shallow, long-duration inundation that typifies a wetland. And what happens under those conditions if you put fish into those conditions? These were hatchery fish from the Feather River. The fish in the river under flood conditions is the best possible conditions for a young fish moving through the Sacramento, where there's actually a little bit of marginal habitat on the edge. Under those conditions, those fish grew almost not at all. The ones in the canal grew substantially more. You can start to see them grow in a little gut. This is just 3 weeks of growth before a big storm took this out. But those are the ones that were out on the floodplain. And why did that happen? Well, this is, I don't know why everything's blacked out up there, but these each represent a cubic meter of water in the Sacramento River itself. There's about 1,500 invertebrates in that cubic meter of water. In the canal, there's 6 times that, 600 times, 600% more. That's phenomenal. You understand why those other fish were a little bit bigger. But then you see the wetlands. 149x is 15,000 times more productivity. The fish, we are fundamentally changing the bioenergetics, not just of fish, but of the landscape, through the change of interaction between water and the landscape through which that water flows. What does that mean? It really means residence time. The water in the river is turning over every couple seconds, in a canal every couple minutes, in the fields every couple days, but historically those large basins, those flood basins for which the counties are actually named, would have been flooded for weeks to months, sometimes for the entire year. We have fundamentally changed the capacity of the Sacramento River ecosystem to access the energy which creates abundance. What was the one anomalous thing? Where is the one exception to that in the Sacramento Valley? Butte Creek. And that is the response that we see in Butte Creek when you actually have a functioning ecosystem at each, from ridgetop to rivermouth, through each life stage, right? This is the currency of salmon abundance. Those fish, this fish is 4 days younger than this one, but this is a fish that was allowed to be out on the floodplain for 6 weeks. This was just a representative picture. The first time we got a permit to tag fish from the Feather River. We were looking to get a fish big enough to tag. And we were there out in January 1st, oh, they're too small. January 15th, too small. February 15th, we are almost done with the summer. The fish hadn't grown at all coming out. Tens of millions of fish had come down the Feather River, but not a single one of them was big enough to actually tag. And we started to understand the difference. The fish were the window into the bioenergetic consequences of hurrying water off the landscape. So just leave you with that picture there, although I would say that's probably a better one. This is what fish that return to Butte Creek look like when they leave. Think about that when you think, when next time you look in your spool trap, next time you think about what out-migration looks like. Yeah, I already saw this. What I would like to say, I guess at the end, is just that this story's not over. It is terribly important to first see what is possible, even in the midst of one of the most intensively farmed and lucrative agricultural landscapes on Earth. You can get a very dramatic population level response. But it's fragile. The Butte Creek is also kind of at the heart of hydropower. It's one of the first places that hydropower was, where it was pioneered, and the obsolete infrastructure there is now failing, leading to erosion that when we were sitting looking at one of the great salmon success stories on the West Coast, and that stream was full of tens of thousands of adult spring run, and then this happens, and most of them die. Or water management decisions happen that put warm water through that system in a way that probably didn't need to happen, and we lose, again, all but just hundreds of a run that was thousands strong. All of that speaks to the need to make fish a primary reason for management, not an ancillary one. But generally, I think what we see is an incredible reason for hope. That if we can understand that each one of those life stages has a very specific set of biophysical conditions, a sequence of biophysical conditions that it's responding to, and that if it finds those conditions, it is going to move to that next life stage, dependent on another reach of that river, and so forth to complete that arc. And if we can do that, if we can allow salmon to recognize the rivers and watersheds that not just on which they depend, but the ones that forged them, that created them, that were the evolutionary crucibles to actually making this amazing life form. That's what recovery looks like. And I think that we're closer and closer to that kind of process-based understanding of recovery. So, thank you very much, and I would just say that there's a fantastic half-hour long video featuring Alan, who's in back, and others about Butte Creek that has been playing on PBS for the last year or so, and is a very worthwhile use of a half an hour. All right, thanks.
Our next speaker will be David Boughton, who works here at Santa Cruz with me at the Southwest Fisheries Science Center, and he will tell us about Carmel River and its steelhead.
With NIMS back in 2001, I've been working on various salmon things and steelhead things ever since. One of the first things I was asked to do was make the feedback stop. One of the first things I was asked to do was to chair one of these technical recovery teams for steelhead in Southern California, South Central California, and that was a very eye-opening experience because things were, I think it's safe to say, pretty bleak. Between sort of various interest groups claiming the fish wasn't even native to that area, to people working in other parts of the state kind of just thinking it was a lost cause. And I didn't really pay a lot of attention to the Carmel River for a while, which even though it was in my area, because people were already sort of avidly working there to restore the population. And it wasn't until maybe 10 years later, around 2012 or so, that I realized with my little brain that what we were hoping to achieve in a lot of these rivers in Southern California and some in South Central California, people had already been working on exactly those goals in the Carmel for a couple of decades and collecting a lot of information on it. And so I began to really focus on working with a lot of people working in the watershed and using their data to really understand how the population of steelhead there had been responding to all the things that people had been trying since about the mid-'80s. And a lot of what I'm going to talk about today, I can't take credit for. All I can take credit for is I've used this amazing data set, this amazing study system to try to understand how the population has been responding. And what's interesting about the Carmel is it is a working landscape. It's got a lot of agriculture, it's got chronic water shortages, towns, people, golf courses, all kinds of things. And it's got this river that for 30 years now, there's been a concerted effort to bring that river back, to bring its steelhead back. So that's what I'm going to talk about today. And since I could probably talk for 2 or 3 hours about the Carmel River, but I'll try to keep things simple and just talk about a couple of key points. So next slide. So here's the watershed of the Carmel River. Here's the Monterey Peninsula. It's just on the other side of the bay here from Santa Cruz. And mainly what I'm going to talk about today is this main stem section of the river up to Los Padres Dam, and you can kind of divide it into 3 what I call process domains. There's this, from this confluence or this area right here up to Los Padres, the river goes through a canyon section. Fairly confined channel, fairly steep, sort of classic mountain stream in a lot of ways. All this down to the estuary is an alluvial valley with a fairly substantial aquifer, or at least aquifer capacity. And there's a sort of narrow confined part of the aquifer about halfway up the river, surprisingly known as the Narrows, that sort of divides that aquifer into two sections, the upper valley and the lower valley. And next slide, please. So back in 1983, this guy, William Snyder, he was an employee, I believe, of the California Department of Fish and Game, did a sort of survey of the whole Carmel River and its steelhead, and this basically what he found is the only parts of the river system that still had surface flow due to development of water resources was this area upstream of a dam, San Clemente Dam, and some of the tributaries up in the sort of wetter portion of the watershed. There was a mile with sort of intermittent stream at this confluence at the head of the valley, but the whole rest of the river went dry every summer. And that wasn't a natural occurrence, that was because of the way water was managed at the time. Two aspects of the way it was managed was the dam, they just shut off water during the summer. And then there were groundwater pumps. The local water company has groundwater pumps all up and down the alluvial valley, and they just use the aquifer as a second reservoir. So it fills up in the winter with water, they pump it down in the summer, and as a result the stream dries up. There's a remnant steelhead population up here. There's a lot of the resident form, but as far as anadromous steelhead going up this river, it was a pretty bleak situation. So one of the first things that happened, and I won't go in part because I don't really understand it all, but there was a lot of wrangling about water rights and everything, but the bottom line was, so let's see, here's lower valley, upper valley, canyon section. So before 1991, this from here all the way down to the ocean dried out every year. They changed the way they were pumping the groundwater spatially so that they would try to keep more surface flows in the river. And this was the result of that. This is compiled from notes taken by the fisheries biologists at the Water Management District. And from that, we sort of reconstructed what the surface flows have been for the last 30 years as a result of this change. And of course, what you see is this whole upper valley section of the Carmel Valley is now a perennial stream. In wet years, the lower river also stays flowing to the ocean, but this is the part that's now used as a reservoir for supplying domestic water. This part, the aquifer, is kept full, and as a result, the stream stays flowing all summer long. And you see this one little break, but that's where there's this sort of geomorphic alluvial fan that just happens to naturally occur in this one spot near Carmel Valley Village. And it goes dry naturally. So it breaks up the continuity, but it's not sort of an anthropogenic thing. But you can see it does get bigger during this drought, the drought of 2012, 13, 14. Anyway, so that's one of the big changes. Next slide, please. And accompanying that was a lot of riparian restoration, active replanting of riparian. So these are a whole series of before and after pictures that staff from the Water District sent me to illustrate this point. This is what the river looked like in 1973. And so it's not, this is in that upper valley section. That'll be dry in a couple weeks as the water just percolates down the channel. So not only was the aquifer lowered, but they were also kept the river cleared with bulldozers because they were treating it as sort of a way to get rid of flood water. They weren't really treating it as a river. One of our speakers talked about put the river back, put the fish back. Well, here's what they've been doing in the Carmel Valley for 30 years. They've been putting the river back. This is what This is the same viewpoint today. There's a parking lot in Garland Park, but then you walk through that bunch of trees, and this is what the stream looks like. So that's pretty much the same spot 40 years later. Next slide. Here's another example near a place called Berwick. They used to bulldoze it. Even before they changed the flow patterns, they started replanting willows along the stream. There's what it looked like in 2002. Next slide. Here's another spot a lot of attention was paid to. Same story. If you put the water back in the river, if you raise the water table so that a river doesn't just become a perched infiltration system, you start to get the whole river system back. And I shouldn't say it just did it all on its own. They've spent a lot of effort planting these riparian zones. Next slide, please. Here's another spot, Carmel Valley Ranch. Here's one of these pumps positioned up and down the channel. That's about the same spot you can see from the shape of the mountains. That's what it looks like today. Next slide. And then something that happened more recently, this is one of the, there's two big dams. There used to be a smaller diversion dam, which is gone. And then this was one of the two big dams that was on the system since the 20s. And it was pretty much filled up with sediment, and it was one of the first big dam removals in California. Happened about 10 years ago now. Hard to believe. And the big problem, the big sticking point with this dam removal was all this sediment. The reservoir was about 95% full of sediment, and what would you do with that? Everyone was afraid if it all went downstream, it would wreak havoc on the communities downstream. So the design was to actually just sequester it in place, carve a new notch here, and this whole sort of engineered series of step pools that would allow fish to migrate upstream was designed. That was completed in 2000, I can't remember if it was 15 or 16, but within a year, we had that water year of 2017, and it completely rearranged that. And it was interesting seeing the response of people. Some people were horrified by this, but actually all the fish people I talked to were delighted by it. They thought that was the river coming back alive. And then this is what it looks like later. And I think I put these two in here because I thought it was interesting to see this riparian corridor just developing. Even though you had a multi-threaded channel here, now it's developing a single-threaded channel, but then we had another big water year, and now it's a multi-threaded channel again, both here and here. The river is a living river again, at least it seems like to me. And I should say this is kind of an unnatural situation though, because this is a gravel-bedded reach, but it's actually a pretty steep one. And because it's through the old reservoir sediments. And so it's still sort of an experiment that we're not quite sure how it's going to turn out. It might just cut down into all those reservoir sediments. We'll see. But right now the steelhead are going up it, and there's steelhead spawning in there. There's par rearing in there, and about the same densities as the rest of the river. So it really has sort of come back alive. Next slide, please. So success. One of the reasons that got me looking at the Carmel River, so let's see, I started with nymphs about here. And at that point it was sort of, wow, the Carmel, they started really restoring the river flows around 1990-91. And look at that response. But then this has been the course of my career, is like every year, it seems like the Carmel is doing a little worse. And then during the big drought of the last decade, there was one year where the river didn't even open to the ocean. But then as soon as that drought ended in 2017, and 2019 was another good water year, you see it popped right back up, at least somewhat to the peaks it had been. So is that success? Is that not success? I mean, if we just stopped here, it kind of looks like those graphs that people were showing it earlier. But it doesn't look like that anymore. And then in these are the abundances of parr, juvenile steelhead. At the end of the summer, the water district there has a long-term monitoring effort where they go out in October and September and electrofish and determine densities. And that's, you know, looks like there's initial response and then down. But, so it's not, I mean, if your definition of success is a long-term upward trend, it's not really a success. But next slide, please. So a couple of points I want to make. So these are some stock recruit curves fit to all those data. This is a spline curve fit to the abundance, or really the density fish per meter square of wetted habitat as a function of how many adult steelhead and trout were spawning. And you can see there's clearly sort of a density dependence here, meaning this is the point at which the river kind of fills up with fish that we can infer from that 30 years of data. And similar for age 1 parr from age 0, there's similarly this peak. But what's really interesting is if you look at the mean recruitment in terms of density, the mean over that 30 years was 80% of that capacity. For this, it was even closer to capacity, meaning every year this river pretty much fills up with parr in terms of numbers of fish per area of wetted channel. In an arid system like that, of course, the arid channel, the wetted area there varies a lot with rainfall. So in this sense, it is a success. This river is consistently filled with juvenile steelhead in the areas that maintain perennial surface flow. Next slide, please. So another way to look at this is here's that same time series of steelhead abundance. So steelhead have about a 3 or 4 year generation time. So here's the running 4-year average rainfall in the Carmel watershed. And you can see those two things track each other pretty closely. So here on this other side here, then it's just putting them on the same axis. This is the exact same data. 4-year running mean rainfall, number of adult anadromous migrants. And you see it, you know, starting in 1991, it just tracks the rainfall pretty closely. And what's especially important here is this is that drought in 2013 through 15. Population went down to where we consider it in pretty dire straits, but then it sort of popped right back up again after we had some good water years. And so, to me, that's an indication that this is a resilient population. So it's not on a sort of long-term upward trend, but it is tracking rainfall pretty closely, and it is recovering pretty quickly from drought years. And that is another definition of success, a resilient population. Next slide, please. So then one of the things we're starting to do at the Science Center is develop this integrated modeling capacity we want to work on to ask various what-if questions. What if we did things differently? And so as an initial foray into that, I did a couple what-if scenarios on the Carmel. So if you think of those 3 sections of the river I talked about earlier as these sort of 3 different geomorphic types, this canyon that as long as there's water coming from upstream, the river is full of water. The upper valley where during the summer anyway it's this losing reach, but it does maintain surface flow, and then in the lower valley, because the aquifer gets drawn down, it turns into this intermittent stream with remnant pools that is much less productive. What if the lower valley looked like this? Or what if they hadn't done any of this and the upper valley looked like this? what would be the outcome? So next slide, please. So here's just a simple model of that. If things had continued after 1990 as they had been before, you'd expect this kind of response of the steelhead. So all this production would have come from that canyon section and from the tributaries. If that was an area where there weren't even residual pools for the most part in the lower river. You had a situation where both the upper valley and the lower valley were kind of like what the lower valley is now, with sort of some residual surface flow in the deeper areas in some years. This is what you would expect. This is the actual situation of the last 30 years. And then this is, well, what if you restored that lower valley as well? You could expect to get that many more fish, including some of these years when you get a pretty large amount. So that allows people to kind of visualize, what has been the effect of all this work that's been done in 30 years. And well, this is sort of our best answer. And so another aspect of asking what the success look like is asking the hard question of an arid system like the Carmel, just how productive can it be? This is sort of saying this is how productive it could be if you completely restored the whole river. Next slide, please. There's still problems, and I haven't talked about a lot of things in the river that didn't work or haven't worked yet. One of those, I would argue, is the estuary. There was a big estuary restoration here done during the Bush administration. And there's ongoing work. There's a lot of plans in the works to restore this whole area, but right now, the steelhead can't really get to it, at least not in the summer, not until fairly late in the wet season when enough rain falls to really reconnect this whole thing. So the river fills up with steelhead and with juvenile steelhead, and to the extent that there's too many, they can't get to the estuary. So this is not really being used by the steelhead. They can't get to it because this lower river still dries out, because the aquifer of the lower river is still used as a water storage area by the water district. And so those are sort of the next steps, is asking what can we do to improve this situation. And I'm not going to talk about that today, but hopefully this clarifies that if you did want to get a larger population, at this point the river seems to be pretty resilient and pretty full of fish, and this is the place to focus attention. And that's all I have to say.
So I'm going to ask for your patience. I did something I normally never do, but I completely redid my talk this morning. And when I mean this morning, I meant while some of these folks were speaking. Mostly because these days it's hard to focus my thoughts, and then many of the speakers this morning reminded me on some key issues, so I apologize for the lack of images and a lot of text. I will pay for that sin to my supervisors this evening, I'm sure, in terms of the beverage tax. So please be patient with me. Next slide, please. So, in asking folks what they wanted from me, it was game changers. And the Klamath is a fun one to be around right now. Talking about whiplash, going from where we were this time last year, watching the drawdowns, to where we're at now is quite amazing. But there are lessons to learn here, and I think I want to make some key points, and then we'll go through that. I've got a lot of text up here, but some stuff most of you probably know, but I'll go over again, is that time and space are important. The Klamath is an old system. There's bull trout in the upper basin, there's sturgeon in the lower basin. The Klamath province has got high endemism. It's a very old system with Pleistocene wetlands in the upper basin, and just an amazing site. Next slide, please. So, time matters and how we look and think about time. We think we've got it nailed. In the last 25 years, working with the tribes, I realized I didn't understand time. And I will tell you, even though I had worked in that basin a long time, about 10 years ago, when we got down really planning how to implement the dam removal, one of the people working for the tribe pulled me aside and said, Tommy, I know you're good, but I also know you like to talk. When you come to these meetings, shut up. Listen. And when you listen, you will hear. And when you hear, eventually they'll ask you questions. And that's what it required. Even then, we were talking past each other for a while until if some of you were at the SRF meeting here in Santa Cruz several years ago when Brooke Thompson, a Ph.D. student at UCSC, spoke. She talked about the Mierau tribe having different words for past tense. And so as I was at these meetings, I realized that I was missing something. And so I had an afternoon where I was sitting with the Vice Chairman, Frankie Myers, on the banks of the river. I said, explain that to me. And he said, the best way I can explain it is that there's been 4 or 5 periods in the past. And they're not exactly linear in time. At that point, my head's exploding. But no wonder I didn't understand. But it was around disturbances, river recovery, the cadence of the river. And so it was a very different way of looking at the system. And so that really influenced our way that we developed our plan to restore. And I am going to be very biased here. This is my interpretation of how we did it. You might have other people here and they might say it's a little different. I was serving as the Science Center's lead on the recovery, on the restoration of the Klamath, so this is kind of what guided me. Next slide, please. So, tribal communities have been there since time immemorial. They have a very long view of that system. Non-tribal communities have got there rather recently and rapidly expanded in the basin. And their land use shifted. It could have been agriculture, then mining, then timber, but it shifted radically back and forth. Very recently, what I'm terming the restoration of this came along. And we were extremely variable. It's subject to funding, subject to personnel, what tools we were using, what tools we use. Some people have tools that are a hammer and everything looks like a nail. And so we have these different type of communities working in the system. And these most recent ones, doing restoration is often subject to budgets and staffing and everything else. Next slide, please. So we have that as a context. What do we need to do in thinking about this system? I was asked by Nate to say, what does success look like? Well, first of all, we had to come up with a plan, and we needed to think in generation of fish. And you've heard several people talk that it's going to take 20 years, 15 years, 30 years. It's 4, 5, 7, 8 years generation times for fish. So first, we worked on that. Second, to restore a system requires space, big space. And we could do that in the Klamath. The Klamath is a big basin. On top of it, our salmon use the ocean, which is really big. And historically, this system was connected from the ocean, several hundred miles upstream, to the ridge tops. Next slide, please. So, switching to the ocean a second. Remember, this is that dynamic thing. For us that work in freshwater, we always talk about dynamic systems. We have floods and fires and everything. The ocean is all over the place. It's very variable, and those conditions have a strong influence on the survivor, the fish, how fish survive, how they move, how they grow. And this is happening all the time. Next slide, please. So, focusing on freshwater, which I focus on, there were a couple things we wanted to establish when we thought about what would success look like and how do we get there. First of all, the environment's very, very diverse. And the presence and use of specific habitat varies by species, ecotype, populations, families, and time. Short time frames, whether we're in a drought, a series of droughts, or shorter time frames. And a critical thing is that all habitats are not always productive in a system that has natural disturbance regimes. Next slide. So if we think about that, the spatial and temporal scale of disturbances where Pacific salmon live are very variable and extensive. These animals have evolved and thrive in diverse and dynamic habitats. This diversity and dynamic nature actually allows for the expression of life history types. It provides them a capacity or capability to responding for changes in habitat. Next slide, please. And if you think about the kind of changes we made in disturbance throughout the range of salmon, but also, like on the Klamath, pre-Iron Gate, with Iron Gate in place, and now you can actually see all the way back up the river. I think some folks floated it recently and told me all about that. These are very different constraints in space and time, and the ability for fish to evolve these different life history types and move across the landscape is different. When I mean move across the landscape, you move across the landscape if you're a fish, it's warm here, it's cold here. I'm using this as this age, I'm going to go over here for this part. I'm moving for food. There's a landslide, I can't get to that stream, I go to that stream. Two fish like Chinook come back at 2, 3, or 4-year-olds. There's all different types of ways you can track change in the environment. This limits that. Next slide, please. So, what did we want to do? How do we think about these things? First of all, with other dam removals, we spent time on the ground with them. And this was one of the biggest ones, is to manage expectations. When David and I were working on the Carmel and others at our lab, we were getting calls weeks after San Clemente Dam came out. Did it work? And trying to explain to them that you need to think in generations. And we tried, but we didn't. We really worked hard on the climate, and we're still getting that. And unfortunately, the fish overperformed this year. We had 7,500 fish go by Iron Gate, which is mind-blowing. But I wasn't expecting that many. But now expectations are even higher, so we're in trouble. It's a good problem to have. What we really did is we focused relentlessly on reestablishing processes that made a diverse habitat and connected habitats. And this was really critical, that we weren't shooting for a fixed target, 5 pieces of large wood every 100 meters. It were the processes delivering that. And remember, I said not all habitat is coming back online. It's all this mosaic conditions. You heard Jacob talk about this earlier, about these mosaics. We really tried to focus on this, and it was hard because in real time, as we were doing the drawdowns, in fact, this time last year, people would get in position, oh no, something's happening. We had a low DO, we had high sediment, and we had to figure out how is this getting us to this dynamic condition, and we had to focus on that. Next slide, please. So, I think one of the most critical things that is putting us in positions to succeed on the Klamath are the stewards in the landscape, the climate, the tribes. They're there and they're not going anywhere, and they've been there a long time. Excuse me. I will also give a pitch for us federal employees there. That 2 of us in the Klamath group that focused on the Klamath, from the beginning to the end, really from 2002, the fish kill into the dam removal, were the same people. And we had a consistency, and we have that across the agency. Steve and David, me, and a couple other folks. Until this last year, all of the people that did the technical recovery teams for the state of California were at that agency. And that provided an incredible amount of stability and humility to get through it. So it was important because really these things are about relationships when you do this kind of activity. And those relationships take time to develop. Going and listening and hearing and being asked questions are important, and you only get that if you're there sitting with people at meetings, going out and talking to them over dinner, and develop those relationships, because you move from arguing with the person because you don't think they're smart to Well, we're looking at that in different ways versus on the Carmel, we had a situation working on the Carmel that we were arguing with the geomorphologists on which side of the river the trip was. We realized geomorphologists walk a river going downstream and fish biologists walk it going upstream, and it was as simple as left and right problems. So you have to interact. Next slide, please. So one of the things, and it's funny, it was great to hear Jacob's like, we're both starting to use this word sequence. And the sequencing was of the expectations that this is going to be messy. There's going to be a lot of mess out there, that there's going to be fish showing up, blinking out, coming back, blinking out, and trying to set up that sequence as that habitat restores. One of the things we did is we built in how we thought the fish would respond and what actions we wanted to take by thinking about how the river naturally worked. And so it was basically rip it out. And we wanted as much sediment flowing down at that time that river probably historically delivered that sediment, which was in January. So January, February, March. And so we wanted to go. Now, Climate's a little different, much different system in terms of the sediment than the Carmel was. But we really tried to time it, and the fish were really good at this. We took a lot, the water board really pressed us on turbidity, suspended sediment. As we had that, when the dam was coming out, everybody heard reports about the water quality and how bad it was. We get a call from our tribal partners on the salmon, and they said a bunch of snook were coming in, and the minute that sediment hit, they pulled in the salmon river. And then as soon as that sediment went down, they moved out. Fish knew what to do. They hadn't seen that for 128 years. Boom, played that card. They were ready for it. Yeah, river don't lie. One of the things setting up expectations that we have to do on all our recovery planning and our restoration is understand that it's contingent on the environmental conditions. If we take a dam out and we're in the middle of a drought and ocean conditions happen to be poor that time for fish, the response is going to be slower than it would be other times. On the Carmel, David and everybody was quite lucky in that we were in the middle of the drought, which expedited the dam removal, and then we had a massive flow events. What was it, Dave? 4 2-year events, 2 10-year events, and a 30-year event in like an 8-week window. It took Splash Mountain and those weirs and just blew them out and did its thing. We got lucky there. So you have to set this up. Early on the process, they discussed putting some triggers in. If after 2 years we don't see this, we do this. After 3 years, we tried to build in this expectation that you have to look at the environment, freshwater, marine, and what's going on with the fish. And it could take 12 years, 22 years. It could take 5 generations to know. And that's a hard thing to get people that I can't tell you we're going to hit that right at this time. And remember, the ocean's doing its own thing. I blame that on Nate. You can talk to Nate about the ocean. Next slide. The other thing that you'll see in most of our talks, and Jake and I seem to do the speaker circuit here, is fish have to be able to move across the landscape. And we're reconnecting the Klamath, which are 2 very different systems. The upper basin's low gradient, hot, spring-fed. Mid-Klamath's a different beast than the lower river. And the salmon, the Shasta, and the Scott, and those mid-basin tributaries are like different systems altogether. And the fish have to move around. We are in a much better position now to emphasize this based on our genetic work and our tagging work. On the Klamath, we're finding fish that are going to the Shasta with offspring in the mid-valley trips. We have fish moving around the system. They're tracking change. Connectivity is important. We also have fish coming from the Klamath that are going south to Redwood Creek, where there's a restoration project going on. So time and space matters, and it's not just within a basin. When you do something as big as the Klamath, there's a benefit for other projects around. Next slide, please. So, and you'll hear me talk more in another talk I'll give at this meetings here, is that I took a real deliberate approach, and many of us did, to have a consistent message about how we delivered things. And this was really developed while we were doing ESA work, but it's analogous to what we need for magazine work and everything else, is that fish have to track change in the environment. So Dave was talking about fish in the Carmel, different regions. Same thing in the Klamath, moving among basins, within the basin, among populations. Next slide, please. So what does success look like? We really focused on having viable, persistent, self-sustaining populations across the landscape, working together, connected. So I drove people crazy in meetings as we went along because they would bring up something and I'd say, how does that get us to the next step? And sometimes it was just, quite frankly, we just can't afford this press item right now. And I would go to the mat. Many of us would go to the mat. Others, it was like, well, this is playing out differently. But it was always this test about how does this get us here? And if it's, you can tack, if you're in a sailboat, you go because you're going to get back to that point. But if you're just taking an action to take an action, that's not good. When you do these big projects, people get a little antsy because, boy, we have to show we did everything we could. Quite frankly, taking out 4 dams on the Klamath is a lot of something, and letting the fish in the river go is important, but that's hard. We want to do things, and sometimes just help people get out. And I think we're fortunate with, for many reasons, active reintroductions proposed for spring run in the upper basin, but all the other places, it's volitional reestablishment of populations, at least for the first 3 to 4 generations. Next slide, please. So, along with connectivity and viable populations, I've always put this in, and it's something we developed at the science centers, is that the foundation of developing these populations for healthy, harvestable populations, non-endangered populations, is spatial structure and diversity. You have to have it. That is the cornerstones of developing these. If you focus in abundance, what do? We probably just do hatcheries. And it really doesn't get us there. So every decision we make doesn't get us to spatial structure and diversity. Next slide, please. So the other thing was that took a lot of time, and this is based on some papers years ago that Steve Lindley showed me, and then reading the papers and meeting some of those authors from work out of Florida, is, at least with the group you're working in, make sure everyone agrees on the desired future conditions. Because if not, you're going to be talking about the trip that comes to the left and the trip coming on the right. If everybody's destination is different, then you're not going to be working together. If everybody says, this is where we're going, we want to have populations, we want to have total number of fish coming out of the Klamath be at this level. Okay, how does that get there? But if people are saying, no, I just want this or that, you've got to get that worked out before you go down the next line. Or you're just going to start making crazy decisions as things go. So that establishing a consistent view of what you think that future landscape looks like is absolutely critical to know how to get there. It's like jumping in the car and go, where are we going? I don't know. I'm going to go to the first in now. Go. Also, this understanding of space and time is really important. Actions that we take in the Klamath influence other basins. Actions we take within tribs in the Klamath Basin have other impacts. We had fish in a site, we researched down at Big Sur area. We had Trinity River hatchery steelhead showing up at Big Sur. These fish move across the landscape. And so space and time matters, and time is setting expectations. And that's really important both for the funding agencies that actually often ask for deliverables. How do we come up with the deliverables so someone can say they were successful in implementing that grant, but all that backwater logs you put in haven't been wet because we've been in a drought. Next slide, please. I think I'm almost done. So it is amazing how fast this has come back. It's still coming. We have a long, long way to go. We need to get fish in the upper basin. But it does show you when you go big and think about time and take the time to develop relationships with partners and stewards in the landscape, you can make big things happen. So thanks.
Yeah, we need more chairs.
chairs.
So I'll ask for a question or comment, and you can address individual speakers or the whole panel, whatever you like. Anybody have something they'd like to ask?
I was going to address this question to Jason specifically, and thank you for traveling here and sharing with us a really inspirational storytelling from up north. And what you presented seems to me like a different way of working. And I wonder if you could share with us who carries that sort of different way of working, or how do you bring partners along? Like, who leads that? What does that look like? And then second part to the question, I think I heard you say that you weren't, government wasn't leading this. Of course, tribal council sounds like a lot of leadership, but was there a specific role or way that government was involved in advancing those success stories? Thank you.
Thanks. I would say if you were in a room in British Columbia and asked that question, we would spend all day responding. I will give you sort of a shorter version, and I will qualify this as one person's perspective. It's not instead of kind of the conventional, but as well as the conventional. And because I think the conventional is similar, whether you're in California or Washington or British Columbia. There's institutional government agency mandates and leadership, but there are these other capabilities, these other perspectives, these other ways of knowing and other ways of looking at situations also in the ensemble of the constituency. And so I am not Indigenous. My family are immigrants. I was trained in university in scientific ways of looking at things. But over time, I have learned these other ways of looking at things, and they go together. So to your question around the leadership, I think it's kind of one of the Indigenous leaders who has agreed to collaborate with us says, the answer is it's going to take all of us. And it's going to take all of us working together, and all these ways of knowing and seeing and learning. And so the answer to the other part around what was the role of government? The government entities definitely had a role and continue to have a role. But I think where we're making progress, the paradigm is changing. Instead of they must lead from some government institution and entities will follow. Some of the entities that are in far corners of British Columbia and have never really had great service from government institutions say, no, that's not how it works. Government doesn't lead, government follows. We identify what needs to be done. We push agendas. We know what's going on in our landscape. And we keep the door open to working with government entities. So one of the great Indigenous leaders in the world that I work in also happens to be a member of our board of directors. His name's Murray Ned. He's from the Smath Nation. And he shows this really wonderful diagram where he says, here's what people from the Western world think government looks like. It's monolithic, and it's an upward pyramid, right? And he said, here's what leadership and responsibility looks like from an Indigenous perspective. And the pyramids turn the other way around, where the leadership and the right comes from the individual and kind of works the other way. And so he says, this is the problem, right? The government approach is who's in charge and who makes a decision, and the Indigenous approach is more like, it's all of us. And so there's a coming together of these ways of thinking that I think is really inspiring and sparking some of the success on the British Columbia side. And so it's not either or, but it's how does it all work together?
Wait, let's continue with that, I think. And maybe if we could just hand it over to Tommy, who was also speaking about that Indigenous Western reconciliation and leading towards something that I think we all think will be a population level recovery in the climate.
Yeah, interesting. We were in a group meeting trying to figure out how to go through things, and it came up, people were talking about TEK, and talking about Western science, and Barry McCovey kind of said, you guys are talking like these are separate things.
Right.
It's not. And a great example for us on the Klamath, and we had this role model, was Keith Parker. If anyone knows Keith in the Lower Basin, he did work with lamprey. But molecular biologist, but also a tribal member. And he sent me a great email I shared with Nate immediately this spring, or this last fall when he's fishing, of talking about how the fish, chinook, are coming in differently. And they must be, you know, this is a time we fished, and look at this, and showed me the color of their flesh and the size and the condition. And in the same sentence, he goes, they're probably heterozygotes for the greb gene because they're going, and he goes through this thing, and I'm, okay, that's it. You know, they're not separate things, and we still compartmentalize them a lot, and time and space are a critical difference in those. And so it was something that developed on the Klamath that I think valued it, but they're not separate. And I'm not good at that, I'm still learning. And one of the things I would recommend is show up, shut up, and listen, and then you'll hear. I heard that a lot.
Well, there's someone else who hears it a lot.
My twin
I'll
here.
take a risk. I felt so lucky to be invited by Jason and by the Pacific Salmon Foundation up to Vancouver this last fall to take part in their inaugural British Columbia Salmon Resilience Conference. And it's so cool to be here with all of you who, you know, I've spent so much time, I kind of feel like this is family. To be in the giant Vancouver Convention Center with salmon biologists and only knowing 2 of them, it was fantastic and really important as far as our isolation in California, often thinking that we might be the center of the known world. It's definitely not the case on the southern range for salmonids, right? But it's true in so many other ways. Part of the session that Jason moderated was something similar to this, the idea of success stories. And to your question, Mary, there were these amazing firsthand stories from the Okanagan and the Cowichan about coming together, about collaboration, about diversity leading to abundance. But there was something that I hadn't ever really experienced before. And it wasn't just that they were indigenous led, it was that they were indigenous guided. That the vision for where those watersheds needed to go was held at the really, not just at a watershed or at a people, you know, as a nation, but at ridgetop to river mouth, full life history, geologic and human generations all blended together into a true big picture. And I thought, you know, I often think about that's the story of 21st century ecology, is really understanding the diversity is the basis of resilience in all systems, whether those are salmon watersheds or investment portfolios, and that we have to do that, but we have such trouble as Westerners holding that big picture. We get sucked down into the nodes in our models. And to see that those 2 things could come together in such a way and so quickly lead to salmon recognizing the relationships which forged them, and out of that coming that abundance. And so that's something I really miss without knowing it in the Central Valley, where the disruption of our indigenous cultures and nations has been so profound that we're only now beginning to build those relationships and have those voices intact, but they're really missing. And so that idea of melding the 2 seems absolutely necessary, and maybe it's one of the fundamental recipes for recovery, is big picture thinking melded to actionable specifics. And 2 communities Western do one of those well, and Indigenous does another, so maybe that's one of the axes.
I have a question, shifting gears, if that's Darren. So, going to life histories, Dr. Boughton, like at the end of...
Can you speak up a little bit?
Yeah, just shifting gears to life histories. At the end of your talk, Dr. Boughton, you were talking about how those out-migrants towards the summer, they couldn't access the Carmel River estuary as the lower river started to dry out. So I wanted to know more about that. How would they adapt to that? Like, would they just start to try and rear in the lower river, or would they try to out-migrate later, or then incoming ocean returns? Like, what was going on with that cut-off passage there?
Yeah, that's a good question. I mean, I guess the simple answer is we don't know because it's cut off. So we don't know what they would do if it wasn't. Or at least we haven't looked at it yet. But we're starting to do some work on that, in that one of the things I didn't talk about today was the water district for decades now has been rescuing fish in the dried up section, and they go plant them in other parts of the river. But they're going to start planting them in the estuary and tag them to seed. Ask the fish. I mean, that's often what the answer is to ask the fish. And so we'll put them in the estuary. The estuary is pretty cool, but it's also got issues. It's got some water quality issues. It's also got striped bass that live in it, which are an introduced predator, which are not going away anytime in the foreseeable future. So we don't really know. There's a lot of arguments about the effect of striped bass, but we don't really know whether the steelhead can deal with them or not. So this is a way to ask that question. What's happening now, what seems to be happening now, is that you have years when there's a lot of recruitment of those age 0 fish, and they fill up the river, and then they just don't grow as well. There's a phenomenon in Salmon, it's called self-thinning, where you see if you have fewer fish, they tend to grow faster. If you have more fish, they tend to grow slower. And one of the things that seems to be going on in the Carmel is when there's years of poor recruitment, the age 0 fish grow faster. And so if they enter the ocean at a larger size, they succeed at coming back as an adult at a higher rate. But in years when there's a lot of recruitment, those fish are smaller, and they don't survive as well in the ocean. And it seems like the two things sort of balance each other out. It's another, not exactly, but somewhat. So it's another sort of aspect of resilience that's kind of built into the way the fish respond to this unpredictable environment. So yeah, one of the questions is if we could keep that river connected in the summer better, what would be the benefit of that? We would expect that the population could use the estuary more effectively, but again, the ultimate answer is to ask the fish.
Thank you. And if I can ask a follow-up question, like with the self-thinning that happens, do you see other life histories happen around there? Like, I know there's double smolting like in those central coast watersheds, so like in the south central coast, are you seeing that? Are you seeing any other, or do you just not know at this point? Got it.
My sense of steelhead is they do whatever they can. If
climb a tree.
Yeah, they're very flexible. There's what we are calling resident trout, but they're pretty small, but we're just assuming they're fish that have, for whatever reason, decided to stay in the stream and reproduce. There seems to be an effect of flow on the probability of age 1 fish going to the ocean or not, an effect of sort of spring flows, which implies that if the flows aren't sufficient to get out to the ocean, they just stay in the river for another year and reproduce there. But we don't really know. We just have to sort of guess it.
So I'd like to add just a little bit to that. I think one of the things that we can think about like across species, across the systems that we're working in, is that life history diversity is just one of the critical pieces to resilience. And so as we're thinking about climate change, building in those ways that we can support a variety of life history diversities is going to be, I would argue, one of the measures of success. The more life history diversities we can get out there, we get these mosaics, we get these different life histories that are operating in time and space differently. And I think that's, again, thinking about the big picture of what does success look like. I think increasing life history diversity in all of our systems is going to be a key point.
Yeah, and if I could add just one thing to that, I think the way to think about it is figuring out habitat, water management, whatever it is, that gives the population the ability to express the life history rather than sort of managing the life history per se. That if you create suitable conditions for diverse life histories, the population will then just sort of spontaneously start to express those.
But that really requires connectivity. Tommy really hammered on this point, and your example is such a great illustration of that. If the fish can't get to the estuary, there's no estuary-rearing life history, and those fish, which would otherwise have probably just maybe even moved on into the ocean and been unsuccessful, remain there and compete against the others and drag the whole system down. So just, some small reconnections could have profound effects.
Did you have something?
I was going to just ask Jen if you had something to share from 10 Mile where there has been this monitoring going on with the work both in the estuary and in the upper portion of the watershed. Do you see that kind of life history, diversity response that you would hope to see?
Yeah, we are. I totally agree. I think one of the keys to success in the 10 Mile is that there has been a ridge to estuary effort, and not just focus in one area and not just focus on one project type either. So understanding that access to velocity refuge in the lower watershed is absolutely essential for outmigrants and winter rearing, and creating really good rearing habitat in the summer in the upper watershed is super important. And having both of those things happening at the same time allows fish to express different life history strategies and to be resilient to climate change and increasing and more frequent droughts and increasing and more frequent and larger floods, right? So we're kind of spacing this stuff out throughout the watershed and in order that they have what they need when they need it. And we are seeing, we've made a huge effort to tag fish in the summertime, juvenile fish in the summertime in the other forks. We've kind of been focusing a lot in the South Fork, and the really intensive monitoring effort is focused in the South Fork, where we have most of the antenna arrays and the outmigrant trapping and all of that sort of thing. But by tagging fish in the other two forks of the watershed, we've been seeing quite a few of them come down the two forks, go down, swim down the main stem, and then swim up the South Fork and rear in the South Fork in the restored area. So they're definitely taking advantage of the opportunity to move around and take what habitat they need when they need it there.
All right. Next question. Here's the back row.
I'm going to read mine because I want to read these questions. And, it's actually for everyone. But Tommy, you mentioned about the need to identify the agreed future conditions, and then the need to build trust. And many of you spoke about the need to build community trust, as well as, a whole new initiative to integrate the tribes. At the same time, obviously, as you're all stating, we need the scientific info to inform our decisions, and now that's even more complicated with what we understand about diverse life history strategies. So in my 30 years in this field, there's been a much increased tension around moving faster, about increasing the pace of the scale of restoration because our species are going extinct. And yet this is in conflict with the time needed to build trust, to develop the scientific database, to agree in community settings on future landscape conditions. So I was curious how you guys thread that needle. In my previous years working in Napa and West Marin, it was a lot easier. We took a 10-year time frame. We thought that was fine, but in recent years, the pressure has accelerated. Just do it. You know these techniques work. Just do it. So So I wanted to know how you guys deal with, those of you that have, you've all demonstrated very great success stories. How are you dealing with that tension? Strategies.
First of all, people like Nate and Steve and up the chain in our Science Center allowed me the opportunity to engage for a long time and attend meetings and go to things, which is actually one of the constraints I'm feeling now, that interacting in person is absolutely critical and spending a lot of time in that system. And so we do need folks with longevity and relationships. I was actually lucky on the Klamath in that I did my undergrad at Humboldt, and there were some people actually retiring when I started, but they were there. So those relationships are important, and they come from interacting with people and listening. The other thing is there's an absolute urgency to take action right now. But you have to set that expectation that it takes a while for the fish to respond. Sometimes they respond quickly. So actions are urgent, but if you have a Chinook that's 4 or 5 years old, some go back, some come back, it's gonna take 20 years. And so a lot of that is being a teacher and providing opportunities, not giving a talk like I did today, but one like you saw with figures and communication to show people what the process is. And that's where our, building, art and science is just a way to explain how the world works. And so merging those, it's about communication and reaching out to the public. We don't do a great job of that. And we also don't do a good job inter or intra-agency and organization speaking. And so a lot of it is that, Nate and I did some early tours of the LWA, and one of their take-homes was communicate and coordinate till it hurts. And you think you've done a good job, and you have to do more. And even though we did that till it hurt, and it did hurt on the Klamath, we didn't do enough. I will also say it's where we have different voices and people at the table too, whether it's our tribes, whether it's the water users on the upper basin, whether it's the whitewater community, whether it's the people who are losing their lakefront property. You have to be in that room and get to that point where you're talking about things besides, I don't like your point of view, or I don't trust you. So
this is a really great question and a really big problem to solve. The Fisheries Science Centers, it's our supposition or hypothesis is that if we can provide you all with quantitative tools to reduce the uncertainty and the expectations about restoration investments, that will be one barrier less to overcome. That when people don't really know what you're going to get for $10 or $100 million, they're reluctant to make that investment. So hopefully that's one small way we can accelerate this. But I think if we did a word cloud of what was said here today, 20 years would be up there, right? It just seems to take a couple decades to make anything big happen. Hopefully we can get that cut in half.
Can I add one note? I also think there's a certain, every place is different, and even the specific sites within a watershed are very different. So I think understanding the context of the environment that you're working with, and understanding that, particularly when it comes to certain types of risks, but understanding that there are some activities that can be implemented a little more quickly. Yeah. Removing barriers is kind of a no-brainer, right? A lot of the large woodwork that we did in the 10 mile, we were working in very low risk setting, and we knew that we could kind of take this method that was effective and very efficient and put it on the ground quickly. But the work that is happening lower down takes a lot more time, a lot more science to understand. So it's kind of understanding and navigating your environment, and then applying the tools in a way that is strategic and makes sense. And sometimes it takes more time.
I would say, and that's why it's important everybody understands where we're going.
Yeah. Right.
Because if you take these actions and you don't know where you're going, you might take actions that are not productive to getting where you want to go.
Well, and if you're worried about the long term not there, then you fight over the near term. Yeah. So that really helps. That's part of that roadmap
is so important for collaboration and for building trust. It's the way of institutionalizing that people have been heard, if you can have a mutually and collectively developed vision for where you're heading.
I also think as you establish success stories in some watersheds, it can make it easier to then do all that collaboration and coordination you need to do similar work in new watersheds. And so that's something we've seen a lot on the Mendocino coast. It's like the 10-mile watershed's pretty uncomplicated. It's mostly one timber company and just a few large landowners. And all the TNC work doing floodplain restoration in the lower watershed, the whole thing we didn't talk about was there's 2 decades of outreach that preceded us actually breaking ground. But now that we've done that, we have like an example and a use case that we can take as we start collaborations in other watersheds that can hopefully get us to the on-the-ground part a little bit faster.
I wanted to add to this as well. This is such a fundamental question, and I thank you for bringing it up. I have a lot to say about it, but just the idea of having to increase the pace and scale of restoration is in conflict with the idea of taking our time, setting up models, understanding the science before we go into the implementation phase. But our grant programs are set up to be the opposite. It's like, here's the money to go build something, but they won't give you the money for the science or the monitoring up front or the planning. And so we need to kind of structurally, fundamentally change this approach. Maybe choose fewer implementation projects and spend more of that money on the science and the monitoring that we need to learn from them as we go through these phases of implementation. We don't do that very well. And I think we need to change that throughout all of our regions. And our agencies are telling us how to do this, right? They're giving us this money. It's been so easy to get money for the last 10 years for implementation, but not for science. And we spent several years as committees looking at the CMP program, trying to get more money infused into it so we could do more population level monitoring. And it's always no. We have to change that so that we can go slower and identify where we want to go, and then we'll get there with more certainty.
I think I would just add to that also. I think our planning processes can better integrate those. We can both plan for short-term outcomes and long-term outcomes. So I think a lot of the restoration work that we're doing is we're going to throw wood in the stream right now because we need to build up that complexity immediately. Sure. But we're also going to be planting that riparian zone that is going to be that long-term process base. And granted, it's more difficult to get funding to support a riparian-based plan. We've had issues with this. We're saying, hey, this is what we need to do. In 20 years, we're going to be reducing the thermal load. We're going to be getting more wood recruitment. Those are harder projects or proposals to fund sometimes. So again, I think you need that balance in there of both short-term planning, what do we have to do now to meet the threat and the needs, while integrating some of those long-term plans.
I think it's important, and what we're learning is like destination is important, but precision may not be to that. Like one of the things, Jordan Point, one of the First Nations leaders that we are working with, it's funny, I'm in California. When we were talking about salmon recovery, we talked about destination. And we said, can we just agree we're going to California? It doesn't matter yet if we're going to Sacramento or Santa Cruz, but we're going there. Yeah. So the idea is, can we agree we want better? And maybe Tommy wants to do this thing tomorrow, and he thinks it's going to make a difference. And Jason's like, yeah, Tommy, we need a plan. We should take 5 years and figure it out. And what we're learning is they're both valid. Yeah. You can do both. You can bring in a bigger tent. Maybe your imperatives are to do something now, and you've got that tension and you have that opportunity. The other view doesn't have to get in your way. It can be, why can't we do both, work together? Because what happens in these success stories is a convergence, right? The things that work stick and you keep doing them or you build off them. The things that maybe weren't the right thing to do, people realize that and they come around to the things that do seem to be getting you in that direction. Are we heading to California? We are. We're going the right way. And when you get to the problem of, is it 8,000 fish or 6,000 fish? Are we fishing them or are we hugging them? That, you've won if you get to that. Right?
Yeah. A great example that I didn't use the slide because I didn't want to offend local folks, but I have an advertisement of a concrete log that was developed to use for fish restoration. And you could get it in different species. And it was because wood's important. Forgetting the process where how wood and sediment are delivered to systems. But so when you do these things, you also, there is a trip point that can we appreciate with what knowledge we have, can we recover from this if we're wrong? There's some actions that and there's some empirical information now saying some actions are wrong, are not consistent. So you have to do that, but I agree. There are things you know that are safe and you're going to get there. But you have to be careful because then the concrete log comes along and people are protecting this part but not those processes. And so I chose not to use it because it would have got a great laugh, but I think I will say that I'll take their intentions were good to do the concrete log, but it screams parts and not processes.
Right, short-sightedness.
Yeah.
Okay, we've got another question back.
So I go out on construction projects, and I got cornered one day by one of the workers, and he mentioned, well, you mentioned previously that we had our good years and our bad years with the rain. And during one of our bad years in California, we voted on, holding more water, right? And so one of the construction workers asked me, why can't we put in more dams? Well, it's because of this dam minnow. And I was like, I don't know what you're talking about, but okay, sir, yeah, sure, it really sucks. I'm sorry that we can't do that. And so I'm wondering for all of you who have gone out on these projects, when you're taking out a dam, have you encountered people like this? What do you say to them?
Define encounter.
But yeah, how do you approach people like this?
You did the right thing to begin with. You listened. It's a good start.
So I'll make a comment. I was going to comment on the previous question that's germane to this because it's really important. I think you said precision maybe doesn't matter, but for some things it really does, and one is water and the quantity of water. And people who want to use the water or the riparian zone for other purposes, you really do have to say this much, if you give us this much water, or if we take this much water, you force them to give up this much water. Here's what society gets from it. I feel like we really need to do a better job of that to address exactly what you're talking about. There's a lot of co-benefits that have nothing to do with salmon that come from managing our rivers better. And
There's another response, though, to a gentleman named Mark Cedarborg who's working with Sally Bolger. They have this organization called the Environmental Workforce Training. So they're reaching out to contractors who are doing the construction project and training those contractors in the environmental restoration work that we're doing. And I think it's a brilliant idea because they're bringing them into the idea of you're not building a structure, you're building an environmental feature, right? And so they start to understand that it's a different kind of thing. And we're making environmentalists out of construction workers, right? And so we're eager to work with Mark and help amplify this process, and I think it'll help people like you're encountering better understand. So like in our bid documents, we're building in the requirement that those contractors actually train their workforce in these kinds of things. And so that's kind of start to growing that part of the restoration industry to be more understanding of what we're doing.
Yeah, but the thing is that what we often move the goalposts. It's perceived we move the goalposts, going from conveyance to slow it down, spread it out, sink it in. Great example. What? Soak it in?
Slow it down.
Slow it down, whatever. Go.
The last one's growing.
Growing. So that's a tough one to do because we do make mistakes. Fisheries biologists took logs out of streams because we thought they were impediments to movement. And we have to own that. We have to own that science is a conversation. And so when you do the wrong thing, you've got to figure that out. So it is communication. It's tough because they pull those examples out. And so we need these type of examples. It's difficult because they see what's happened before. But so much of river management has been conveyance and getting people to open things up. Stage 0 reduces flood risk, but they see levees as preventing floods. And so I think having example projects you can take people to, and practitioners or communities that have done those actions are really important because they often have the same fears that those local people have to that action.
But Tommy, let me ask, I'm going to channel my colleague, Allison, who is our head of communications. She's a communicator. And if my instinct would have been to say something like what you just said, to help a young person who's out in the field. And she would say, no. So what? Who cares? Why does it matter? That's what we as technical people, as people at the back ends of our careers, I'll point at you, not everybody up here, people at the back end of our careers.
A little too much touch of gray
here. That's our responsibility, is to translate this technical stuff so that people who are on the front lines can explain to people that are not technical why this matters, what we are trying to do, in a way that maybe helps them go, oh, okay. Like, I don't need to know all of the details of the stuff that we would talk about in a room like this, but we do have to help our technical constituency communicate it in that, make that leap to the general public, who, when you explain it to them, they probably care. They probably care about that river for some reason. They like to walk there, they like to fish there, they, whatever, they like tadpoles or something. They probably care for some reason, and we can probably make that connect. Yeah. But we have to take the technical. I'm channeling Allison, and she would say to me, so what, who cares, why does it matter?
And one of the great tools we all have now is using the word portfolio. And that really started being used around the .com crash, and people understood that. But when you talk about, or I was in a group where I clearly, because of where the venue was, there were sports people there, so I could use the example of having all point guards in those centers. But that, taking those analogies, so reading the room and communicating in such a way is important. And some people are really good at it, and others are not. And so that's where on the Klamath is great, because we'd have tribal and non-tribal people there. We'd have scientists and comms people there. And they would do just what you did to walk through that, which is what you need to communicate to groups.
All right, well, I am going to cut us off for now, but please come back at 1:30. We've got lunch right outside, and we will have another series of presentations from case studies that will be followed by a panel discussion, and if you have a burning question or comment for people, grab them over lunch, maybe it gets started. Thanks very much for a great morning session. That's good. Thanks.
All right, so when we were organizing this workshop, our thought was we would pair case studies on places where we thought there had been a lot of success achieved, and we challenged our speakers to talk about how they define that success and what they thought were the key elements in achieving it. And we wanted to pair that with a series of case studies where people were in the thick of it. In other words, where there are watersheds that have attracted considerable attention to do restoration of salmon populations in one way or the other, but success is still sort of they're in the middle of it. They haven't seen big responses. They're still thinking about what needs to happen, what they plan to happen, and asking similar types of questions. How do you define success? What do you think are the key elements of success? So our first speaker is Matt, and Matt Menzinger, and he'll be talking about Halama Creek and Halama Creek Steelhead down in Southern California.
All right, cool. Well, hi everyone. My name is Matt. I'm a postdoc with UC Santa Cruz and TNC. Today I'll be talking about a collaborative and ambitious effort to bring steelhead back to Hwang Creek. So we know that steelhead are widely distributed across the North Pacific, but there is, and all these populations have their challenges, but there's one population that's at critical risk of extinction, and that's the Southern California steelhead distinct population segment, which spans from Santa Maria down to San Diego. And across this whole range, we're talking, low double-digit annual returns of adult spawners. So to give a sense of how suppressed this population is. I've highlighted some of the watersheds that continue or have recently supported steelhead activity, but today I'll be talking about Hwang Creek, where steelhead haven't been seen in the river in over 30 years. To orient you to Hwang Creek is located between Vandenberg Space Force Base and Hollister Ranch, but perhaps most importantly, just up the coast from Point Conception, which in addition to the watershed has and it continues to be an important cultural site for the Chumash people. However, once the Spanish missionaries arrived, the landscape primarily has been dedicated to cattle ranching, and the land continues to support cattle ranching today. And Hwang Creek has been the principal water source for these cows. Up until the 1980s, the creek supported annual runs of steelhead, which were actively targeted at the Hwang County Park in the lagoon, which perhaps have contributed to their decline. And these are some of the last pictures we have of steelhead in the creek. And then in 2017, almost the entirety of the watershed was acquired by TNC through the establishment of the Jackanour Endangerment Preserve. And this creates a unique opportunity for targeted restoration under more or less one single like-minded landowner in the context of steelhead recovery. So we see translocation as a potential game-changing strategy for steelhead conservation. Some of the reasons to move fish around are to prevent local extirpation of critically at-risk populations following disasters, restore metapopulation dynamics within this population range, as well as increase overall population size. Just some of the benefits, but all under the umbrella of increasing population resiliency. Why might Hwang Creek be a good place to put steelhead? First, it's designated as critical steelhead habitat. It has perennial flow. It has a really nice lagoon system that could support juvenile rearing. There are currently no omicas present in the watershed in any capacity, so we're not worried about screwing something up if we were to put fish in Hwang Creek. And perhaps most importantly, 94% of the watershed is within a TNC preserve, again, which creates this unique opportunity for targeted restoration and recovery. So our ultimate goal is to return a self-sustaining steelhead population to Hwang Creek, and we're considering sort of three things at this point on how to make that happen. The first is to identify and mitigate human impacts to the creek. The second is to assess and improve habitat. And the third is think about how we're going to get fish back into the creek. And all of these are sort of happening simultaneously as we speak, and I'll sort of walk through each one of these things for the rest of the talk. Before I talk about identifying and mitigating human impacts, I just wanted to give everyone a sense of how wild and relatively undisturbed this watershed is. You can see by these pictures, it's just a pretty tremendous and intact landscape. But generations of cattle ranching operations have imposed human impacts to this creek. And so I'll talk about two things briefly in this talk. One are human-made barriers, and the other are cattle themselves. So prior to 2023, I'll just put the watershed back up there for now. Prior to 2023, that's how much continuous anadromous habitat was in the creek before steelhead would have encountered the first barrier. So TNC went in an intense effort that involved low-grade explosives and helicopters and all sorts of fun stuff. Went in there and got that dam out, and that's what that stretch of river looks like today. And all those cobble were previously buried under sediment imposed by the dam. So things are getting back to normal. What did that accomplish? Well, 2 kilometers of continuous anadromous habitat. So really it was the combination of that barrier and this barrier that I'll talk about now that was really going to be a game changer for opening up connectivity in this system. And that barrier was a 3-foot drop created by this concrete apron below the road, where the road crosses the river. And what TNC did is they totally re-engineered the downstream riverbank and built it up to meet that concrete lip. We're back. And my colleague Keith Miller is giving an awesome talk on this tomorrow afternoon, specifically about this rough and rock ramp system that they created to enable fish passage upstream and downstream. So what did the removal of that dam do? Well, that looks a lot better, okay? Now there are over 20 kilometers of continuous anadromous habitat within the creek. And thinking about all the potential anadromous habitat available, outlined in those red, by the red lines, that's over 60% of the total habitat in the creek, which are limited by natural barriers and gradient barriers. So now what we're thinking of are identifying the existing barriers to connectivity within the creek and prioritizing, which ones to remove next. The next thing we're thinking of, I mentioned that Paloma Creek has and continues to be the principal source of water to support cattle operations. So the next step in this mitigating human impact is to find creative ways to keep cattle out of the creek. This next sort of vignette is assessing and improving habitat. We're doing that in 2 ways, and I'll present 2 slides, but I promise we're doing more work than that. The left, we have intensive sampling for benthic macroinvertebrates, which can not only be great indicators of stream health and responses to restoration efforts, but they're also what steelhead eat. And on the right, we're doing assessments of physical habitat at the reach level and the watershed level in collaboration with CDFW to sort of map out where that good habitat is and ways that we can improve that habitat. So using all of these data, we're able to generate maps that look like this. So this is sort of the lower half of the main stem of Paloma Creek. And on the top, we have rearing habitat, and on the bottom, we have spawning habitat, and sort of mapping this out, and we can identify areas of high quality rearing habitat and high quality spawning habitat, such that when we move fish back into the creek, these might be good places to put them. But also, this allows us to identify places that we still need to work on and think about sort of other targeted restoration that we can do to make those places yellow as well. The last thing I'll talk about are potential reintroduction pathways to get the fish back. And I'll plot them, I'll introduce them, and then I'll plot them on this probability of happening axis that I put up here. The first is straying, or sort of natural reintroduction. That'd be great. It's sort of the field of dreams approach. If you build it, fish will come. The probability of that happening is relatively low, given how low the population density is in that part of the range. So another thing that we're thinking about is sort of a planned translocation, where you pick a relatively healthy donor population, and then you select individuals to introduce into the creek. And that comes at some of the benefits of selecting for a healthy donor population, really considering population dynamics, but at the challenge of bold decision making. These are bold decisions that are going to have to be made if a planned translocation were going to occur. But I think we're kind of at that point with this population that something bold needs to happen. The last thing are these emergency translocations, where you take an at-risk population that's immediately at risk of extirpation, and you move them into Paloma Creek. And with the increased frequency of these extreme events that we're seeing, like wildfires and flooding, drought, this is becoming more and more like a greater probability of happening. But it comes at the challenges of you're taking a doomed donor population, you have to make rapid decision making when that population is at risk, and that there's really no control over population dynamics. You're taking fish out of the creek and you're moving them somewhere else. You don't get to pick and choose how much and how much of each life stage. And the reason I say that this is most likely to happen, at least in the near term, is that it just did happen in Topanga Canyon. So just a few months ago, CDFW rescued almost 300 steelhead from Topanga Creek and translocated them into another watershed. So our goal is to recover Halama Creek to the extent that it can be a good destination for these fish the next time this happens, because it's going to happen again. And that's all I have. It's a huge collaborative effort involving all these folks up here. And yeah, that's all I have. But I don't know if there's time for questions or not.
Yeah, a couple.
Okay. Yeah.
Do you have any creative ideas, panels on the water?
Yeah, so the thing that TNC is really thinking about now is using this virtual fencing, where you GPS collar all the cows and sort of train them to not enter the creek. And they're actively purchasing equipment to make that happen right now.
Actually, I have two other colleagues that work in Central and South Coast region that have expressed resistance to do translocations. And could you summarize, is there a state policy that's precluding that action from happening? So I'm assuming you've asked the department to do this sort of thing, and they're saying no, and do they give you reasons why not?
Yeah, so I'll preface that we're not going to be the ones making the decision to move fish. That's going to rest with the agencies, and there is a little bit of resistance to do that proactively. But when something like what happened in Topanga happened, I think that really puts them into action. I don't know what this, I mean, yeah, there's permitting that would need to happen to move fish around and approvals that need to be, run up the ladder. But that's sort of where we're at right now with the translocation potential.
So I noticed Carlos Garza was on your team. So, I mean, he would be as expert as anyone else on the effects genetically of populations if you were to move, and your watershed doesn't have any other fish, so it doesn't seem like there should be a barrier to that action.
Yeah, one thing to think about, I mean, when we get the fish, is that can we then put other fish in? And that's the exact reason why Carlos is on this advisory team, is to think about the population genetics from both like a emergency translocation or a planned translocation.
What do you know about future hydrology with climate change?
Well, it's going to get hotter, less water. But it is a relatively low gradient watershed for that part of the steelhead range. So I guess I'm less concerned about some of the disastrous impacts that a debris flow or a high flood event might have on fish in this creek. But it's definitely something that we're thinking about and making sure that once fish are in there, there's going to be enough water moving through that the estuary can still be reached and we can still have those, analogous dynamics.
Yeah,
Are you currently looking at water temperatures, and do you know the water temperature seasonally in this watershed?
Yeah, so yes, we have ideas of what the water temps are, but this summer we're going to deploy a whole bunch of hobo loggers to monitor those temperatures through time, both longitudinally within the river as well as stratification within the estuary and those deep pools.
Real quick.
Yeah.
Oh, yeah? It seems like it never pays to bet against steelhead. I mean, they're cockroaches. They exist all the way down into Baja still. I know it's tempting to say density is low, but they're also amazingly fecund. I mean, just one or two females completely reseeds that population. That's what they've always done, especially in dynamic Southern California. And I know it's great for us to put all our science to work, but getting those barriers out, getting the watershed there, yeah, I hear you on translocations, but I would be really surprised if in a very short time you don't have naturally reproducing fish.
Well, in 2 weeks we'll be out in the stream and we hope to see some of them.
Yeah.
But
Our next talk was originally scheduled to be on the Tuolumne River, but both presenters ended up having conflicts, so that, unfortunately, that talk is canceled. So our next talk is with Allison Collins and Liz Stebbins. All right. And the title is Reorienting to Recovery in the Central Valley, Adapting Decision Support Models to Advance Values-Informed Landscapes.
Hi, my name is Liz Evans. I'm a data scientist with Flow West, and I've been working on the Reorienting to Recovery project with a ton of people. So I'm really just here talking about part of it, but there are a lot of people on this team, and way more people who have participated in it through 4 phases now. So I'm going to be talking about our structured decision-making process, which was really designed to be equitable, values-informed, and to work at a landscape scale. So the charge for the workshop today was to talk about recovery both in near-term improvement and full recovery. But what I'm going to focus on specifically is really how this project, R2R, defines recovery and how we got there and how that came from a lot of people's participation and values and objectives, and then really how we could put that into a model. So how do we define recovery? It's a lot of outreach, engagement, a ton of communication. There's a lot of work creating forums for people to have their input, and really just to record their values and objectives in a way that would allow us to produce metrics from our model that can measure against those values. This was a really big process, so the way I'm going to sort of talk about it is a little bit about storytelling, the way that we solicited people's opinions, the integration of their values, their personal connection to salmon, their visions for the future of salmon, and also some barriers to involvement in the decision-making around salmon restoration. There's also some talk about structure. We have this decision support model, but it was also just great to have everyone agree on, a conceptual model. Once people agreed on that, you could talk about, what your ideas were, where they fit into this conceptual model of the salmon life cycle in the Central Valley. I'm going to talk about the modeling tools because that's really where my expertise comes in. That's where I can answer probably the most questions. And then I'm also going to talk a little bit about transparency, or making sure that our modeling, all of our work to put people's values into objectives and performance metrics, making sure all of that's really transparent so that people can, give feedback, come up with ideas, and just improve this process iteratively. So the project goal, if you're not familiar, Reorienting to Recovery, or R2R, is a project designed to identify recovery actions for the 4 runs of Chinook salmon in the Central Valley. We wanted to advance recovery while balancing interests and also achieving a critical mass of support across everyone who was involved. So it's not just people who are really interested in improving salmon numbers, it's people who are water users, people who have personal engagement, people, tribes who have been working with these fisheries and with the fish for time immemorial. So there are a lot of values that we're balancing here, and what we were using for this is a structured decision-making process. So we're trying to identify actions that will advance recovery. We really call this the 4 H's, or these 4 areas where those actions the 4 categories those actions could fall under. So we have hatcheries, harvest, hydrology, and habitat. Our model was designed to really test out actions in each of those 4 categories, but in the process of building this out, we realized that while there are a ton of models a ton of investment really in this space, there wasn't really one exact model that would allow us to model all of these different categories of actions. So this is where we have our little diagram here. We have some of the existing models, and then we also have the decision space we needed for reorienting to recovery. And we really did not want to we knew we didn't have to reinvent the wheel. There is a lot of work being done in this space. So what we did is we took one of the best existing models in this area. It's a life cycle model developed by the Central Valley Project Improvement Act, CVPIA, Science Integration Team, the SIT models. It's a life cycle model, and I'll get into the specifics of what parameters it uses, what it covers. But the main thing to understand is that one of the main things that that life cycle model can one of the things that it can do is model how different habitat actions, or more or less habitat, affects the life cycle. And so what we did is we took these models and we built them out so that we could also plug in different actions in the hydrology space, in harvest, and in hatcheries. Make sure I got everything I wanted to say there. Oh, one important thing to note, as we're plugging in these different actions, we really wanted to consider and measure the values of the R2R participants. So it's not like we're just coming up with these actions. These are actions that were suggested by the participants. We did a lot of literature review. We did a lot of consulting with other people to make sure that they had backing to them. So I'll quickly go over the scope of the model. It works for fall, spring, and winter run Chinook salmon. It's on a 20-year time step, which is matched to hydrology from 1980 to 2000. It runs on a monthly time step, which it's tied to the hydrology. We use calcium, and that's at a monthly time step in the area. And it covers the Sacramento and San Joaquin River basins, which includes 31 different watersheds. The model itself is calibrated to Grand Tab, which gets us a lot of the survival coefficients. And really, one of the main things to note is that this is all the capacity of the model, and some of the things that some of the key updates that we did as part of the R2R process involved updating the model to use calcium 3 runs where possible, or to come up with different ways of plugging in different hatchery scenarios, like, you know, scoping up over, like building up over time and then decreasing, and those were just small updates we had to make to the way the model was designed in order to put those actions into play. So what I am going to cover here are just some of the different model phases, the phases that it went through, the scenarios that we modeled, where those came from, and then also quickly go over the results. But like, there are a lot of results that we could talk about, and in the interest of keeping this short, I'm going to spend a little bit more time on how we got to getting the model functional, and then really encourage you to dig into our resources, talk to anyone from reorienting to recovery you know around here, and then also just come up and ask me, because there is a lot of information here. So the question of defining recovery, there were, let's see, I think in the process of soliciting value statements, there were over 560 values, which were condensed into, I think we have 6 categories of values, and then we have 34 performance metrics that came out of that. So these right here are some of our biological performance metrics, but we have performance metrics that cover land and water use, water availability, ag and land use, water availability for municipal districts, let's see, ecological processes. There's a lot of different performance metrics, but these right here are biological ones. So the first one is a cohort replacement rate greater than 1. The second one is spawner abundance over 500, and we did this for some indicative watersheds, some key indicative watersheds. We also had a population growth rate greater than 0, and a proportion of hatchery on spawning grounds less than 0.05 or 5%. Our modeling phases, just briefly, we had illustrative scenarios. These were really to just figure out what the model can and can't do, figure out if it's converging. The bookend scenarios were designed to really maximize one of the 4 H's. So if you really wanted to maximize like all of your hatchery actions, what does that look like? If you wanted to maximize your habitat, what does that look like? And I think one of the most interesting things to come out of this part of it was, as part of this like forum, this like group of people all participating, a lot of people might have one of their favorite of the 4 H's that they think is going to work. And what this showed is that not one of those reached recovery. So it wasn't just one of the H's that worked. It really brought people in on this idea that you might have to have some trade-offs between those 4 H's. And that's what the blended scenarios were, really combining different actions across those 4 H's. And this achieved recovery. The last phase, which was the most recent phase, is our balance scenarios, which really tried to sort of even out some of the benefits across the different performance metrics. And we also got some scenarios that achieved recovery there, which was great. So this is just a quick overview of some of the balance scenarios. I'm not going to go into detail. We had our baseline scenario, the tortoise scenario. We don't need to go into the names too much, but that's really maximizing actions for dry years. We had an elephant scenario, which incorporated some of the different proposed actions under the voluntary agreements, or the HRL, healthy rivers and landscapes. And then platypus is the one I'm going to talk about. It really is just some of everything. And I want to make sure I got everything there. So these are just some of our results here. This graph here on the bottom of the axis is just our model simulation years, so 0 to 20. And then on the y-axis are our watersheds. And this is just showing us how many of the model years did we achieve these different metrics. So you can see that we reach recovery both for the spawner abundance and for PHOS. PHOS pretty much after year 6, and then I think after year 10 for the spawners. So this is just a cool way of visualizing where it meets abundance and PHOS recovery thresholds. We also looked at other things like the average cohort replacement rate by these different watersheds, and then also our average growth rate. We really hit it in every single one of those watersheds. Like I said, there are a lot of different results here, and I'll get into a little bit into some of the things we built out for this, but we have like a web application where you can really just plug and play and look at all of your different runs, the different scenarios, and see how they perform, and look at how they perform in every year. This is a QR code. If anyone wants to see our documentation site, this will have a link to everything. I was going to put the website, but it's just really long. And I did have, I had a note for this one. Was it? Maybe not. I think the main thing that I wanted to really hammer home here is that there were a lot of people who worked on this. Allison Collins is my co-author, and she's here, but also everyone on this team here was really integral into this process. I am just one part of this big group. The workshop participants, the SDM group, the technical team, the science advisory team, the planning team. There are a lot of people involved here, and I wanted to thank the Delta Stewardship Council for the funding of this. I also, as the last one, want to shout out that Natalie from our group is giving another talk on reorienting to recovery on Thursday. And this will have a lot more information. I think she has some more time, and she's going to go into a lot of the work that went into pulling people's value statements, objectives, and really putting this together as a collaborative effort. So I hope I was good on time there, but I'll take questions. Thank you.
Yeah, there's time for a number of questions.
Yes, yeah. Probably a better one to rest on.
So given you have solutions that are coming from the modeling exercise, is there a timeline for implementing those solutions?
That's a good question. We had a proposal out for the next phase, and we're just trying to figure out how we can get that to work. I think there's, this was really an exercise in identifying what we think is viable, but there's like, I am not sure what the process is going to be for getting those into play.
Can I add to that, Liz?
Yeah.
Hi, I'm Allison, so I worked on this with Liz. Yeah, so right now we're seeking implementation funding for the next phase. We wrote a grant with the Delta Stewardship Council, but that was not successful. So we're talking a little bit about it with various agencies and breaking the proposal parts into smaller pieces. I think we're really interested in working in like a specific watershed and doing a case study, implementing the recovery actions that were identified like on a smaller system and showing how it could be scaled up, which some people have talked a little bit here about that process. And then it's just really continuing to engage all the participants. We engaged over 110 agencies over the last 3 years. So it's keeping that group engaged and collaboratively thinking about how do we move this really broad scale vision of recovery forward. And part of that too is like there's already very many efforts in the Central Valley going on. So it's lining the pieces that are currently going on underneath this like grander vision. So that's what we're working on towards the implementation of these next phases.
So related to this, so when you go to an individual watershed, is there a priority list for that watershed where this is the most important and then down, or you got to get them all kind of thing?
No. Great question. No, the scale of the actions that were identified are very large landscape scale actions. So part of that is finding a group of users, multi-users in a small watershed that can work to take these broad actions, understand how their pieces of work existing are there, and then prioritizing the next pieces. So then that will be for all the 4-H's. So like, again, what we found is all 4-H's are needed. But I think there's some great places like the American River has already a forum that has very broad participation from many different parties that you could start to prioritize more specific landscape level actions.
I've got a two-part question. First is, can you give a ballpark of like the number of people, the number of months or years, and the number of dollars it took to get, like, whatever, at whatever level you could cover that. And then, is there a shortcut to the top thing, or do you have to go through the whole deep dive and wade through everything to, you know, put it in an order of item 1 to 1,000? Or is there a shortcut to the top 5 or 10 things that you could do as a start, even if you needed to wait, you know, 5 years or something to go through the deep dive?
Yeah, I think Allison probably can answer the first part of that question because she's been involved with the project since its inception, I think. And then just for the second part, just with my experience working with the model, I think there are quite a few of the actions that we know might have more of an outsized influence on the success for some of the performance metrics or some of the biological recovery targets. And I am not quite sure, I don't think we've discussed yet, like how you would essentially rank those. And also I think part of the question that gets a little bit into the specifics of the model is some of these things can really, you know, push up your numbers for a certain watershed, and we want to also ground truth that and make sure that it's something that's implementable in the way that it's working in the model.
Yeah, speaking to the number of participants and the years and the dollar cost. So it was a 3-year effort, $2 million. We started off having a lot of very small one-on-one conversations. We found, again, like groups and forums that already had collectives present to go and speak to about the process and what we wanted to do. And we spent like 8 months just doing that, right? So to bring people in on this idea, because again, we were talking from users that lived locally, like in the upper watershed, and then in the delta, and then ocean as well. So it was like bringing, so there was a lot of, you know, Tommy mentioned like communication till it hurts, like that, but
it hurt.
But identifying that we could have even done more, right? So there was just like a lot of engagement piece, and then the first year was really focused on that and defining what we meant, like what does recovery mean, how do you know when you achieve it? And then the second year was really focused on working with all those people to do this value storytelling workshop where we really brought people in and gave people lots of space to tell why they care about salmon and how they're impacted by salmon to really drive those values that we could then turn into some quantitative metrics. We weren't able to track everything. We kind of had process-based and decision-based performance metrics that were there. But it is a significant investment of time and communication, but was really worthwhile.
All right, I think it's time to move on to the next speaker, but hold your questions for a panel discussion. Lots more to talk about with recovery.
So, floodplain forward, what is that? We were just hearing about a really ambitious, really necessary project in R2R, in reorienting to recovery, that is Central Valley wide. And it's a big place, the Central Valley. Definitely, probably, feels foreign to coastal salmon folks, but the San Joaquin, the southern lobe, is very different than Sacramento, the northern lobe. And R2R was looking at the whole enchilada. How are we going to recover fish in all 31 of those watersheds across all the different species? That all makes a lot of sense. And we all know there's only one way to do that. It's do it all. Yes, please. Right? We need upper watershed, lower watershed. We need to understand longitudinal connectivity. Right? Getting adults spawning and laying eggs in diverse upper watershed gravels so that those juveniles can be a diverse portfolio of both size and timing, moving down into lower watersheds where you have lateral connectivity into those floodplains, oxbows, side channels, tidal estuaries, all of the different places where river ecosystems make food, which makes abundance. So you have resilience on one side and you have abundance on the other. They're tied. All of that's awesome. R2R needs to happen. That's why it took $2 million and I don't know how many people and how many rooms. You guys can talk about it. But this is also in the Central Valley. This is not nearly as ambitious. We're looking at the Sacramento Valley and at the floodplain side of things. But it's still in the midst of one of the great agricultural landscapes on Earth. We were talking about TNC owning most of 10 Mile. We have thousands of landowners. We're talking about the water supply through this agricultural landscape that moves directly into California's economy, right? This is a $4.1 trillion GDP that doesn't run on silicone, it doesn't run on gasoline, it runs on water. And the water is moving through this ecosystem. And if that ecosystem is failing, you don't deliver the water. So what do we have here? We have all the folks that live and depend on the Sac Valley coming together under this basic tenet. That more fish is good for everybody. That a functioning Sacramento Valley ecology is absolutely necessary to deliver a secure water supply into the fourth largest economy on Earth. That means that we have not just the major agricultural landowners and business interests in the Sac Valley on the top line there. We're talking about the large ranches, the large agricultural interest groups like the Rice Commission, as well as the biggest ranches in the valley. You also have the water districts and the flood protection districts, which supply, maintain the water infrastructure that moves water across that landscape. Below that, you're looking at the major conservation groups that work with fish, that work with birds, coming together, understanding that what we're really talking about is the entire system. And then we have our regulatory and local governments, as well as the state and the feds, all there coming together. Why? Because there's this simple underpinning that if we continue to only meet in the courtroom, we're never going to actually get to a place that is better for all of us. That the money spent on litigation, on acrimony, is wasted. That we need to come to a place where we have aligned our ecological and our economic outcomes, and the only way to do that is to realize that the river is not a thin blue line. It's actually not even a river, it's a river valley. That we have a set of patterns that not just our salmon respond to, but our giant garter snakes and our bank swallows and our cottonwoods and our elderberries. Those specific sets of conditions, those specific sets of patterns that the entire native biota is adapted to, that they evolved under, all of those are changed or altered by human behavior. This group has come together understanding we don't manage salmon. We don't even manage the rivers that those salmon depend on. What we manage is human behavior. And really what we're trying to manage if we want to see salmon abundance is understanding the human behaviors that interrupt the natural processes that create and sustain those series or sequences of biophysical conditions that a single salmon responds to. That's what habitat is. And that means that we can actually have one of the most lucrative agricultural landscapes on Earth and an abundance of our native wildlife. So how do we get there? How do we get to this place where we're actually advancing floodplain reactivation at a landscape scale? And this is absolutely critical to everything we're doing. We have absolutely no right to expect a population level response if we're nickel and diming. If we're not operating at landscape scale, we have no reason to expect success. And to date, very rarely are we actually operating at that scale. But even in a privately owned landscape, one that has been managed, controlled, owned by what historically would have been an extractive industry, agriculture, we see that there is incredible synergy if we understand the means by which this valley once produced wildlife abundance. And if we understand the means by which that productive capacity was interrupted. Yes, by dams, but guess what are really long dams? Levees. This isn't really difficult. What we're talking about is a gross approximation of the natural patterns to which salmon are adapted. So how do we do that at this large scale? Well, partly we understand the multiple interests involved. Getting the bird folks to talk to the fish folks, that took us a decade. Instead of fighting over this water going to that refuge, understanding that having more public interest and political pressure on spreading and slowing water out through wetlands, that was absolutely critical to both. And the science really helped, right? Up until relatively recently, what did we think? The fish belonged in the river belonged in its banks. So seeing that wetlands were as important to salmon as they were to birds really started to align us. And Ducks Unlimited and Trout Unlimited, California Waterfowl and California Trout, all of these entities, both national and state, coming together on a common agenda of really spreading and slowing water. Understanding that that can happen in productive farmlands was really important. The other piece of it, of course, is that when you spread and slow water, you sink it, right? And sinking water back into the ground, that's California's piggy bank. Every summer is a drought. Pulling water out of the ground, that's absolutely necessary throughout the state, whether it's for ag or for municipal water uses. And it's pretty simple, right? I mean, if you just take money out of your bank account and never put it back in, guess what happens, right? So when you spend 150 years doing everything you can to get water off the landscape as quickly as possible, right? Think about your backyard, think about a suburban street, think about every farm field you've ever seen, or a Safeway parking lot, or basically everywhere that humans go. What do? Get that water off, right? You're anti-beavers. We abhor a puddle. So how do we both spread water in order to sink it back and recharge our aquifers at the same time that we're really doing some of the most effective flood protection projects in the state? So there's this confluence of benefits. Let's talk about the ag, right? So what happened when I was a kid in the valley? There was a, can you press play on that? Or does I, yeah, there we go. When I was a kid, this is a rice field. Rice was burned after harvest. So there was an epidemic of asthma within the Sacramento Valley. Every August, the skies turned dark. And in 1991, the state legislature passed the Rice Residue Burning Reduction Act. And that cut off rice burning by about 75%. And they cried bloody murder, the rice industry did at that point, right? Uncle Sam's gonna kill us, it's all over. But there was a second way, a second best way, a second, not the second least costly way, I guess. Let's just watch that again because I love it. To deal with rice stubble. Rice stubble has to get out of the way, or else basically your field turns to adobe and you can't get the next year's crop in an effective way. And that was flooding it. So in the heart of the Pacific Flyway, what had been for millennia, right, this incredible continental, this migratory route of continental importance for waterfowl. But for 100, 150 years after the valley was drained, in winter, when it should have been wet, it was more or less dry. There might have been a puddle in a corner somewhere, but leveeing, divorcing the river channel from the floodplains meant that the wetlands were absent. What did these ducks and geese do when they suddenly saw these fields flooded again? They went, oh, I know what to do with that, right? And they came in. It was completely unintentional. But these birds saw a population level resurgence in the last, in my lifetime, since I was in high school. Their populations were similar to where our fish populations are now at that point, on the verge of listing. And we had a change, not in the actual physical state of like the habitat, but in management. We started to grossly approximate the wetland conditions that these fish, feathered fish, had evolved with and were adapted to. And all I'm trying to get to is abundance. It was necessary that this happened not at 1,000 acres or 10,000 acres, but over hundreds of thousands of acres. But it meant that we had an industry in the rice industry that had a real experience of being the bad guys. They were growing a monsoon crop in a desert, right? And there had been this change, and now they were providing habitat for 250 different native species. Then we learned, as we talked earlier, that those wetlands were as important for our native fish as they were for our birds. And here's an illustration of that, I hope. Or maybe not. Do you see if that video is playing? Oh, that's too bad. That's the making of a floodplain fatty, you guys. You're missing out. You watch that thing just swell. It doubles in size every week. I can, if you want to see it afterwards. But what this meant was that farming and conservation, now it wasn't one or the other. We had this opportunity, and we're not saying this is true for everything, but in the Sac Valley, especially within rice, we have this landscape scale opportunity to, in summer, still provide the economic engine for a rural, vibrant agricultural community. But in the off-season, in the fall, in the winter, and the early spring, manage water on those farm systems so that they not only provide wetland habitat for birds, and not only provide incredible engines of natural productivity that create the bugs that even if the fish can't get onto those fields can be drained so that energy flows back into our channelized streams to actually benefit out-migrating juveniles. Or we can do these landscape scale projects within our flood bypasses and floodways to get tens of millions of fish out into swim-through wetlands where it makes sense each and every year. Right now, that only happens 2 out of 10 years or so when you get really major floods. So this is a piece that I've been hearing about today. We were talking about abundance in salmonids tracking rainfall. And I would say that that's unsurprising, but that it also is a direct result of a channelized system. That when the volume of water is required and directly corresponds with the extent of wetland habitat that water creates. What's the best way of saying this? The interaction of the landscape and the river that flows through that landscape, right? You have volume of water. That's one way to think about it. But you also have the interaction of that water with landscape. When that water spreads and slows, you actually get much more wetted area for the volume of water present. And in a channelized system, it's going to require an extreme volume of water to create that kind of residence time and wetted extent. In a system where we have more interaction between water and landscape, you get more habitat benefit, more biophysical condition, more productivity for the volume of water actually present. And that's all that's really happening out in these systems. We're trying to use relatively little amounts of water when that water is available in winter and especially in normal and dry years to create the kind of big water year benefits that we've grown used to. So the coalition is come together to support each other's projects from the forests of the headwaters all the way down to the estuary. That is the portfolio that's going around here. The reason I didn't do it as a slide is because it's so large that you end up with teeny little dots on a really big landscape. But what we're really trying to do is create that portfolio of reactivation, of approximating natural pattern on a managed landscape that involves landscape scale swim-through wetlands and our bypasses that takes the hundreds of thousands of acres of former wetland that are on the dry side of levees, floods those acres in winter using irrigation infrastructure to recreate that wetland bug productivity, and then drains that back to the river, and then taking the last little bits of remnant floodplain that are within the levees and making sure that the energy from the floodplain is hitting the river upstream of those so that you increase the carrying capacity of the remnant off-channel habitat that does remain. So the floodplain forward MOU was signed last fall, and it was this simple idea that we can't do this at 100 acres or 300 acres or 1,000 acres. That until we're investing in landscape scale, green infrastructure, nature-based solutions at the same way that we do in freeways, in bridges, in concrete, we don't really have the capacity to expect recovery. And so the heads of all the major resource agencies at both the state and federal level, I'm sorry to say, except NOAA, signed this MOU that said, we're going to do better, we're going big. I think 2/3 of the signatories are now taking retirement. The idea, I think, will carry forward, however, right, is that only together are we going to get to that scale. One thing that I'd point out is you didn't hear me say tribes in any way. It's a huge gap in our work in the valley, and one that we really hope to remedy is having the tribal engagement at a truly meaningful scale and early in the development, and helping to set these objectives and to guide that recovery vision. But floodplain forward, again, in the Sac Valley alone, and really just based on this idea of how do you make puddles and where. But let's make them big and soon. So thanks.
And Matt's going to speak on restoration in reconciled aquatic ecosystems in the wildland-urban interface, specifically Mill Creek in the lower Russian River watershed, Salmon County, California.
Good afternoon. Happy to be here, and that was really a great talk that we just heard, and I'm going to a very different scale, and maybe about as hopeful and aspirational. So I'm here, Matt O'Connor, representing a young nonprofit, Coast Range Watershed Institute, and we've been rearing in Mill Creek for a little while and hoping to maybe go out to the ocean one day. This talk is about a watershed where there's been a lot of work done by a lot of different people and organizations, a common theme here in this session. And I'm trying to acknowledge as much as I can. I haven't acknowledged anyone. I'm not naming any names, but you can see there's been a lot there. And I'm really narrowing the focus here to hydrologic controls on habitat, because in this part of the range of coho salmon, that's really the major limiting factor. And without the stream, you can't have any part of the habitat. So I'm going to give you a little outline, or a little orientation of the Mill Creek watershed, talk about how thinking about it as a reconciled ecosystem makes any sense or matters. And I'll get to the rubric for the talk, elements of near-term and long-term recovery, to make sure I get to them. And then talk about the scope and timeline of recovery actions in this watershed, and spend a lot more time talking about habitat assessments and modeling that have led to specific restoration objectives, and a little bit at the end about current restoration activities. So Mill Creek watershed is there where the star is. It's in the ancestral lands of the Coho people. It's now known as Mill Creek. It's in the Russian River watershed, Sonoma County. And the Russian River is the largest watershed in the CCC-ESU of coho salmon. There's a little Google Earth image of the watershed. I live about right there. It's a small watershed. You see the Pacific Ocean out there. Healdsburg, and in particular, this is Mill Creek as it leaves this sort of coast range watershed, flows across the Dry Creek Valley, joins Dry Creek, and eventually the Russian River right there. One of the biggest problems with this watershed and why it's sort of thinking about it as reconciled is important is that because of changes in the river, and, the water table of Dry Creek is a lot lower than it used to be, and so this part of the stream system goes dry in the spring at various times, and that is a real problem for out-migrating birds. The watershed vegetation shown in this map, and the greens are the Doug fir and redwood forest, and the browns are various hardwoods, mostly oaks. The yellows are grasslands. There's kind of a coastal Franciscan and the Central Belt Franciscan kind of on a dividing line there. And the purple stuff is vineyards for the most part. The Walbridge fire, one of the big fires in 2020, did a number on the upper watershed. This whole, pretty much the whole upper watershed burned to medium to high severity, big effects. So much for the introduction of the watershed. Mill Creek, a reconciled ecosystem is just one that has got a lot of influence or dominated by humans, but it still has ecological values worth maintaining or improving. And the reason it matters here is just that it sets up constraints on what you can do. It's a watershed that's entirely private ownership, lots of small landowners, homesteads, residences, some agriculture, all the infrastructure that goes with that, bridges, roads. And it makes things like prescription fires hard. It makes in-stream habitat enhancement actions harder than they might be. And most importantly, that loss of surface flow in Lower Mill Creek is a real problem for the Coho population. I'll talk more about that. And now, the last part of the talk early here, so I'm sure I get to it with enough time to talk about it. So the elements of recovery for this watershed, first is there's been this 30 years worth of work on it at various levels and various levels of focus that sets the stage for kind of knowing what to do. And among the obvious things like stream flow is really the significant thing you have to deal with to have any hope. And in the near term, to maintain or enhance that stream flow, the idea is to have some existing and maybe new small reservoirs storing water, or at least half the volume of the water out of the reservoirs, to be released during dry years and drought years to maintain stream flow and to help out migrants. Near-term in-stream habitat enhancement, working on a reach of about a mile of Mill Creek where there's perennial flow to maintain habitat or improve habitat there, benefiting spawning, rearing, and spawning, winter and summer rearing habitat. And the long-term elements of species recovery here with respect to water is watershed scale, vegetation management, runoff management, the good fire concept, maybe stream flow enhancement with water from Healdsburg's sewage treatment plant that's right near the mouth of the watershed. That's kind of a hard thing to do right now, but I think in the long run that could be a big important thing. And having a community organization, local, with support of larger government entities. And in-stream habitat long-term is just wise management, avoiding making mistakes that are hard to rectify, like managing the riparian zone so it can recruit wood and not cutting it up so it doesn't cause a flooding problem. Okay, so a little bit of a timeline of restoration activities. These things are kind of happening everywhere. Captive broodstock program is an unusual thing. We have listings and the final recovery plan that kind of set the stage after early work by CFW doing landowner outreach and some projects. More recently, and where I'll spend some more time talking about this, is work that was done by the Russian River Coho Water Resources Partnership part of which during that period of time did a major improvement in migration that really helped. Our organization did some modeling work that has helped set the stage for knowing how to manage the water. And we've had more recently the SHARP program, sort of solidifying what those goals are, what the objectives are, and some projects that are currently ongoing. So, Coho Partnership, this was about a 10-year effort, really focusing on trying to get a viable coho population in the Russian River. Mill Creek was one of 5 watersheds that were intensively studied with the intent to restore the natural flow regime and get a viable population of fish there. And this planning process led to objectives and actions. And they mainly led to some management of water and through conservation, storage and forbearance with rainwater collection on rooftops and some modified diversion practices. There was analysis that demonstrated that although water is scarce in the summer, there's a lot of water available in the winter, so if you can get a way to store it, that could be a solution in some ways. And they recognized the problem at the mouth with loss of flow and initiated a study of the groundwater connection. At the end of this program, the partnership considered its successes, accomplishments. Intensive monitoring was a huge thing. There was a very dense stream flow and water quality network. There was a lot of monitoring of fish use in specific habitats related to the Coho salmon broodstock program. Use of pit tagging is an amazing tool. Created a lot of research-grade fisheries information and remediated impacts of water diversions to some degree. Now, this is one of the most important things that came out of this scientifically, and boy, that did not really reproduce very well. I'm sorry about that. But this is a graphic about survival of coho juveniles in isolated pools that are maybe just connected or start losing connections to the upstream flow. And there's just a probability of survival as a function of the number of days the pool is isolated. And this ended up being very helpful to some modeling that we did a little later on. But this is a very, very practical and useful finding. The other things that they were able to do with the pit tagging, this is work that Sea Grant did. There were migration barriers in the lower part of Mill Creek. This is a map of coho spawning, and a barrier had been removed down here, allowed fish to get up here, but there was still another barrier that was really limiting access. When that barrier got removed, they were able to demonstrate that, coho could now get into this upper watershed where the stream flow was sufficient in the summer to be able to have a successful over summer rearing population. This is a further map of what the partnership was able to do in Mill Creek. The red dots are storage and forbearance projects. Those green dots are part of the stream gauge network, which was absolutely instrumental to some modeling work that we were able to do. And the amount of water that they were able to sort of account for through forbearance, can be a lot in a single watershed. This was across 5 watersheds. These numbers amounts to something like 1/10 of a CFS, which I know does not sound like a lot, but in some of these watersheds, even a couple tenths of a CFS can make a difference if you're thinking about that pool connectivity curve. Some of these lessons learned are things that we've been hearing about in various talks today. I'm just going to hit a couple of them. Actually, not if I hit that button or not. So this was an interesting one, just recognizing that in this process of trying to figure out what's going on, it's possible to make mistakes, and you have to be prepared to deal with what your findings are and what the pitfalls are and move forward nonetheless. Small amounts of flow can be very beneficial. Cumulative benefits of these small incremental projects are very important. And watershed scale solutions were some of the main lessons learned. And they talked about facilitating future in-stream flow work and some of these kinds of things that we've been talking about that have come up in many of the other talks. But they did add that planning for future drought and climate change is very important, and linking flow restoration to wildfire management efforts was an opportunity. Now, how am I doing on time? Am I out of time?
You have a couple of minutes.
A couple of minutes, okay. So this is modeling work that we've done that I think is very helpful. This is an overview of this model that we've used. It's an integrated, spatially explicit, physically based model and can give us all kinds of pointers on how the systems work. There's a quick diagram of how the model is set up. There's a 10-year period of records calibrated to stream gauges and wells. You can do things like take into account this map of diversions that the State Water Resources Control Board collected, wells and diversions. It allows us to create these graphical interpretations of water budget terms, where stream flow comes from in the summertime, infiltration recharge of rainfall, small amounts of base flow, spring flow, and interflow generating most of the stream flow in these streams. Being able to think of that spatially lets us have maps like this in these sort of light blue colors. This is August conditions. These light blue zones are where the groundwater is feeding into the stream, creating gaining streams, and you can see in this lower part of the watershed where there is still some flow, it's being lost to the stream bed. It allows us to look at the effects of curtailing diversions and how much water would be realized from that. One of the main things that we've gotten out of this is looking at forest management, basically reducing evapotranspiration from the forest, which is the biggest outflow term in the water budget. And if you can make a 5% reduction in that evapotranspiration of vegetation, you can get these fairly significant increases in stream flow. We really think that that is the long-term solution to stream flow in this watershed, if you can get there. One of the aspects of that also, so the flow at the mouth of the stream where the fish are trying to escape, this graphic is showing the time where 80% of the outmigrating smolts have left the watershed, 95%. You can see a curve here of the sort of existing conditions and predicted conditions with 15% reduction in the main forest types. And you can see you get an extension of the period of time that the fish can escape the watershed to get to the ocean. And in fact, in some of the Walbridge fire, when a lot of the vegetation was suddenly removed, observations of stream flow were similar to that. And the amount of the stream that was wetted versus dry or intermittently wetted was also a lot higher right after the fire. And so we can see the effect of that evapotranspiration anecdotally, in addition to showing it in the simulation model. I've got to finish this up. I want to show you, this is a scenario of using reservoirs in the short term to release water into the stream to maintain that flow for the out-migrating Coho smolts. And you can see this pulsed scenario where these blue sort of pointed shapes are water being released through April into May, and the orange-colored lumps of flow, showing the sort of the losses to the stream bed, but maintaining the flow as opposed to just doing one big lump of outflow, but both have a positive effect. I'm going to skip through most of these things. So Sea Grant, in the SHARP process, came up with this list of effects that they have strong evidence for. I'm going to have to skip these. This is just illustrating the outmigration limitations that have been seen at the mouth of the watershed. These are their recommendations for what should be done in the watershed. This was, the SHARP project sort of confirmed all that, created this list of actions, and this has led to one of the projects we've been working on, which is trying to find those reservoir sites that can be used or created to feed flow back into the streams for short-term viability of flows. And this is a map of those project sites. We've got willing landowners with an existing reservoir here in need of repair, a reservoir for somebody who's looking to build one. A couple of people are willing to, other existing reservoirs downstream, so we've got reservoirs upstream to help feed the in-stream flow in the summer, and reservoirs downstream to help feed the spring outmigration flow. And thank you for the extra couple of minutes.
All right, our next speaker is Darren Mierau, and he is going to talk about the Eel River on the threshold of transformative change for basin-wide salmon recovery.
All right. Thank you, David. Good afternoon, everybody. Welcome back, and good to see you all. It's really nice to be at SRF again, isn't it?
Yeah.
Glad that our federal partners here ordered up some nice weather for us this week, maybe? Anyway, like many other speakers, I'm here representing a team of scientists working together on our watershed up in the North Coast. In our case, it's the Eel River. And the team I'm working with are from Applied River Sciences, formerly McBain Associates, if you haven't heard their new company name yet. Scott McBain, Tim Caldwell, and Suzanne Rhodes. Stillwater Sciences, Gabe Rossi from UC Berkeley, myself, Christine Davis from CalTrout. We have a member from the Round Valley Indian tribe as well who was with us, departed, hopefully coming back. We're trying to gain some tribal representation on our steering committee and our planning team here. We've also reached out extensively to the Wiyot tribe, who's sort of under capacity, so we know what their interests are, but they don't have the capacity to participate in our team here. I'm also sorry that I'm getting over a cold, so I'm a little bit congested and not a lot of high energy like Jacob, but trying to get through this together. And I think the Eel River, I've been working in the eel since I joined CalTrout in 2012, and I do believe it's on the threshold of this transformative change, and felt that it was appropriate for the topic of this workshop today. We started the Eel River Forum in 2012 with the idea in mind of bringing together the community of scientists, NGOs, agency folks, tribes, to get ready for what we thought would be relicensing of the Potter Valley project. And that was set to start 5 years before the license expired, so that was 2017. So we had like 5 years to kind of get our stuff together. And that started, PG&E went down the pathway of relicensing and then decided not to relicense. So now we're in a whole new world of likely the next large dam removal in Northern California on the heels of the Klamath River. We were using the Klamath sort of as a template for some of our early planning. Seems to have worked. We did some habitat assessments in the upper basin to demonstrate that if fish got up there, we would have a response, population response. There's habitat there for them. PG&E sort of read the writing on the wall that they're probably going to have to provide fish passage, which was one of the triggers, I think, in the Klamath Basin as well. So, yeah, I firmly believe that, with dam removal and some of the other, we'll talk about those actions that we're planning in our team, we could have transformative change in the Eel River in the next decade. Just some really quick background. The eel, we say, is the third largest watershed entirely in California. If you don't say entirely, then it includes the Klamath, which is bigger than the eel, but is partly in Oregon, so it's third or fourth largest. Kind of like, splitting hairs, but it's a big watershed, 3,684 square miles. I like to say it's bigger than the Shasta, Scott, Smith, Redwood, Mad, and Russian rivers combined. It's a big watershed. Lots of it. It spans 5 counties, really long. Historically, we also like to say over 1 million fish, and if you forget that in good years, then you're sort of exaggerating. But this is a study from Peter Moyle and Ron Yoshiyama that looked at the the cannery records from the late 1800s, early 1900s in the Fernhill Bottoms to reconstruct how many fish were there that fed the canneries, right? And they estimated, in good years, 850,000 Chinook salmon came back to the Eel River. There was one year in particular, I can't remember the year, 577,000 fish in one year were harvested. Harvested, not just the escapement, but harvested. It had this potential for enormous abundance of salmon. That's gone. You all know the reasons why. The harvest in the early days, timber harvesting, loss of the old growth. We had some what we call biblical floods earlier on, 1955 and 64, that filled the channel with sediment. The river hasn't really recovered from that yet, but it's still there. There's no hatchery in this watershed. We have wild Chinook, Coho, steelhead. We also have Pacific lamprey. We have sturgeon that our team is focused on. Those are our focal fish species. So it's got a lot of elements, ingredients that are ready to be reactivated and become a more healthy watershed. I think, dam removal by PG&E is highly likely, but I think our assessments, at least initially, and some by other scientists, including those here today, have demonstrated this not going to be the panacea like maybe we hope to see in the Klamath. The upper Eel Basin is 7.8% of the whole watershed, so if you think about, and it's about 16% of the intrinsic potential habitat capacity, so it may not deliver that grand game-changing scale of response to dam removal. It'll be important though. The dams also host the non-native pike minnow populations and foster those habitat conditions, warm water being and lentic water being those two real key characteristics of the non-native pike minnow, that they thrive there. So removal of those dams will help alleviate some of those conditions. So these other constraints, pike minnow predation, we're now documenting to be very, very present and strong in this watershed. The sediment from those past floods, commercial harvesting, I haven't in my professional career followed the commercial harvest process very closely, but I'm starting to get interested now because we've had 2 years of closure going into the third, and we've had this response of more abundant Chinook salmon coming into the eel. We've gone from about 8,000 fish starting in 2018 when we started our sonar monitoring for a few years. This year we're going to be just under 20,000 fish counted. So we've just from not harvesting, we're seeing a little bit of a response. And so it makes me interested to know what are the effects of that ocean harvest. None of the fish in the eel are marked and caught in the ocean, so we don't really know. There are surrogates for them, but you know how that goes in the modeling world. It's just it's an estimate. So I'm very interested in knowing more about commercial harvest and its effect on our watershed, the eel. The other characteristic of the Eel River is a lot of private property. We have headwaters, BLM, and Forest Service, but most of the rest of the watershed is privately owned, a lot of ranching, so forth. And so that kind of limits access to these places, but also limits the amount of habitat restoration work we can do and so forth. And then the last constraint here is scarcity of data. We do have some data, we're collecting more, but it's such a big watershed. We definitely need to invest more in science and monitoring up front to better understand what we're hoping to do. Yeah, and I was just talking to David at the break about this, this certainty about dam removal. I just wanted to throw this in here and put this in here this morning at Starbucks because it was in the news today. This is just today's headline in the Press Democrat. A small group of sort of private landowners tried to appeal to the Trump administration to have the Bureau of Reclamation step in to buy the Potter Valley project and own it and operate it and maintain it. We've been sort of helping behind the scenes inform the administration on sort of that's not very real and here are the reasons why. And I think we're sort of turning that ship away from that horrible disaster that could occur and instead we're hearing just today, in fact, that they're probably not receptive to that idea. So this is sort of breaking news, really good news, because we want to be on the trajectory of dam removal, which includes a water diversion agreement to continue diversion of water from the Russian from the Eel to the Russian, but without the impacts that we've seen from the current project. So this compromise that we have actually will deliver more water than if they stepped in and bought it. So hopefully we'll get there, but yeah, just threw this in this morning. So our team, with CalTrout being the grant recipient and working with our team of scientists, is leading this other aspect of eel planning. So we've taken the opportunity where the focus is on the dam decommissioning. First it was relicensing, now it's dam decommissioning, and the attention brought to that process to say, we know that's not going to be enough to heal this watershed, bring back fish. We need to do this basin-wide planning. So while there's this synergy, this energy, this focus on the Eel River, we want to do this other thing. So these two things are sort of going forward in parallel. The first is obviously the dam decommissioning process, the license surrender application from PG&E, and all that entails. And then we're doing this basin-wide planning alongside. And so what we're doing is a phased approach. The first phase was completed in June of last year. You see the cover of the report that we put out. It's on CalTrout's website if you want to see that. We've done some data collection, sort of assembling all the information that we have. The plan itself, this phase one plan, proposes to establish a new 501c3 nonprofit organization that would specifically focus on restoration of the Eel River. You might think of the Klamath River Renewal Corp, that nonprofit entity that was set up to oversee dam decommissioning. We're thinking the same thing here, but in more long term, because we may have revenue from the water transfer to the Russian that could support that nonprofit, and that group could be independently implementing phased restoration, science and monitoring, and so forth. So taking it out of, like CalTrout right now is administering a lot of the activity in the eel, but we want a neutral nonprofit that represents the Eel River to take that forward into the future. So we're looking to stand that up. We're building this framework to prioritize recovery actions. There's a lot of things that we want to do and think we need to do across the Eel River Basin, but deciding among those competing priorities is a real challenge. It's one of the reasons I'm here is because we need some decision support and modeling tools to help us do that, right? And so I'm specifically reaching out to the federal partners who are infused with funding and capacity to help do modeling of watersheds to say, hey, we have this great example of a coastal non-Central Valley watershed that you might want to consider, helping us. We would really welcome that kind of support and help. And I'll talk about it in a minute. They've done some really good modeling already in the past. And so that's where we're going. We have great ambitions to do lots of recovery actions in the Eel River. We have a good idea of what needs to get done, and we just need some help, some tools to support how to make those decisions going forward. In the meantime, we're doing stuff anyway, right? We kind of have a good idea of some of those things that need to get done. I, for example, have led several large fish passage projects. We know those are important. We know they're not going to be the game changers necessarily, but let's get those fixed. They stay forever. This pike minnow problem is also something that we've recently tackled. And I'll talk about that a little bit. Just from the standpoint of that question we had this morning about grant programs and science, we had to sell pike minnow management as an implementation project because the agencies wouldn't give us money to go study this fish to understand how they're affecting our salmon population. So we propose to install a weir. The weir is placed in the South Fork eel. We're in our 3rd year of operation. So the weir's intention was to prevent the upriver migration of pike minnow in the springtime when the juvenile salmonids are coming down. They're colliding populations that one eats the other one, right? And so the weir is placed, so we kind of created an implementation project to get around that idea of not getting funding for the science that we need. It's been an important thing, but it just kind of speaks to that structure of how we're approaching our watershed planning and science and implementation. I think there's work to do there. Anyway, let me share. Yeah, so we're operating this weir about halfway up the South Fork Eel River. Again, the purpose is to prevent that upriver spring migration of pike minnow into favorable non-natal juvenile smolt salmonid rearing habitat, so they don't get eaten before they get out to the ocean. We're also conducting, and we've been doing this since 2018, and when I say we, I say the big we, conducting snorkel surveys to count pike minnow. So we have a fairly good idea of the abundance in the South Fork eel, and so you can see the different size classes. You know, many thousands of small pike minnow, but then the larger size classes that are more piscivorous size, they're not quite as numerous, and so you think about a 10,000 population size in the South Fork that are piscivorous size. Did I say that right? Yeah, so we're counting pike minnow, preventing their upstream migration, and then we're running this juvenile telemetry study. This is 2 years of data, and we just started our 3rd year. So collecting, tagging Coho salmon in the upper river, releasing them, and we have radio receivers all the way down the South Fork and into the main stem all the way to, so last year we deployed receivers all the way to the estuary. So we're getting survival data from juvenile salmonids for the first time, 2 years worth of data now, and it's really frightening. These are the cumulative survivals from different tributaries in 3 different release times. So if you get tagged and released earlier, you have a higher survival probability, but these later release groups are virtually all getting eaten. So our cumulative percent survival is about 12% in the eel group. And Gabe Rossi, who's leading this study, has been working with the Russian River folks, and they have a publication. This is from the publication that's coming out. So the Russian River's been doing similar telemetry studies. They have 4 years of data, and they have actually higher survival in the Russian River than we do in the eel overall. But when they normalized it by the migration distance, they were about the same. So every mile that a juvenile has to migrate down the river increases the probability of getting eaten. And so if you get a long river, you're not going to make it. So some of these lower release groups have a higher survival rate. So really starting to probe into this really critical problem in the eel of a non-native fish, not only eating the juvenile salmonids, but they're also abundant enough to supplant them from the habitat that juveniles want to rear in. And so compounding problems there. In that phase 1 planning report, we outlined a prioritization process, and it's based on a multi-criteria scoring approach. Doesn't sound really sexy, but we have to do something with the data we have. It'll be based on our expert ranking, and we think we have a really good set of experts to do this. We also have a really good GIS spatial analysis team, Christine Davis from our program at CalTrout and Stillwater Sciences. So we'll be doing some conservation, sort of higher level conservation GIS planning to inform like 30 by 30. Where do you buy properties? Where are the properties, if you were to buy them across the Eel River, that are the highest priority? How do you connect public lands with migratory corridors for wildlife? Things like that. We're going to be doing that kind of conservation planning in this next phase. But in the future, we're looking to employ more quantitative tools. And again, that's sort of why I'm here. And I think our team is interested in support and understanding, how do we do that sort of modeling at the scale of the Eel River. There have been some modeling efforts in the past. Here are two of them. The one on the left is Emily Cooper. She was a graduate student at Humboldt State University, now Cal Poly Humboldt. CalTrout and NIMS sponsored her to do a study of the habitat capacity above Lake Pillsbury, above Scott Dam. This started in about 2016. She published her results. Brilliant gal. She was really, really, really great. And then Southwest Science Center folks also picked up this and did their own version of modeling, I think expanding the scope of Emily's work into the temperature dynamics in the upper watershed to better understand how that would influence habitat capacity up there. So we have, some work started down the path toward modeling. And something I'm interested in is understanding how the capacity estimates from the publication from Fitzgerald that included Nate and David can be translated into a life cycle model. Because I think a life cycle model is something that would be a little more dynamic, that can allow us to run scenarios and test different things to better understand the responses we would get. And really, so from my perspective, thinking of this workshop as a workshop, and thinking about integrated models, I decided to make my own life cycle model just for heuristic purposes. And so I got a hold of a Beaverton Holt life cycle model from none other than Ray Hilborn. I emailed him to ask a question about one of his papers, and he just emailed me back an Excel spreadsheet, and he's like, here's a working model. And it was really good because it helped me understand the functions that are in that model, in that Beaverton Holt world, which I'm not very familiar with. So I was telling my son, as I was preparing this presentation, I was calling this a fake model. And Tommy this morning said something about being shy about presenting slides without pictures in it. I'm like, dude, I'm going to be presenting a fake model to a group of experts here. You got no worries. But so I do have a fake model. I call it my useful model. Essentially all models are wrong. Some are useful. I found this useful because of that heuristic purpose or heuristic value it had. So for me, doing this was in order to sort of force myself to conceptualize that process for prioritizing. Like let's just go through the fake mental exercise of developing a model, developing the scenarios you want to run, and then try it out. And it doesn't matter what the results are yet. We'll get there. But so this is my attempt. I renamed it the UBH model. That sounds a lot better, right? So I've got my UBH model. I calibrated it to the abundance of Chinook that we've seen the last couple of years, which is about 20,000 fish. So I made it be a fish in, fish out model, right? So 20,000 spawners enter the Eel River. They go through their life cycle out to the ocean, and then we get 20,000 new recruits that come back. So it's kind of a sustainable thing, right? So my model basically has the life cycle of a Chinook salmon, the numbers per each life cycle, and then I essentially had to invent these numbers, right? We don't have a lot of data for the survival percentages or the capacities. We may have some of that, but I tried to put values I thought were representative for survival, and then I had to tweak the capacities until I got the Beaverton functions to work right. And so I've never done this before, so it's totally fake. Don't know how it works. But then I built some formulas in here so I can change the parameters, right? So that's the important part. You have a model, you want to see how it works. And so then I developed my scenarios. And so I think this is something we're going to go through with our team in a more formal way, but this was just me doing it for the workshop. But here are my different scenarios. And these are sort of individual treatment scenarios. So looking at Scott and Cape Horn dam removal, management of pike minnow at varying degrees that would result in varying increases in fry survival during that outmigration, having PG&E as part of their dam decommissioning do certain actions in the project reach. We could do this sort of management thing of continuing to operate the weirs, and conduct suppression above the weirs like we're doing now. That might have a response to capacity or survival. And then actually, at our last CAC meeting, George Bradshaw from the Commercial Fishing Group pulled me aside and says, you gotta consider building a hatchery after they take the dam out on the eel. I'm like, no, we're not gonna do that. But commercial fishermen are going to advocate. He described how they advocated for this on the Klamath, and there is a hatchery on the Klamath. It's going to be there for some period of time. So I think model quantitative results that can provide an answer to George why that's probably not a good idea, and maybe why other things will be more practical in the long run is what we want, right? That's the kind of respect what they're trying to get at, which is abundance of salmon for harvest, and work together to get to that place, not think about the tools first. And so we're going to want to look at this, quantitatively, I think. And I did run each of these scenarios with my changed parameters in the model, and I kind of feel like the results are a little bit believable. It doesn't really matter, but it's kind of neat to see, something's working there. And then I did 3 more scenarios that had sort of combined different things. So the first would be remove Scott Dam and manage pike minnow. And again, this is maybe something that we could require PG&E to do as part of mitigation for dam removal. They're going to take the dams out, keep all the pike minnow from coming back up there, and put a weir at the Cape Horn Dam where the new diversion facility is going to be, and do that sort of thing. So I ran that, and you can see sort of the response. I did this other management strategy that kind of feels like it might be a state agency idea. Let's build a hatchery, and let's do the weirs like we're doing on the South Fork at both, the main stem and South Fork, to prevent that migration upriver. You get a response, and then, this is the kitchen sink scenario. If we did everything that we think we could do, basically, we're gonna need a lot more fish back. So, again, for me, this is just a process to go through, but I think our team will be looking at this as part of our next phase of planning. Through the rendering from Sonoma Water, who created this, to show what the post-dam decommissioning diversion facility on the eel will look like. So we won the battle to determine the type of structure that would go in here, and they conceded to build a pump structure. They wanted a gravity diversion structure that would have required a roughened channel, a continued obstruction in the channel itself, but we won. They're going to take everything. So PG&E will remove everything from the river, and there's a pump house here that will lift the water up into the tunnel to take it over to the eel. So that's hopefully what it's going to look like when it's done. And so what did I learn from my modeling approach? Okay, just going through this process of developing the scenarios. I think those early life stages likely can rely on literature information in a place like the eel. That non-natal rearing capacity, I think, is one of the keys in the eel for bringing back life history diversity. Right now it's occupied by pike minnow. If we can get them out, we'll create more of that. That smolt to survival obviously is key. If we're having 12% of our population are 88% eaten, that's not a good thing. And then really understanding this commercial harvest. And the last thing here, just some next steps for us to think about internally. I really want to look into, I'm embarrassed to say, I just rediscovered the paper, Fitzgerald et al., that David and Nate were part of, and a ton of information in there. Haven't digested it all yet, but need to bring that back to our team and talk more about those capacity estimates and what we can do with that. And there were some really good suggestions from both of those publications on pieces of information that are missing that we can, I think, as a team go after. So that's all. Thank you very much. This is a photograph of Gravelly Valley that's underwater at Lake Pillsbury right now. So you can kind of get an idea of what could happen if we take when we take the dams down. So thank you all. Appreciate it.
So this is Ada Fowler, and she'll be talking about Upper Shasta River recovery actions.
So now for something totally different. So, and what I did not do my own model. I'm not sure why Darren put me last, but there must be a good reason for that. So I'm going to talk a bit about the Shasta River. I work with, I'm Ada Fowler. Work with Stillwater as well. I think 3 or 4 proposals also have put Stillwater in there. So Jay and Roe and Roderick Jones have supplied some of the slides for this photo. So next slide. Oh, I can do it.
Oh, I can do it. Sorry.
Okay. So this is Shasta River, Klamath River. Klamath is right up there. Shasta River comes in about 180 on the Klamath. The dams were at 195, so the last big tributary before the dams. It's a spring-fed river. The Shasta is, especially since Dwinell Dam has gone in, and since a lot of Parks Creek water goes into Dwinell, most of the flow is now spring-fed. And because of Mount Shasta, it's also a desert. So precipitation is 3 to 5 inches in the kind of the center of that. So it's cold water, spring-fed tributary, and not anything like these coastal streams you guys out here, but Coho did pretty well there in the past, as well as spring Chinook and fall run Chinook were all there. And the Shasta is very productive as well. Some of the estimates of salmon were that it supplies about 10% of the water to the Klamath, and up to 50% of the salmon came from the Shasta River. So it's a highly productive system. But it's dry, and it was settled in the 1850s, and most of the water then now gets spread on the land and heated up, and then is returned to the stream really warm, as with everywhere in California. But in the last couple of decades, there's been really significant investment in restoration in the Shasta. And it's been typically opportunistic, like a lot of places, working only with willing landowners, and kind of scattershot where folks, we go back to the same people all the time because they're the only ones that will work with us. It's a really difficult socio-political environment up there. I think I was talking to Betsy earlier, I said, I think the Shasta and Scott are some of the hardest places to work. She says, I agree. But hey, we work there. But, and if we're cynical about it, as others have stated, there hasn't been a lot of change in it hasn't been a lot of positive change with the restoration in the Chinook or the Coho populations. Chinook are averaging about 6,000, I think last year was 44, and Coho are kind of swirling around the toilet. So I'm going to talk about not so successful restoration strategy or plan. Not anything like what Darren just talked about in the eel, but the Safe Harbor Agreement was kind of a change for the Shasta in that actually when TNC bought Shasta Big Springs Ranch, which was a 6,000 acre purchase kind of right in the middle of things here, the kind of first, that's the other thing, it's very private. It was some of the first public lands, accessible lands up in the Shasta. When TNC bought that and was talking about Coho reintroduction, all the landowners around started getting nervous and they wanted to talk to NOAA about getting a safe harbor. So that was 15 years ago that the discussions about safe harbor started. And it was driven by landowners, it was good, but it was very closed. It was NDA closed. They had everybody sign NDAs, so not a lot of public input at all. And to get the take, which Safe Harbor is take, the landowners agreed to do certain actions in their ranch plan. So each rancher got a ranch plan, and there's 14 ranchers. It's about 30 plus miles of river. 30,000 acres that was incorporated into the safe harbor. And each ranch did their own ranch plan, and it varied. I mean, in this area here, we have working ranchers, and then we got California's largest landowner as well. So it varied by the willingness of landowners. And the permit has now been stalled due to some court action. So it was signed in 2021, but then it was sued, and now it's no longer. And you can ask Noah about the specifics of it, because I don't know, I wasn't involved in it, but I'm just trying to work on some of the restoration. So it hasn't been successful. And so the folks that are working in the shafts, and CalTrout's really only one member, lots of people are working there, and and I don't have a lot of slides that show all the partners, but there's a lot of people working. We're working with tribes and landowners and all that as well, but I didn't have a slide on that. But we are back to now working opportunistically with landowners. Before the safe harbor failed, we got a grant from CDFW to do some habitat restoration projects, and we thought, CalTrout thought, starting with the habitat restoration projects, we could gain more public support for the safe harbor. Next slide, please. So this is the safe harbor habitat restoration. We changed it to the Upper Shasta habitat restoration since the safe harbor is no longer. This was funded from CDFW, and we again are working with 7 landowners within that safe harbor. It's about 26 miles of river. And working with Stillwater, what we've done is we've taken the actions from each of the site plans, and we have then used desktop tools such as LiDAR and stuff developed from LiDAR, like RM models and the high-res photos, and we have restoration. We have all these potential restoration actions. So we have this kind of data for like 26 miles of river for a bunch of ranchers. And then each of those are identified. The different types are, are the typical restoration: gravel, alcove enhancement, tributary enhancement, and large weed debris and that kind of stuff. So they're typical restoration, in habitat restoration. But we have those kind of planning sheets for 26 miles of river, and we are moving forward with implementing a few of those this summer, we hope. But that's really not going to be enough to recover the Shasta River. And next slide, please. So I wanted to answer those questions that Darren had in the outline, and just improving the habitat is not going to do it. And there's different elements to kind of improving the populations, and these are biased and mine, and probably there's some that are missing. But landowner participation, we have a real problem with that. We have funding. You'll need funding, and you need support. Right now, there is not community support for this safe harbor, this restoration plan, we can call it, likely due to the way that it was conducted, very privately, without a lot of input. And that is one of the reasons why it was sued. And we need to start implementing projects. We've been talking about these projects for a long time, and I think if we start implementing good projects, we want good projects, we would get more support and more landowner participation. And there is an issue with figuring out what the good projects are. There haven't been modeling, and NOAA didn't really even prioritize the projects in the safe harbor plan. So we are, I think we know what the good projects are, but it would have been nice to have a little bit more data on which projects we should prioritize. And we not only need these habitat improvement projects. I mean, Shasta is a cold water stream, and right now, most of the water is extracted for irrigation. We need flow enhancement projects, and those flow enhancement projects are the irrigation efficiency projects and the infrastructure projects, and these are the ones that are very contentious and currently held up. We've had a pretty good project that's been held up for 3 years now, and we think it's going to go forward. We finally got support for that. And like others have said in this session, we need monitoring, really good monitoring. With the current funding that we have from CDFW, as I said, we're going to implement a handful of these different projects, and I am going to put in each of the ongoing projects that I get, because we want to design a few projects, implement them, and then get money to design some more. With each funding, I'm going to ask for effectiveness monitoring, because really, we don't know what's going to happen with some of these projects, and as other folks have talked about, we need to monitor for effectiveness and make any changes that we can to the design of the projects to make sure they're working as we think. Because if we put VDAs in Big Springs Creek, we don't know what's really going to happen there, and before we put a bunch of VDAs in Big Springs Creek, we need to monitor for effectiveness. And finally, just monitoring. Safe Harbor, one of the good things I thought about Safe Harbor was the monitoring plan. It was a really good telemetry monitoring plan. There was issues with it. It was like public access. That was one of the issues with it. But it was a pretty a good monitoring plan with flow and temperature and diversion monitoring included. And because we don't have that Safe Harbor kind of umbrella, it's going to be piecemeal. It's still being conducted, but it's going to be more piecemeal than it was. Okay, next slide, please. For full recovery, I think we got one thing this year that I think probably is going to help with full recovery, and we got a really good water year to help flush it all out. So the Klamath dam removal. From my understanding, and talking, you can from my understanding, talking to some NOAA folks, is that potentially with the dam removal, Chinook at least in the Shasta could be as high as 10,000 to 15,000. My understanding with that, so that's pretty cool for Chinook. It's going to be pretty exciting this next decade or two to see what happens. I'm really looking forward to it. I'll be retired by then, but that's okay. That's all right. Coho, I don't know what the impacts of Coho are from dam removal, but some up, you're saying, but still that whole 1 year in the Shasta is probably pretty critical as well, and I think it's not going to have as dramatic effect, and maybe, Coho reintroduction is the way to go, and they're starting to talk about it again, maybe not. Tommy, I'm looking at him back there, he's making all kinds of faces.
I like the first idea you had.
Maybe not. I mean, it doesn't appear, when you look at the Shasta, it doesn't appear like a Coho stream, but there were Coho there, and I think the NOAA goal is a couple thousand for more than that, 5,000, that's right, it's 5,000, so it is there. And then we need functional flows, we need better water management in there, and I'm not really going to say anything about that because it's tough. It's tough with climate change, it's tough with water law, it's a very tough thing to do, but we need to have more flow. When you have a river that has higher flow in drought years because of emergency regulations versus wet water years, it's a problem. So, I mean, we can have as low as 20 flow in some water years, and we now have 50 flow with the emergency flows in the drought. So, that's a problem. Next slide. This one's kind of like Darren's, but we need to think about the other barriers in the Shasta, and there's a couple other barriers still, one big one, but not only the physical barriers, but also the flow barriers. This is a picture from the Little Shasta, which is the lowest tributary And this is a Basie Springs was probably 3 to 5 CFS. These were pitchfork, I'm sure. They were not caught line and sinker. But Basie Spring now is diverted solely for irrigation. It never reaches the Shasta, the Little Shasta. The Little Shasta goes dry at River Mile 12 in April or May, and it doesn't connect until November, December. Sometimes it's dry all year round and never reconnects to the Little Shasta. So we got to think about those flow barriers as well, but just better water management. So not to end on a bummer note, but that's all I have.
Darren, what does pipe ditto management look like?
Well, part of it's the weir that we're putting into the river to prevent upriver migration in the spring. We are doing suppression, so the last 2 years we've been learning how to capture and kill pipe minnow. Part of that had to do with overcoming some agency resistance to doing that. So we use spearfishing, angling, gill netting, and electrofishing. And so we're kind of evaluating the catch per unit effort. Electrofishing seems to be more effective, so we're scaling up that effort. We're also conducting a derby, so we're getting the public involved. This will be the second year that the Department of Fish and Wildlife is permitting our derby. CalTrout's giving prizes so we can get more people sort of interested in that. Yeah, that's where we're at right now. We're trying to get to, thousands of fish removed. The first year we took about 500 out. Last year about 1,000. We're trying to scale that up even more, so that approximately 10,000 fish that are predator size, we want to really put a dent in them and see if we get a response, like greater survival, rebound in adult abundance, that sort of thing. So for a couple of years, we're funded for a third and fourth year in the South Fork right now. We have a proposal out to take that work into the main stem as well. It's not funded yet, but we hope that we can start to move over into bigger full basin implementation of that.
One other question related to the deal. You mentioned the snow water. Have they always paid for that water?
They've never paid for it.
They've never paid for it. Okay, that's interesting.
Never paid for the water. So part of our water, part of the water diversion agreement will have $1 million a year going to the Round Valley Indian tribes, along with the water rights. So the pre-1914 water right, the PG&E Indians will go to the Round Valley Indian tribes, and then $750,000 to Humboldt County for restoration. That's part of the deal that's not signed. It's part of our MOU that's signed. So we're getting there. But, yeah.
In perpetuity?
Yes. Well, for the term of the water diversion agreement, which is 30 years.
Forever.
We'll see.
Yeah, in perpetuity always makes me good.
Other questions?
Jason.
I find the range of restoration recovery efforts that we've heard both in the morning and the afternoon now really impressive. And I'm still trying to wrap my head around it, but is there a master document or plan or playbook or something? Or are you each kind of inventing your own version of a wheel every time? Because in where I work, we're reinventing wheels, or we think we're inventing wheels. And I think there's a lot more recovery going on, and you've been doing it longer. And so I'm wondering, have you started to consolidate and say, if you were starting at the first step on the board, what do you do, and how do you take it with a vision towards the 20th step? So is there a master plan somewhere, or any of you?
No.
Work? No. All right.
Tommy wants to say yes, but he's
So all of these have listed ESUs or DPSs, and so there's a recovery plan that has a list of activities and targeted actions and populations in it. There is some framework within the recovery plans for these basins.
what you've been hearing about though is how do you make them actionable?
Yeah.
How do we find both the cultural momentum, the dollars, the certainty, both scientific and political, in order to act, and to act at a scale where we can expect a population level response? And that's been very difficult. And what you've been hearing is inventing that wheel, actually changing the world that salmon swim through. Yeah, I think that to a very great degree we are working in parallel often. But I think it's very it's the healthy competition of evolution. I mean, I think that we're converging on ways that work. We've been hearing similar themes again and again today, right? Big picture merged with actionable specifics. We've been hearing about the need for not just perspective, but all the perspectives coming together early in order to collectively create a vision that we work towards. But Jason, no. I mean, I would love to work with my colleague, Darren Mierau. We work in the same small organization for the last decade and a half. And yet I was just looking at Tim here. We're doing a strategic action plan based on the Wild Salmon Center's work in Oregon that Tim talked about in Butte Creek, that in many ways is a recapitulation or in parallel to the recovery plan that Darren did. Can we get together and discuss it? Yes, hopefully that's what this will lead to. But in a lot of ways, we continue to work in parallel.
There's a tension, I think, because every watershed is different, and so to a certain degree, you have to sort of reinvent your own wheel. But on the other hand, I think we've been doing that too much, and so there's opportunities to learn from people who've had successes, but then it's still qualified if that success pertains to your watershed, because it doesn't always.
Well, I think that's why we wanted to do this, right?
That's why we wanted this workshop.
So, right. So,
well, it's exactly to start talking about these things. Everyone has their head down,
right,
focusing on their thing, and but we feel like it's going very slowly.
But there's inherent problems with the grant programs. If you go back to the CalFed Bay Delta program, it started out with some demonstration rivers, and they were funding. There were 3 of them in California: Tuolumne, Merced, and Clear Creek. And the departments were funding those places to make them work. And this was back in 1997, right? Mm-hmm. And then that collapsed. Since then, we haven't had that strategic investment in specific places that allow us to learn from those places. Instead, all the grant programs just scatter their money across a lot of different user groups, and whoever's good at writing proposals does well, the other groups don't. Even if they have a really valuable watershed or good opportunity, they don't make it, they don't compete. It's a bad model for doing this kind of work. And I've tried to argue with CDFW about that kind of demonstration. Let's invest in specific places, and they're resistant to that. We just haven't gotten there with. I think we need to restructure the way we do funding for our efforts.
If not us, who, right? If not now, when? And I think that's what we were after today, was trying to both compare and contrast, because absolutely every place is different. Every population has its own issues, its own opportunities, its own challenges, but also there are really strong commonalities that we need to bring together into these recipes for recovery, in which the frameworks, in which the specifics of each watershed and each community working in those watersheds get to work, get to come together to actually solve those things collaboratively. And I hope that you guys are going to throw those back at us today too, the things that you saw that tie this stuff together that are common.
Yeah, so I'm curious, I know in the Scott and Shasta watersheds, the North Coast Regional Water Quality Control Board is looking at establishing new basin-wide waste discharge requirements relating to non-point source pollution with cattle. And I'm curious, for those who work in that watershed, kind of what insight you might have on that, and then how that kind of approach may be applicable in other agricultural watersheds as well for funding restoration and removing some of the impediments to it.
I actually don't know. I can't answer that question. I haven't been involved in that. I think my superior is more involved in the TMDL stuff. I don't know, Betsy, if you have anything to say about it in Scott. But yeah, I can't answer that one.
I can tell you There's a temperature TMDL in the
Yeah.
Shasta already, and the regional board's given 3 5-year waivers to it. So basically, they establish what's required and say, oh, but you don't have to do it.
Yeah.
3 times, 5-year waivers.
There's a
So
new one going in now.
they're gonna start that whole process again. I mean, don't get me started on the regional board, but it's the most frustrating agency there is. They have a Clean Water Act that they're responsible for implementing, and they don't. So I would not buy into a new process.
How do we get it implemented?
Yeah, we're gonna have, yeah, right.
So I think there's another perspective. I work for the San Francisco Bay Water Board. We have WDRs in the Tamales Bay, West Marin watershed. And they were actually instrumental in pulling the grazing community into, but we were very committed to it. So where you have regulatory commitment, you can actually have action. When NOAA wrote the recovery plan for Coho in a creek named Walker Creek, they hadn't been there for 10 years, and they were like, that creek is trashed. We were like, no, 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 we did this WDR. Come on out. This was on Butte, et cetera. Come on out, and you're going to see a transformed watershed. So much that they started doing the reintroduction of Coho there. So yes, the WDRs can work, but they have to be developed in concert with the grazing community. We actually worked probably for 5 years with the grazing community, and there was a very proactive component of the grazing community that helped us roll it out. So I think these things can work, but it's just like everything else we've been talking about. There's the specifics that really, really matter. The community, bringing the community up together, making the regulations kind of stepped. We made ours pretty stepped. And we're in the process of rolling out more strict regulations. And again, we're not getting pushback though.
Leslie, would you think that there were producers there that would be willing to come up to the Shasta and Scott and talk with other producers?
Like that. I'm pretty good friends with quite a, you guys all probably have the, Point Blue, the Point Blue cheese. Okay, so he was an instrumental, Bob Giacomini, instrumental guy. He's not going outside his watershed because he's not going to spread something that doesn't belong outside his watershed, that he doesn't know. He's not sure. He's also probably 90 at this point. But at any rate, these things can work just like everything else we've been talking about. It's the specific, it's the will, it's the bringing the community up together, not just imposing it. But so I just want to say, Darren, it can work.
I don't disagree, but it hasn't.
Yeah, no, that makes sense.
Well, so the question is what would work in changing the minds of people who are entrenched?
I don't know, I was just going to say that, in the era we're in, it's uncertain whether the big money is going to be there to, do things on a big scale. And doing things on a small scale, you have to think differently, and you really have to get that community buy-in and figure out how to sort of motivate things to happen on a small scale. The future for where we're headed seems very difficult. But if we can try to find small things to do, at least in the near term, maybe that's going to help.
Let me share something that maybe ended a little differently than what Leslie was just talking about. So in the Sac Valley, where the agricultural community has really not just rallied behind, but led the implementation and the understanding of how you would execute a bunch of these landscape scale wildlife and environmental enhancements, the ag community was willing to talk with other communities, and one where it seemed like there was a lot of parallels was the upper basin of the Klamath. And so we've been having, kitchen table talks with groups of ranchers from both the Sac Valley and from the upper Klamath, where you get these big Sac Valley guys saying, hey, stop fighting, you're gonna lose. One of the most influential rice growers in the valley turned to his colleagues, in the upper Klamath and said, if you guys don't start kissing suckers, you're gonna be out of a job. And I think that there's some real power in that coming from peers, people that they really respect, that would never have the same impact if it came from a regulator or an environmentalist like myself. And so I think there is real power to do that. It doesn't come easy. It doesn't come always, but I hope, as we were talking, Betsy and I were talking, that we do have the capacity to come in and maybe help a little bit by bringing success stories from other places to where they might be resident.
A question over there too.
Yeah, similar regards. Question for also all the talks this morning as well. If you've had, I'm curious if you've had any kind of examples of that kind of full-scale cycle of the ecosystem and the economy not necessarily being separate, but having the full circle where maybe you've got some lines of communication that have been built because you start with the fish and then it realized that the real solution is the bottom line of the growing and the agriculture, whatever it is. That's the conversation starter is not necessarily the end if there's been any economic benefits to projects that others that wouldn't have seen, maybe have seen. That's clear enough.
Yeah, I think what your question is getting at, maybe the timber industry on the North Coast has realized working in partnership with restoration entities to fix their roads, because there's a lot of public investment going on in those private timberlands now. I think that may be one place where I've seen that.
Yeah, I would say we also, at least on the TNC projects, we often try to make sure that timber companies or landowners doing voluntary restoration are able to share in the economic benefits of a restoration project, whether it's purchasing timber from them directly on site and paying them mill prices that they could sell their logs at a mill for, but we're taking them right there, so there's some cost savings for them. We're paying landowners for access or temporary use of their land or taking pastures out of production, all that type of stuff. Because we are asking something of landowners if we're asking them to give the creek more space on their property that otherwise they would use for their own economic benefits. So just trying to increase the size of the tent and bring more people in to the kind of little economy that we have around restoration projects has been pretty helpful.
So similar to in the Central Valley Reorienting to Recovery, in our model, we asked the participants that were there, what are the values that you care about? And so we included impacts to water deliveries for municipality, ags, and refuges, how much farmland was lost in production, fishery harvest quotas. So, and for some of those with further development, I think we could put it a dollar amount to associate with that. But I think making the tent big, bringing in lots of people, asking what they care about, and including that, we included it in our life cycle model. And so in the alternatives that we're modeling, we could see what are the bigger impacts that they had, and then you could take that to an economic dollar. And I think the economic dollar part, I think that we should have more economists working with us in pushing these issues forward. I think we're really lacking kind of in the fisheries world, so I think it's a really great idea that needs to be expanded upon.
Not to put a value of money on everything, of course, but just that if there's that full cycle connection, or just by adding more water to the fields or more geese, maybe there's a fertilizer effect that actually has a free resource that goes back into perpetuating the cycle.
In all of these, there's really two aspects to this, and the reason that the top row of all those logos included are the actual growers, the ranches themselves, where there is an economic incentive for what happens in that specific action. And through that, the bird and the fish folks working together have created a whole menu of environmental of subsidies, which can be paid directly to growers to create environmental enhancements on their farm, right? And with the fish food program, it's not just habitat that is produced on farm, you're actually exporting that currency, the protein created in wetlands back into the aquatic ecosystem. So there's both an energy flow there, both of hard currency, of money, and of natural currency that's going on. But the next level down, those are the large ag groups and the water. So the Northern California Water Association represents all of the water suppliers to all of those farms. And then there are the trade groups like the California Rice Commission. They're thinking about the economy in a larger scale, right? And so they think about what happens to our water supply if we have a failing delta ecosystem. That big picture thing is going in parallel with the growers that actually pay dues into that association, right? So it has to make sense at each one of those levels. But when it does, when you can propose a series of no one event, but a whole bunch of actions that can fit into the way that they do business and their cropping schedules, their way of life, then you start to see all of these pieces where there's a cultural turn, where people that had for generations felt villainized, felt like they were the bad guys, are now part of a collectively held solution, and you just feel the whole room switch. And that's what we were talking about by aligning ecologies and economies. And I think that largely that's what our science is pointing to. That's why diversity is the foundation of resilience in both economic and ecological systems. And we're getting to systems that actually work, that function, but it takes all of us working together to get there.
It's a question
So in the Scott watershed, sister watershed to Ada's, we're looking at developing a large-scale restoration model through the main stem that involves floodplain restoration and all that. And a part of that was an economic analysis, because this is private working lands, and if you're going to move the river out of that channelized, drained, you're starting to interact with people's private property. So we brought in an economic team, and they found that that land was super valuable in terms of, one of the things they used is they did a survey of what would all the people in urban areas, those people, pay to have more water, more fish. And there was really a lot of value with that. And we thought, oh, great, we're going to take this information back. And our landowners are going to be really excited because there's an economic model for this. And the reaction we got pretty universally was, if you bring that out into the public, people are going to decide that our farms are worthless and they need to be taken away and used for this production. So this issue about how to think about the economy, how to have that conversation is really difficult and nuanced, and we would love maybe to have a session to talk about that and think about it more and think more deeply about it. Because we thought, wow, we're really hitting the mark here, and it was a total, like, get out of here, we don't want to hear this. So just reflecting on an experience we had.
And I will add that when you have your tribal partners in the room, salmon are not a commodity.
Yes, we've had that discussion.
And so it's a different system for them. So it's a good conversation to have, though.
You know, this is really fascinating because in Napa, with the wine industry, we've had a lot of success with the wine industry initially leading the charge. They were under pressure from the local citizens group to have a required stream buffer. They saw the writing on the wall and they were like, we don't want that. We want to voluntarily figure out what we want. And so they led the charge, and we have 15 miles of stream that we have nodes on. And a lot of people at SRF have seen our tours. And what I was just thinking is, it would be so great to have some of the agricultural folks and the winery folks talking about how they framed it to their constituents. Because we didn't do it, they did it. And then we were able to come on with grants and with technical support and stuff. But actually they led it. And I don't know what their economic model was, but I know that in some of the biggest wine industries in the world, we thought it was all local, and then we discovered, no, some of the bigger ones, Constellation Winery. I'm a little worried about tariffs, how it's going to affect the Napa industry. But it'd be really cool to have a panel of our industry folks who have stepped up to the plate. Because I think the Russian River is different. I don't think they're stepping up to, I'm not sure, but I've heard people say, really, your wine industry will give up 100 feet of riverfront? They'll pull vines and let you have that much river, which is not that uncommon. So it'd be really cool to hear that dialogue, actually.
rationale for buying into that was, the wine growers?
Well, one was the pressure. They wanted to do it on their own, and they wanted to lead the charge. The second was, though, green labeling. The third was they actually do buy in Napa to the community perspective. It's called the Living River. Somebody else spoke about a living river. We did a big poster, just like I think you were talking about in British Columbia, where we had artists up on the front doing a vision of the Napa River, and the citizens termed it the Living River. And the vineyards have embraced that. And so I think it's tiered. It's economics, it's public perception, and then it's also community involvement. And I don't know why would one of the biggest wineries in the world, wine cellars in the world, go for this? I don't know.
Marketing to their clientele.
Yep.
In part.
Yeah, that's right. Yeah, he just said they can afford to do it.
Well,
That's
that's
why I'm a little worried about the tariffs.
Yeah, there's got to be, everybody's got to have some self-interest in it. Like the Mill Creek example, offering the idea of, maybe you'd like to share your reservoir with the fish, and some people are not into that, but enough people are just like, well, we'll let you have half the water if you can share half the water in certain years under certain conditions. They're at least willing to talk about it. And some people are eager to, and other people, it's like depending on their situation, it helps them out with, a pond that was there with no water rights, and they've got to figure out a way to rationalize it, and that gives them enough of an avenue to deal with the division of water rights to help them out, and then maybe that works for us.
You know what, I forgot. There were levee wars on either side of the river. And so a big flood would come along, and one landowner on one side would raise our levee, so the other guy would flood. Then the next guy. And so what we were able to do is say, and everybody agreed, we'll set the levees back 100 feet, but we'll build them to the same 10-year standard, and nobody can adjust it. And everybody agreed to that. And the second thing was, there's a disease called Pierce's disease, and the non-native riparian zone is a host. But Fish and Wildlife wouldn't allow without a lot of work, the vineyards to remove the non-natives because it was in the riparian zone. But the grant program and the restoration program was able to remove all that non-native vegetation and plant with non-host species, which increased the vigor of the vineyards significantly. So I actually forgot, that was a big part of it.
Yeah, if we can figure out a way to inspire the people of the Shasta Valley, which are very conservative, Sissy County is very conservative, and there's not a lot of public pressure to it, and there's just not a lot of, we've tried thinking about water transfers, but there's no big cities down there to do it, so it's if we can figure out a way to inspire folks of Shasta and the Scott to do something, that would be awesome. Not, they're land rich and money poor. They have all this land, it's cow-calf stuff, so the economic drivers aren't there for them either. So it's very difficult to work there, and so I'm open to anything if we can figure out a way to inspire them, and they're very resistant to change. How many study plans have been developed in the Shasta that have never gone anywhere to study in-stream flows?
I wrote one.
Yeah. A bunch of them, and it's just,
And programs, there was the Watershed Wide Restoration Program.
Yeah.
And then the Safe Harbor.
And public support, the public is always brought in, and they're cautious, so it's a real difficult place to work, so I'm game.
If they're land rich and money poor, can they be enticed into conservation easements, acquisition of some portion that they own, so they have some money, and then we take a piece of their operation? They have to reduce their...
Conservation easements haven't really worked up there. TNC is now, Jen can talk about that probably more than I can. TNC bought Shasta Big Springs Ranch to try to use it as a restoration kind of tool to see what worked and stuff like that. And some, it happened. They sold it to, we sold it back to CDFW, and the county has not been supportive of any more kind of land acquisitions. I don't know about easements. I don't know if TNC's trying easements or anything like that. Might work, but
Can I share, I mean, it is so hard, right? We all share that working in, especially in private working landscapes and historically extractive industries, it's a difficult place. And the momentum and coalition building that we've been able to see in the Sacramento Valley was just built on one relationship at a time. And it wasn't just opportunity, it was trying to find those pillars of the community that both, you said they could afford to. It's a big piece of it. Often those big places, they're respected by their peers within the local community, but they also have the cash flow to really think a little bit farther down the road. And when those kinds of folks begin to say, listen to the kid, you know, there's something here that ducks and especially fish are a better protector of our water rights than any lawyer is ever going to be, we should probably be doing this. When those guys say it, it has a completely different resonance than when we do. And there's no way you can go to that table and tell them how it's going to be. What you might be able to tell them is what it could be, is a way of laying out a vision, a science-based vision of how maybe the acrimony that all of these communities have existed in for years might be lessened with the additional benefit of better environmental outcomes. And if you can lay out those possibilities and not tell them how to do it, but tell them how it is, often they have a better idea on how to achieve it than anything that we would come up with from the outside. And I found that those two things really were kind of the secrets to success in starting to pull the water and the ag folks together. It was not dictating from a San Francisco-based environmental group or from an environmental regulator. It was an honest sharing of some scientific insights and then a humble request that they share their expertise on how that place works and how it might work better.
Jake, I think it's important to acknowledge that where you're working in the Sacramento Valley is a place where probably the most famous SRF person ever came into the Sacramento Valley after his commercial salmon business died. Started working with those landowners. His name is Nat Bingham, and everybody should recognize that name.
Yeah.
And he came together with Mark Reisner, who everybody should recognize as well. And they started working with those rice growers, and everything started to change.
Amen.
Really important connection.
Yeah, no, it's, again, relationships, and that they're intergenerational, and no one of us is gonna, tip it, but that there's a patience there that really is necessary. If you don't understand the other person's concern, you can never really hear them, and they're never really gonna listen to you.
That was 30 years ago.
Yeah, and we might be getting somewhere in Battle Creek.
So I have a question then. So 30 years, is there a way to, what are some thoughts on how it could be less than 30 years? Or you mentioned it took 5 years just to get the duck people and the fish people to talk.
Can we look to the Klamath on that one? 30 years? We got some dams out, 22.
Yeah, I mean, the real push was at the fish kill. I mean, the battles before that, but they took a turn at the fish kill and the tribes got together and went out a different route. So kind of think about 2002, 2001, 2005 was, 06 was the trial-like hearing. Pacific Corps at that time had to provide passage. It was too expensive, and then there we went. It was also the shift from the agreements to the FERC process. But that was all triggered pretty much by the fish kill.
So, a regulatory forcing event, right? What's next?
Well, or environmental. I mean, the drought in the water and the demands on that water in the upper basin triggered that with the fish kill. Yeah.
I guess the question is, how can you accelerate, right? What lessons?
It's accelerating on us.
It's happening, right? Does everyone feel that? It's getting faster? No?
A little bit.
Well, it seems like, you know, all the similarity of all these presentations about how it's happened, I mean, there's certainly, whether we know it or not, it is coordinated. People are taking the same successful lessons and at least applying them. It doesn't seem like it is going to be fast, though. It'd be nice, but I don't know. I think it's just a slog, but requires people to be committed and look for their partners, look for people's self-interest and engagement.
I don't disagree with that. I was hoping maybe the faster. Are we getting better at this?
Yeah, I think we might be getting better, but I think climate change is really affecting our work. I mean, stuff 10 years ago, 15 years ago, we'd be making progress. We're just kind of holding it. So I think it's going to be a slog. So, and there's places like Shasta, which Shasta has cold water. If we can just get it cold and to stay in stream, it can be it can be very resilient, but it's a tough place to work.
Do you think how you look at getting faster can help to unlock it? Like, is it faster to the end, or is it faster to starting to get results? Right? Because I think one of the things I see in rooms I'm in is the target becomes the optimal end result. And that is far, and it takes a long time. But if the target is, can we take that first step to making it better? And instead of getting bogged down with, it's going to take us 20 or 30 years to get to the end. But could we, this is kind of my question to Liz, is there a way to shortcut the start, right? To get going where you could run a mega model and take 3.5 years and then take 10 years to sell it to people. But could you run a micro model and say, these are probably the top 3 things, and you can wrap your head around them, and we can start working on these now. So it's faster, maybe combining kind of timelines and scales and tactics and finding ways to use the totality of all of the options. And maybe that, it starts to look faster because you're starting to see action and change and alignment while you still have the big tent and the big umbrella.
We've taken this approach. My colleague Mary is here, who works with me on the North Coast in Redwood Creek, which is from Redwood National State Parks. The estuary has an Army Corps levee project, and there have been numerous attempts to get the landowners to buy into modification of the levees. They haven't succeeded. So Mary led a process that started with the landowners and had that dialogue with them first to understand their values, and then the places where they are willing to go, how far they're willing to go. So it's kind of go slow to go fast. I think it's been successful. We've gotten through that collaborative building process. The landowners are leading it, and now we have an Army Corps Cap 1135 process feasibility study to remove portions of the levee. So we had to take 6 years, literally, of meetings to respect the values of the landowners and understand where we're trying to get to before even starting a grant that took us down the path. I think maybe that's what you're suggesting. So like, identify the first thing first, which is building the willingness to collaborate before trying to accomplish the goal. And it's worked. Congratulations to Mary for leading that process. And yeah, it's a good example.
Can I add on to that first? So for reorientation recovery, we should clarify that the 3-year process was like year 1 was spent with the group defining what we collectively thought quantitative measures of recovery looked like. Year 2 was really engagement with all the participants, building this big tent that everyone brought in collectively. And then year 3 was spent on the modeling. So the model itself wasn't a 3-year process. To be fair, we took an existing model and added onto that, and Liz could probably speak to the timeline. But the year-long modeling process was really like, I don't know, it was less, I feel like it was less than 6 months to build out the model, and then the year-long process was hearing from participants, what alternative actions do you want to model to achieve recovery? Sharing those results with them, taking their input, going back, reworking, like, you know, because we look at trade-offs between alternative actions, and people would say, like, we're losing too much ag land or we don't have enough water. So then we take that feedback and then we'd like tweak things in the model and rerun it. So the year-long process was really to give the feedback between what the participants of the group wanted with the modelers having time to explore that, model it, incorporate it, and then like feed it back out in a very general term that people could understand. Let's spend a lot of time making very good graphics and shiny apps so that people could actually explain that process. And my optimism is that, you know, all of us have talked a lot about the partnerships and the participants that need to be involved, and I hope that once those groups are in place, I think that it's really important when a project ends to keep those groups together so we can continue that conversation and hopefully speed up projects so that in the next 10 years when we're really facing these climate change difficulties, you already have the group in place that have this long history of working together and don't like want to give that up. So I feel like when a project ends, like don't stop your partnership. So you have to keep those going to keep momentum moving.
I'll say a few things about the pace of change, and my colleagues that work on Hwang Creek will maybe say a few words about this too, right? We anticipated a fairly long period of time to prepare the watershed for reintroduction of steelhead, and then all of a sudden a fire happened, and I was getting a call from my colleagues being like, are we ready to have steelhead? and it was like, holy cow, like I don't know, are we ready? And so it happened super fast, and that was, we didn't get the steelhead in the end, they went to another place, but it made it really real. Like, are we ready? And that accelerated us. I think that sped up our process because it was sort of like, maybe we were thinking on too long of a timeline and things can happen faster. We're in sort of the rapid pace of change of the world in general right now has negative consequences, but it might open opportunities as well. And so I don't know if my colleagues want to sort of chime in on Halama and our lessons learned from that experience, but which we're still learning, obviously. But I mean, I think we were shocked a little bit how fast things could possibly move under the right sort of constellation of circumstances.
Yeah, for sure. I mean, I started this postdoc in September, and to be honest, it's a 2-year postdoc. And to be honest, I thought the chances of getting fish within those 2 years were relatively low. And then I'm like, okay, I have 2 years to sort of, really plan with our team, and develop this reintroduction plan so that, we can start to, pick and choose where the fish are coming from, how many fish, what life stages, where are we going to put them in the watershed, and how we're going to monitor them. And then in January, my colleague Walt back there calls me and say, hey, they're moving fish tomorrow morning, and they might go in Hwang Creek. And it was like, wow, yeah, that was a huge reality check. And then, we're trying to send the agency as much information as we can so they can make the right decision on where to put those fish. But it definitely has accelerated our timeline in thinking about all the things that we need to get done right now so we can be ready to get those fish the next time something like that happens.
Yeah, and provide the information needed to those who have to make a decision as to whether or not that's the optimal place to go. So we also, there's are we ready with the information, from the science side, it's like, are we ready with the information that they're gonna need to make this decision?
Yeah, I think that's right. I think we talked about earlier in the session that juxtaposition or balance, if you will, between scientists want to take the time, having the right answers and really model and develop out the pathway for anything, whether it be restoration or recovery or translocations. And then, maybe it's put the fish in the river and put the river in the river and go, right? And I think part of what has not been spoken in a lot of these stories that all of you have worked on for your lives is opportunity. And sometimes it's not necessarily the funding or not necessarily the science, but opportunity comes, and we need to take advantage of that opportunity. And part of the story that was not told here is really, somebody asked the question of, is there resistance to moving fish? And the answer is yes. And that's something, that Eric and Matt and I have been thinking about. Okay, how do we work with that? How do we inform that process of really considering working with Carlos Garza, really considering genetic structure? All right, check. We don't have to, Carlos says we're good. We don't have to worry about that. Okay, well, we really have to worry about disease, because we don't want to introduce fish into a basin for disease reasons. 100%, for sure. We don't have fish. We don't have diseases. Check. I think we're good there. But part of it
of that opportunity are maybe, what is it, like opportunistic baby steps, right? Like enabling conditions, right? So CDFW had to move those fish in order to maintain an imperiled, critically endangered population. Okay, it was done. Okay, we can do that. All right, maybe let's start thinking about doing that in a planned fashion. Maybe let's start thinking ahead about when that next emergency comes. And they're thinking about that. So that really is an enabling condition for us and for other partners to really think about that, of how we do that in a planned fashion for some of these other places that might need it. And I think that's kind of another thing that is important for all of this, is really, there's hurdles. How do we get over those hurdles? Because we need to. And we're at the point in some of these places where we really need to lower those hurdles, and we really need to recover a critically endangered species or a critically endangered population. We can't wait anymore. We can't wait for science. We need to actually take some bold, as Matt said in his talk, make bold decisions and really advance conservation and science and recovery.
Maybe a simple way of thinking about that, Jason, is simply that success really does build success. And there's nothing that looks like success that embodies abundance quite like salmon. And so those places where we can really look to the fish, to that exuberant response and to abundance from little quickly, it's really important galvanizing, leveraging events. And I think the Klamath makes a really, really big difference. I think that Potter Valley is going to make it a lot quicker in Butte Creek and in Battle Creek. I think that nothing translates exactly, but I think that we're getting the muscle memory towards understanding things from that larger scale, from a process orientation, from a sense that if we don't do this stuff, what the hell do we expect, right? I mean, it has to, and so, I don't know, I'm taking a lot of hope that we're actually starting to act at landscape scale and therefore beginning to expect a response, something that's called recovery.
Something you just said triggered a memory I had of a scientist making a comment that, we're doing all these recovery actions. This is 20 years ago. We're doing all these recovery actions, but we don't see any response. And I think, what we've heard today, what we know more broadly, we had some canceled presentations on places like the Elwha River, where, in fact, we have seen recovery in places that have been suppressed for decades or a century. And the needs of salmon are pretty well known. Right? Very clear, crystal clear in some places. And depending on where we are, right, the barriers to bring those back can be relatively low or really, really high.
Or multiple.
And usually multiple, right? And so George Pest was invited here to talk about the Elwha, and one of the things that George has said repeatedly is the cumulative actions and the benefits that come when you address multiple threats. And that includes the fishery and the hatcheries and habitat, passage, and sometimes it's introduced predators, water quality, all those things. And, that's really interesting to me to hear the discussion of the different places, different physical, geomorphic settings, biological settings, cultural settings that we're hearing people work in that do present unique challenges, but then the fish actually just have the same basic needs everywhere. And that, I think, is what we can kind of work back and forth from. It's like, how do we deliver those requirements with the setting that we find ourselves in? So I don't know, it's pretty exciting for me to hear how the world looks in these different watersheds and different communities.
Can we ask
Will have a question.
Oh,
Will have a question.
Oh, wow, thank you. So I was just wondering, we talked earlier about, slow versus fast. And when we can move fast, as we're working slowly towards a long-term goal, and there's some principles we can follow, that way we don't look down the line and say, wow, we really messed up things here, and it's gonna be a lot of work to untangle this. So I was just wondering if we could review some of those principles, maybe see if folks have other ones in mind, where it's like, this is what we know, this is crystal clear, this is what we can follow to do now, act now as we're learning and assessing the risks and rewards to make decisions in the long term. Like, what can we do in the short term that we're pretty confident about?
I would say one principle is don't go forward without the landowners who own the land. If you can't bring them along, you're not going to get there.
I would say we worry a lot about the biological or ecological risk, and maybe too much about that, and maybe not enough about the social risk of moving too fast. I think the social risk of moving too fast is probably greater, but we don't think about it as much, and the ecological risk is probably less, and we spend a huge amount of time thinking about it. I don't know if folks agree or disagree, but I guess that's my response, having thought about it for 5 seconds.
With the safe harbor points you were making, Aidan, like others earlier, like if we move too fast socially, then we're like wasting money on litigation and like starting back, you know, versus moving forward and not having to like take a step, 2 steps back to like make a step forward. So yeah.
Will, if I take your comment and Nate's right now, and we just turn it back to the room, really, it was like what you heard today and what you brought in with you today, your own experience. What are these commonalities of success, of social, of ecological, but of momentum towards a integrated ecological and natural communities, right? That's where we need to go. And I think that there was a lot of that today. So could we just, call it out or raise your hand, or just what did you hear today that you thought was one of those principles? Yeah.
So just kind of going back to, I think, what Jason was saying, I think part of what I heard about success would be moving the finish line a little bit closer and working towards having everybody who's involved feel empowered. I think that like empowerment seems like a big part of how the big processes, the Klamath Dam, like that's how that worked.
I'm gonna take notes.
So I think one of the things, I've just been synthesizing is this: if we can empower, have all of the partners involved feel empowered, that will make moving forward to the ecological gains that we want to achieve easier.
No one else.
Common vision.
Well, I'm thinking that what I've heard, and we haven't articulated it, but is a synergistic level of effort. I think every watershed, we've said every watershed is different, one of you said that, and needs different approaches, and for us to figure out, each one has mentioned a different model with commonalities though. So like Betsy and I mentioned to each other, regulation does work in the grazing industry, but it has to be committed to. Or, Mary with her toe-kicking efforts with the landowners. So I think we have to think of the synergy of the whole toolbox, working with the community, working with the regulation, working with the funders, and in each watershed, figure out what does that watershed need? Like clearly the Shasta is different from Napa, which is liberal, relatively liberal and well-financed. The Shasta is not. Maybe that's where the North Coast Board has to step up differently. So I think synergism, we've all mentioned things, the lowering the time frame, but also increasing the time frame. When we're talking about landowners, I think the mistake that restorationists make is that the time frame actually needs to be pretty long. Both in Napa and in Marin, we started in the early 90s. kicking the toe. And that was with trusted resource conservation districts doing that work. So I think we need to revision synergistic efforts toward our goal, but our goal isn't really just restoring the environment, it's also restoring the communities to be a part of the environment, which is what the native people are always telling us. Oh, you're so wrong. You think that, wildlife doesn't include us, or the wild, you need to start envisioning humanity. So I think we need to start re-envisioning how we do this work in actually kind of a big way. And I think we've all said that, but we haven't pulled it together exactly.
I was going to make actually a similar comment. Hwang Creek always makes me think of this because you described it, I think accurately, as a bold move to but really all we're talking about is collecting some fish from one creek and moving them to another.
No one's ever done that.
100 years ago, that wouldn't have been thought of as a bold move.
No, it'd be thought of as a milk can.
But so why do we think it's weird? Well, we have this vision of wild salmon populations, but wild salmon populations are a myth. They were always in a relationship with indigenous people who managed them in some fashion. And we're in the same position today. We can't recreate a world where these salmon populations just exist on their own autonomously. We have to be in some kind of relationship with them. Our relationship has been to take them and squeeze their eggs out of them and put them in these concrete channels. What kind of relationship do we want going forward? And if to me, it makes more sense to move fish from one creek to another than to squeeze all their eggs out of them.
To jump on that, David, Jason, I think you said, and I totally agree, that goodness gracious, these are salmonids, they'll come back. They'll come back on their own. And they've proven that over, the geologic time frame. But we're not operating in geologic time frame, and we're on the brink of extinction. And so we do need to work on management actions to recover these species and move fishes to maintain populations, enhance resilience, and think about this as a meta-population dynamic.
Mark, want to make a comment?
Yeah, I hesitate to launch into this one.
You, Mark?
First of all, just a little historical perspective. A number of people refer to the hesitancy, presumably of agencies, to move these fish around from one watershed to another. But in fact, the agencies historically have been moving these fish all over. The only place that they haven't moved steelhead to is Antarctica. And there's been a lot of work done since that first moving around fish effort became a national effort. And it's the reaction to the realization of the consequences of moving these fish all over that you have now in place guidelines for moving fish. There are formal agreements between NOAA and the Department of Fish and Wildlife on how and where and when to move fish. It's not just a resistance to moving fish, it's in fact reaction to the movement of fish all over the planet for over 100 years. So just to put that in a little bit of historical perspective. And the other thing is, I'm fairly familiar with the Topanga situation because just coincidentally I was on the survey of Topanga in Malibu about 5 weeks before the Palisades fire when we did snorkel surveys and virtually counted every fish in both of those watersheds, so we knew pretty much how many fish were there. And we moved, well, I didn't move, but the department moved 300 of over 1,000 that we counted. So most fish actually didn't get moved. We're going to go back in the summer and resurvey both streams to see how the remaining fish did under the wildfire and rainfall events. But from a recovery perspective, which is what I do, I'm concerned about the preservation of not just the existing diversity, but the ability of the fish to pursue their own evolutionary trajectories. And we know from lots of work that we've done over the past 25 years and before then that these small populations, like along the Santa Monica coast or the Santa Barbara coast, are part of meta populations, and they wink out and they reappear at rates that we don't really understand, but we have anticipated in our recovery strategy. In other words, we've assumed that many of these populations are not going to be consistently persistent, that this process of fire, floods, droughts, etc., is going to continue to affect individual populations. But we hope that the strategy that we've developed with the help, of course, of the Science Center is in the long term going to allow enough of those populations to persist over time so that natural diversity is ensured and the evolutionary processes that these fish have been undergoing for the past 20 million years will continue into the future. So when you look at it from an evolutionary perspective and a recovery perspective, it looks a lot different than when you look at it from, well, there's a population that's now immediately threatened by an event like the Palisades fire, and we have to do something about it. If something was done about it, it was done within the guidelines that had been established before the fire, years before the fire, to move those fish in a way that's consistent with those guidelines. So again, I hate to even weigh in on this because obviously people have strong feelings about individual watersheds where they have substantial personal investments in, but we do need to look at the larger picture, and we need to look at things at a larger time frame in order for us to make decisions that make sense for the long term. I've said enough.
There was one comment this morning that built off of that you said, and it was pay attention to the process, not just the parts. And I think having that holistic thinking and awareness of what we're trying to achieve here is critical for that.
But we are.
Yeah, absolutely. Both. Yeah.
Related to the kind of themes and really envisioning, I just jotted down in the beginning of this the weaving together of different dimensions, and it sort of seems like that's kind of like coming full circle in the different dimensions here. And I just also kind of thought that, and wrote down that we worry so much about getting it wrong when we go out and we take the time to do that as scientists, to put everything in place, make sure we have better models before a decision can get made. But there, as all of these talks and case studies have shown, there's also a lot of value in taking that time to build the relationships and to kind of use that. But then also thinking Matthew saying that a 2-year postdoc, right? And the realities of, not everybody gets a chance to have an entire career working in a watershed or, with a certain group. So kind of reconciling those different dimensions, but also to the question of, a knowledge that we're never going to get it right the first time. We have a lot of knowledge to use, but with adaptive management, add in our toolbox, and the knowledge that folks in the past may have made some decisions about moving fish around, and there were some consequences that weren't known at the time. It's really easy to look back and say, putting in all these dams in all these different places was really bad, and now, but the people at the time, they needed water resources, right? So that the context is different. So I guess being okay with getting it wrong would be a theme that I would say, and that we're actually really experimentalists.
what wasn't my word? So it was the weaving together of the different dimensions, and that's the different dimensions of space and time, and also different dimensions or metrics of recovery or metrics of the things that we actually put into our models and can measure that have, you know, in that kind of nonlinear lateral thinking space that we're actually now okay with in the world, that, you know, we're not going to always go from point A to point B. There's, even if you have a general vision, that the goalposts may move. It might get shifted further, it might get shifted nearer, and just like accepting that and revisioning that we just have to have a more dynamic way of looking at the world, I guess, without waving more hands, yeah.
I've got another one. And maybe this is obvious in this group where everybody takes it for granted, but sort of restoring sort of natural or more natural form and function of streams, geomorphology, hydrology. I mean, that seems like a given. It seems like, but now there's a lot more evidence from population studies and monitoring that you can kind of say, well, yeah, like the 10 Mile Creek thing of like ridge to the estuary, doing lots of different things in different parts of the watershed, but building, you know, reassembling the ecosystem, and it seems like that's kind of safe territory now. Maybe that can go faster. Maybe that's not true.
I think a key part of the weaving together of a functional landscape and looking at process is humans as the fire apes, and us and how we use fire on a landscape. And I've heard it touched on a couple times here, but maybe not fully synergized in with how indigenous people tend landscapes using fire and the benefits that that has to river restoration and has on fish populations. I see fire as, I mean, it's an accelerant, right? And sometimes it's just by circumstance with relocation of fish following a catastrophic fire. But there's also an intentional way that we can be working with fire as an accelerant of landscape change, using prescribed fire, using cultural fire. And I've heard this too with large landowners in the Shasta and Scott watersheds of wanting to see fuel load reduction on their lands, and this being a potential win-win between a lot of landowners and restorationists, where we can go in and people feel empowered to be able to do fuel load reduction, use that material to build BDAs, you're clearing up, opening up cold water springs, you're now getting more cold water flow in. These things really can synergistically weave together from what I see.
You get that?
I did. You did too. Likewise, I think in the fire context, which we touched on earlier, is leveraging fire as the disaster and the response of that is an opportunity to expedite treatments, recoveries, leveraging bear and var NEPA to implement watershed scale restoration, expedite permitting. We're working with the Army Corps in New Mexico right now on extending the bear and bar treatments from the fire scar to the actual watershed that's impacted. So all those downstream reaches that are impacted by the post-fire debris flows are included. And so they've done a statewide exemption for that. But then finding those opportunities and then elevating those so they become national policy with the agencies, whether it be FEMA or US Forest Service. The early engagement, and I think one of the lessons, I live in New Mexico, so we deal with Rio Grande cutthroat trout. I've been working out there with the tribe who had a fire in 2011, and they still don't have fish back in their watershed. There's an opportunity because there's 100% fish kill, so they got rid of the non-natives, but they're trying to get the new ones in. And using that disaster and that recovery response and collaboration has been key, but they're still dealing with post-fire impacts to date. But it's also created new opportunities to integrate nature-based solutions, to elevate indigenous knowledge, and to show the agencies what the tribe wants and to elevate those priorities. So that disaster response context provides a lot more flexibility and a lot less rigidity and, in some cases, bureaucracy. So opportunities there.
Love that.
I have one quick thing I'd like to note. So I am really coming at this from like a modeling perspective and not so much like the product design or implementation or a lot of what these other presentations have been on. But when I see like this need for monitoring both before your project and then also effectiveness monitoring, I feel like I saw that in a lot of talks, and something that's really, really helpful, especially if you're trying to build something out where you're like trying to get a sense of how all these different projects work together or what might work from one for the other, is when you're collecting that data, have a plan for it, know where you're going to keep it, and please, please, please make it usable and standardized so that like when it's done, you can just plug it right in. And that's what made R2R, that's what made the modeling timeline so much shorter, is that people had already done all this work to have their data in a usable format, and you have like the same metric that's gathered across 31 different watersheds, and it makes it so much easier to compare or even integrate projects that are in progress into our modeling. So I think it's not like you have a ton of funding already, but like allocating some of that time and your energy so that it just makes it so much easier to use for the rest of time for any scientist who's interested. That would be my recommendation.
Excellent. And I would add to that, the ultimate metric is survival, which is the hardest thing to measure, but it's the thing for if you're trying to use modeling to help people make decisions, that's the fundamental metric.
Shara? Yeah.
I have a question that kind of takes a different trajectory, so if I ask it? Or
Yeah, jump in.
still, I don't want to like dissuade us from building on the guidance idea. But I just like, as we are all convened here, I'm like a natural convener. I want to bring people together. I love this sharing of lessons learned. And that's a really important thing so that we're not all like reinventing the wheel constantly. And so my question to the panel and to anybody else who has ideas is how can we continue these kinds of conversations, right? This is great. I love this. I love coming to SRF and to AFS and then those meetings, but if we're only having these sessions once a year, once every couple years, you know, are there ways that you have experienced where there's more successful opportunities, more common, you know, regular opportunities for knowledge exchange that work and maybe work for people who are having travel challenges these days, and like what opportunities do we have for building on this kind of conversation and continuing it more regularly?
I have a few ideas. So like first, this session like started, like they mentioned the staff retreat we had. We had an idea where we were like, let's have this reverse panel where we talk about the work we're doing and then have the Science Center ask staff questions. So whenever people are getting together, use that. I think also there's limitations to this, but having a representative from each entity, like where they come together and talk about things and then report out to the rest of their organization. And not trying to create more work for people, but newsletters are awesome where like we just say, hey, this is what we're doing, like little snippets, you know, and exchange those ideas that way so that folks aren't having to worry about travel or making meetings, you know, like it goes unsaid hybrid, like when folks are coming together. Glad you're doing the video. But yeah, newsletter is going to be really helpful in my opinion.
What was the increased adversary support? You mentioned having a panel earlier with ag users being present. I think having a representative from the wine industry, having someone from the ranching industry, and having those folks here firsthand and be able to translate that back to their respective cohorts. BLM is the same way. He's like, we're trying to get process-based restoration to these landowners in Colorado, and we don't do very well when we say we're the government, we're here to help, of course. But he says, if I can get one landowner on board, it permeates and spreads.
Spreads across fence lines.
Yes. And it's slow at first, but once it starts, they start listening to each other, and they all want a part of the action. And so how do we increase that? The pace of that is what I'm trying to figure out. I think proper media forms. I'll send you a new Living with Water documentary where they talk about this. But it's a challenge. But once you have the support of that adversary, I think that breaks a lot of barriers down as far as the speed at which stuff gets done.
The Mierau Coalition was one of the great inspirations for the creation of first the Central Valley Salmon Habitat Partnership, which was the seed that created Floodplain Forward and had a big effect, I think, on R2R as well, which was just this idea of the radical center, of really of the radical act being to know each other, to come together and to find collaborative solutions. And that when you do that, I think that we all can be completely excused for feeling hopeless at times, especially when you look at the global trends in environmental outcomes, right? And yet, it seems that when you actually get down into these systems and start looking at the expertise that's there, the people, what they're willing to do, there's almost always incredible reserve of this, not just of hope, but of innovation to make things work. And so, Shara, what can we do, right? That was the question. How do we keep these conversations going? One of the things that we've been trying to do is figure out how you synthesize something like this. What is is there a white paper? Do we do a peer-reviewed paper? Can we send these notes back around to everybody? I don't know. It's a great question, but it's something that we're struggling with.
One thing I could suggest as an academic is inviting students into your organizations to work between organizations and academic institutions. I think students gain so much from that experience, but then it also benefits the host organization and just sort of the entire learning process. Students can be just great conduits of building connections. It helps them build their careers, but it also helps everyone stay more connected. Like, I have had more meetings with probably more people in this room because my students have reached out to people saying, like, I need a field site in the Russian River or like whatever. And so it's like, okay, like, let's make those connections to make that happen. And then those turn into lasting collaborations. Or the 10 Mile is a good example as well. Like, we start talking and then those connections sort of are maintained. So I would encourage everyone, and we have a really close relationship with NOAA Southwest Fisheries Science Center and UCSC, but building and the Nature Conservancy, but I would invite anyone to reach out if they want student engagement in their organizations and projects. I think that's a great way to build these connections.
Betsy, yeah.
So I'm going to put in a plug here. I have the great privilege of doing restoration in the community that I live in, and I am working with my neighbors, and we might go head to head, and then their mom gets sick and we bring the potluck over there and it changes the story. And so there's a lot of agency representation here and big NGO representation, and I would really ask you, if you want to figure out how to get stuff done on the ground, to figure out how to empower the local groups that are trying to do the work. Rather than, I want to, this is an industry, and I'm going to get a little, there's limited dollars. Everyone has to support their overhead, and there's a tendency to want to bring the dollars into your own organizations and run your own people and your own projects. By empowering the local organizations, where every single person that works in my organization lives in the community, has kids going to the school, we have kids coming into our programs, and we have been doing this now hard on for 15 years, and we're starting to gain that traction. So if you're looking for solutions, really, I love that there was going to be a stand-up organization in the eel. It has to, particularly in rural communities, they're close-knit, they're integrated, and the people who are living and working on the land do know it better than anyone coming from the outside. They can walk up and down the river and tell you what needs to be done. Now, whether or not it's going to get done, that's a different question. So that's my suggestion for moving towards success.
Anything else?
So early on, I asked the question about scientific tools, and I think, Steve, you were the one who said that's something that NOAA helps us with. So I think we need to make some statement about some continued support of places like the Southwest Research Center. We're focusing on community, which is essential, but without the proper scientific tools, we are going to get it wrong, just like removing the wood. And so I don't want us to lose focus on the fact that we do need the science. We need both state and federal, and local governments to support really good science. So I think, personally, I need to make a strong statement that I need the science to do my work. And then, you can work with the communities, but if you don't, the last 20 years we've seen so much seminal research and information that's helping us know, fish rear in non-natal streams, all these things that we didn't know. So I just want, personally, I think that we cannot negate the need for continuance of, and Tommy mentioned, long-standing science in watersheds.
Sorry to be, I'll stay another minute. I'm Jacques White, I'm from Seattle. I work with Shara at an organization called One with the Kings. And first of all, I just want to say I'm super impressed to see all the great and creative and energetic and sort of surprising work and the scope of the work here in California. I came down here on a sort of a fact-finding mission, and this was a really great opportunity, this workshop, to see that, so thanks so much. I kind of come away with 4 new H's to do with salmon recovery. One is who, that's a H-sounding word. The second is how much. The third is how fast, and the fourth is how'd you do that? Because I think we're all really familiar with the hydrology, habitat harvest, hatcheries. But I think where the salmon recovery movement is now is how do we get to scale? And so I was out in the field yesterday with Jacob and saw the notch in the yellow floodplain and a weir that is designed to take salmon. They're getting trapped in sort of a blind slough network and put them someplace else. That's really amazing scale-sized work, flooding farm fields for a period of time, allowing that to happen now. That's the kind of thing we need, and we need to look for those across the entire range. Shar and I are working with Jason on trying to develop an approach that looks from California to the Arctic at what salmon need. And I recognize that it seems kind of hopeless right now to increase the resources, the sort of how much part of this for the work we do, but we can't give up on that. We have to make sure that our voices are heard. And I think the who part is, I know diversity, equity, and inclusion is not a really popular scheme right now, but this room needs to look like California. It needs to look like the people in the West Coast, and we need to build support at that scale. We need to think about scale in terms of who's on our side, who supports this work, who understands this work. So there's a huge sort of educational component to this, and I think part of what, in thinking about launching a salmon initiative that is to get to scale, to be successful, to address how frustrated those of us who've been doing this for a few decades are at the lack of progress, and understanding that our work isn't occurring at the rate and the amount that needs to happen in order. I'll just speak, not for, but try to channel my tribal friends in Washington State who have treaty rights and were promised in 1999 that by working on Chinook recovery that they would be able to fish and don't worry about it. You can't fish now, but you'll be able to fish in the future. Well, they're still not fishing. And I'd say that the Chinook populations in Washington State are still about 10% of recovery goals on a whole. So there's a whole lot of more work that needs to get done. And I just encourage you to think about how we can get to scale, not just in our projects, but in the entire enterprise and the volume and rate of work. And we're going to try to coordinate. I think Shar is asking, how can we continue these discussions and think about that element while we're thinking about the technical elements. But anyway, thanks so much. This is a great workshop. I really am pleased to be here and appreciate all you do. Thank you. Anyone else? This is a great discussion.
I'd like to suggest we close with a comment that I'd like to invite from Jason, just asking what it was like in the Connegan River to have 750,000 fish come out. What was your community response to that? Like, let's close on that thought, right?
Well, I'm hesitating because I'm not sure that it's my place to comment on that.
But I will qualify a comment, how's that? In that, as it's not my story, it's not my organization's story, but it's one that we are proud to have had a really small contributing part of. And it is awesome. It is unbelievable to see it in a place that I think most people, even in the optimistic world of salmon stewards, would have said, even if you do well, it won't be that good. And it has surprised people, and it has changed the world view in the region that we work in on what is possible. Because if you know the geography of British Columbia at all, you would not select the Okanagan as one of the places that seem to have winning conditions, especially winning conditions at that kind of turnaround. And yet, through the leadership of the entities that really own the story, it has happened. And you think, wow, if you're in British Columbia and you see that they could do it there, and even in the Cowichan, they're doing it there, and the Cowichan has its own challenges. If you can do it in those places, we can expect to see success in many places, if not most places, to some degree. So I think that would be my summary of the Okanagan story.
Yeah.
All right, well, thank you, everyone. And it is our plan to synthesize this into some kind of paper that sort of talks about the issues, and I would invite people who are interested in that to be part of it. And the goal is to keep these kind of conversations going. What would success look like? How do we get there before